about a lot of staking topics. Actually, everything's a staking topic. And the people that are here are going to get to experience the Mobile Museum. We have food all day. If you're not here, come join us if you're in town. And we'd love to have you. We want to just set some ground rules for what to expect during the day today. It's pretty clear once you're here what to expect, but the venue in the middle is the auditorium. This is the auditorium. The foyer is where you can meet with our sponsors. We have 6 great sponsors here, which you can see on the screen. Lido and Bitwise, as well as Aztec, Nimbus, Sigma Prime, and Rock Solid. So thank you to all of them for supporting this event. It would not be possible without their support. You can meet all of those teams outside in the foyer all day long. Speaking of all day long, after we have the talks throughout the day, we will then, around 7 o'clock, we'll have dinner served, as well as an open bar for anyone here, and the more social hour at that time. We're also going to have the ability to view the museum. So without further ado, I will give up the stage to our first speaker, and that's Kody Sale. So,
hello, hello. You have a clicker? Very nice. Oh. All right, there we go. All right, thanks for the intro. I'm Kody Sale. Yeah, I probably don't look as good as Vitalik on stage yesterday, but I'll try to keep you guys entertained. Currently leading product marketing at Obel. Prior to that, built a little protocol on Ethereum called Smoothly, which was an MEV smoothing pool for solo stakers. And before that was just a community member who was passionate about home staking. So I guess I'm one of those guys who just like started from the bottom, now I'm here. Oh yeah, and today we'll be talking about correlated failures and Ethereum. So from a high level, what are the dependencies among a bunch of node operators that could either bring the network down or things like that. There are 3 types we'll be looking into. So yeah, if you look at this heat map, it kind of shows you the geographic distribution of nodes on Ethereum today. Specifically, like the East Coast in the US and Western Europe are definitely hotspots. And so we'll be looking at cloud failures, stake centralization, and client bugs as 3 different types of correlated failures today. So for cloud failures, this is the distribution of consensus layer nodes on the network today. Unsurprisingly, hosting nodes dominate with roughly 61%. Shout out to Ethernodes for always having amazing data that we can pull from. But yeah, this isn't really surprising because a lot of the professional node operators are running in cloud, and they run redundant systems so that they also run DVT, so you can fall back in case something happens. But I was kind of surprised that residential is still roughly 35% of the network. So even though solo stakers only account for maybe between 3 and 5% of the stake today, we account for a lot more of the nodes on the network. And that's just a testament to the impact running a node at home can really make. And so if we break down the hosting nodes, Amazon's pretty dominant with roughly 30%. And they don't have a third of the network, so that's pretty solid. But that's closely followed by I'd say 2 of the top cloud providers and bare metal providers that solo stakers use, which would be Hudson and OVH. Like I run my node at home, but I also have an OVH node on bare metal just as a redundancy feature. All right, so yeah, while I was actually preparing for this talk, we got to test in prod what happens when one of the biggest regions of AWS goes down. So on October 20th, 2025, AWS, I think it was US East 1, went down. It was like maybe a 14-hour outage. And yeah, crypto Twitter turned into a bit of chaos. From a retail user perspective, it looked like the chain was down, you couldn't access anything. that cat's supposed to be going like this, trying to get a transaction in the network. So yeah, from an optics perspective, it looked really bad. But most people in here know that actually it went really well for the network itself. I'd say, based on those two charts before, roughly 18%. Hello? Roughly 18%. You guys still hear me? All right. Roughly 18% of Ethereum runs on AWS, but consensus participation only went down by roughly between 1% and 2%. And so yeah, that was pretty amazing. I was actually, before this outage happened, I was thinking that would have went down by a lot more, and that like missed blocks would have been a lot more as well. But it kind of speaks to just the maturity of the staking ecosystem and how incentives are actually working. And that a lot of the node operators are running redundant infrastructure like Vouch, DBT, and other backup systems. But yeah, other things went less well. So you know that like a lot of decentralized applications maybe they're Dino, they're like decentralized in name only. And so a lot of the dApps front ends went offline, and so you couldn't access any of your favorite decentralized applications to get your transaction in. And even if you could access the application, if you're using MetaMask with the default settings, then you're using Infura, and Infura's mainnet RPC went down. And yeah, we kind of got wrecked. Like Coinbase went down, Robinhood had an outage, and a variety of other RPCs just went offline for an extended period of time. So it was one of those moments where we've had them over and over again. When there's like a cloud outage, you can't access the network, and we always say we're going to do better, and then we never do. So yeah, it's a kind of a repeat of history. But the good part is, we all know Ethereum just kept chugging along. And yeah, it didn't even skip a beat. All right, next we'll look at stake centralization. This was originally called stake centralization, not decentralization, because we've actually improved so much from a couple years ago. So if you remember, 2022 and 2023, Lido was getting, close to 33% of the network, and the community, we kind of turned to the social layer to call on the ecosystem to keep the network decentralized. Famously, Danny Ryan jumped on a Bankless podcast and was like really aggressive about the community decentralizing stake. And it's still up for debate, whether or not Lido deserved that hate. They run multiple operators, but I think the network's better for it. So now today, Lido's at 23.7%, but not only did they reduce the share of the network, they implemented new modules like the simple DBT module, which moved them from 36 node operators at the time to I think over 250 after simple DBT. And also, now they have the permissionless CSM module. So yeah, Lido's, moving in the right direction, absolutely, and onboarding a ton of node operators. And yeah, it's great for solo stakers because, like in CSM, you can earn a lot more rewards than staking solo. And Lido wasn't the only one. So because of like this social layer push, EtherFi also had a EtherFi solo staker program, and brought on over 200 node operators in that program as well. Yeah, we could probably all use a green chart today. It's been a rough couple weeks. So this is the state of the network today as far as stake goes. From a Nakamoto coefficient perspective, it now takes 3 entities, assuming Lido is a single entity, to hold hostage finality. And before it was really, Lido plus 1 small entity. So we're definitely improving stake decentralization. Yeah, it's more decentralized than ever. So although this talk, sounds kind of bearish, like correlated failures in Ethereum, I think as a community and as a whole, we've improved a lot over the last couple years. And what that tells me is the social layer really the push had lasting effects, and just speaks to the testament of the impact the social layer can actually make. All right, so the third type of correlated failure would be like a client bug. And now people are, I guess, correlating client bugs with this supermajority risk. So this is an old chart. You can tell because it looks like a chart from like Excel in 2012, even though it's pretty recent. In January 2022, Geth, had over 80% of the network, and Prism, was almost at 2/3 of the network at 60%. And this was another time when the social layer actually kicked into gear and was like, we can't, this was before the merge, but after the Beacon chain launched. And I think the goal was really to get Prism and Geth below that, at least 50% before the merge happened. And really, that's what we did, right? There was a big push for client diversity, adopt minority clients to preserve, or to help out the network. And, it was really impressive. And so today, we're looking a lot better. Although, Prism's down now to 22% and Lighthouse jumped up to almost 50%. So I think it's always a work in progress, right? Like we can always improve client diversity. Like we should all be moving, to some Lodestar, the Nimbus, the Aragons, the Besus, the Reths. But, I'm confident that as a community, we can definitely make that happen. And just like the previous issue, the cloud outage, we also got to test this in prod. So during the Holsky hard fork, or the Pectra hard fork on Holsky testnet, we actually did see the supermajority bug happen, and the network justified an invalid block. And yeah, it was pretty chaotic. We'd been speculating for a long time what would happen in this case. And yeah, it's basically like doomsday, worst case scenario. Eventually the network got to finalize, but yeah, a lot of the validators were slashed, and because of that, the exit queue extended to, over, I think it was 18 months. So if that happened on mainnet, yeah, I'd say just ETH we're just going to 0. But, it would be ugly. And so what are ways we can actually defend against this? So first, I'm sure a lot of people in here, if you're at the eStaker event, are running a node at home. And so if you're running a node at home, and when the cloud goes down, you can definitely use your own node as your local RPC. That's probably the easiest way to get your transaction in. But if your dApp front end's down, then maybe you need to pull up like Forge or something and use a CLI tool to get it in. But still, you can definitely get your transaction in through your local RPC. Next is run a halting mechanism. So after the issue on Holsky, at Obel, we started thinking about, since we're using a multi-operator architecture, we could actually compare, the head of the chain among the nodes in that cluster. And if the nodes didn't agree on what the head of the chain was, or if it forked off, then that cluster could actually stop attesting, and you would have to manually intervene. So we tested this on Fulu, and it worked really well. So that is one way to protect yourself from this like doomsday scenario. And I know other teams are also working on things like that as well. The next would be stake with multiple operators. Don't put all your eggs in one basket. Find operators that run multiple clients. And the last would be choose a minority client. So instead of the Geths and the Netherminds and the Lighthouses, pick a, all these clients are really mature at this point in time, minus the maybe newer, the few newer clients. But yeah, run a minority client, don't be part of the problem. And speaking of like the minority client, if you're running DBT at Obel, we've always pushed for this like end-game cluster architecture, which is multiple operators in various regions around the world, also running different client implementations, and then implementing this stake or this chain halt feature, so that you're diverse around the world. You're running various clients with different operators, but there was always like this single point of failure in such that Charon is a middleware, so it sits between your consensus layer and your validator client, but there was only one implementation. And you have to start somewhere, so that's what we did. But recently we released the DB spec and invited the client teams and other builders in the ecosystem to start writing a second client and a third client using the DB spec, so that Charon is not the only single point of failure in a DB cluster. And over the weekend, we announced at Staking Summit that Nethermind is the first team that's going to be building this. They're a longtime partner of ours, did research in multi-party computation a long time ago, and are definitely, they've been helping us with security audits along the way. So yeah, happy to get Nethermind on board, and yeah, looking forward to like the true endgame cluster architecture, which is a multi-client at the middleware layer as well. All right, well that's it from me. I'm Kody on Farcaster. If you want to hit me up on Telegram, Kody Sale. And I think we have time for questions, probably.
We have about 5 minutes for questions. If anyone has questions from the audience. Actually, I had one question myself here, which is, out of the scenarios that you proposed, are there any that you see as most likely in terms of probability?
I thought that the client bug issue was going to be near zero. And I'd say that it probably is still near zero, but that jumped up much higher than I expected. But cloud failure still seems like the most possible outage to me. Because it's happened over and over. There's a precedent that like clouds will go down, but luckily, like the network itself just keeps going, and from a retail perspective, users think that they can't use the network, so they feel like it's down, but most of us know that it's chugging along.
Excellent. Any other questions from the audience here? All right, well, Kody, thank you very much for the presentation here.
Yep.
And good morning, everyone here. My name is Ken Smith. I'll be your MC here today. As Jonathan said, it's going to be just an amazing day of presentations, all focused on staking. And I'm very pleased to introduce Dima here as our next speaker here. Dima, of course, is with Lido, and he's going to present on the home staking landscape with Lido CSM. So welcome.
It's not over the mic. Hello, and while we're waiting for here we go. It's kind of extended. Okay, so today I want to talk with you about a topic that might seem kind of obvious, especially for the audience of ETH Staker event, though the home staking landscape might be slightly wider than you think, or it might have changed since you last time checked. And for sure, one of the most noticeable changes over the last year was Lido CSM. So let's get straight into it. And before we will get there, we need to agree on what home staking means. And I've been involved into multiple discussions on what's the difference between solo staking, home staking, whatever other staking is. And I think this picture by ETH Staker is the best way to describe different types and varieties of staking. And we want to specifically focus on home stakers for one particular reason. Even though independent operators are definitely all important for the network, home stakers combine two crucial aspects. First, they still control their validators at full scale, and second, they run validators exclusively from home, or not exclusively from home, but mostly from home, which makes them kind of better than remote stakers who are using commercial infrastructure, and kind of better than solo stakers who are again using virtual machines or whatever else. By better, I mean from the point of view of Ethereum network. Though most of the options that I'm going to be covering today are available both for solo and remote and whatever other else. But I personally think that the more home stakers, the better. So I highly encourage you guys all to home stake. Yeah, because I mean, I do home staking personally, and it's fun. So now we need to look at what are the options for the home staking. And even although it is just a single line, a definition that you run Validator from home, actually there are a lot of different options. And the first group of options is the hardest path. It's what I call solo staking from home, where the picture is mostly like that. It's you're a home staker, you take your 32 ETH or more, you put it into the protocol, run Validator, boom, that's it. Maybe with a small addition of something in the middle. So what are the benefits here? The benefits is that in most cases, it's just you and Ethereum and nothing more or not much in the middle. But on the downsides, you are basically not getting any cool things. You still need at least 32 ETH. You get default staking APR and uneven rewards, which for me personally is not a great thing, and you face a full slashing risk. So what are the options here? The most notable here, from my perspective, are these three options. Just solo staking from home, Stakewise Vault, and Lido Vault. Let's break them down. Solo staking from home, simple and easy. No protocols involved, no nothing. You take your 32 ETH, you stake it with the Beacon Deposit contract, you run validators, you get rewards. Cool. And the best thing here is that, again, there's literally nothing in between you and Ethereum. On the other side, you are not benefiting from any other application layer or middleware that you might benefit from that we're going to cover later. The next option involves a bit of a middleware, though not like a lot of a middleware, honestly, which is Stakewise Vault. Here, you still need your full 32 ETH or more, because no one will bring you money. Protocol will not allocate funds to you. But at the same time, you have the ability, and I'm pretty disappointed by how it's all turned out that I'm closing benefits, so I would rather close QR code. Give it a second, you all know where to find that. So the main benefit here is that you can mint OS ETH, which is a liquid staking token, which you can then use to borrow ETH and do a bit of a leverage home staking, which might be interesting. You also get native OXO2 support, and you can attract stake from your friends or the others thanks to the architecture of Stakewise Vaults. What's on the downside here is for sure that, again, protocol will not allocate ETH, and you are now bearing the, even though small, but protocol risk. The other option, the option that is kind of not live yet, but will be live soon, and it will be the case for a few more options that I'll be covering, or other conditions or so, because why shouldn't we talk about things that are going live, like in January, for example. So with Lido Vaults, you get almost similar things and benefits like with Stakewise Vaults, with the difference being that with Lido Vaults, you can mint STETH instead of OS ETH, which might be considered as a more integrated and more like a token with better liquidity. But at the same time, you have limited ability to attract third-party stake, because the default architecture of the vaults, at least at the day one, is less about attracting stake from others. It's more about one depositor, one node operator. Speaking of cool things, there would also be custom rates for operators that are willing to identify themselves, so you will be able to mint more STETH against your position. But again, it's a matter of choice, and I thought that if you have one option, why not to cover both? Next, this is the thing, this is the set of options that I personally like the most, because in my personal opinion, this is the most feasible, interesting, rewarding, you name it, way of home staking, which is home staking with liquid staking protocol. Here, instead of using your own money or money of your friends or your mom, you can use just a part of your money and the rest will be allocated by the protocol. This weird scheme kind of describes that. So the benefits here is that you can now start with way less than 32 ETH, which is important, especially for those who haven't been in staking for ages and who are currently thinking about starting staking. Like, imagine you have 10 ETH. Well, the first set of options is not for you. You will just not have enough ETH. This one is for you. You can also get higher if you provide like only part of validator stake. should slashing happen, this part will be slashed first. But at the same time, you are running validators, so you are the manager of this risk. What are the most notable options here? It's for sure Rocket Pool, Stater permissionless, Lido CSM, and Puffer, though Puffer permissionless is currently disabled, so we would not cover it in details. Let's start with Rocket Pool, the most well-known and by far the largest permissionless protocol. What you can do here, and what's cool here, is you can start with just 4 ETH. Again, same as with Lido ST Vaults, you cannot do it like today, but you will be able to do it in January, and why not to mention that. You can get APR multiplier of 1.35, given that you're not touching RPL, which means that you will get 1.35 times more rewards on your bond provided. You can choose between individual or partially socialized rewards, which gives you a cool optionality. Rocket Pool is definitely a battle-tested protocol, and you get access to such a cool thing as Rocket Pool Smart Node. On the downsides, I would also start with the Rocket Pool Smart Node, because even though it's a very cool thing, at the same time, crucial interactions with the protocol are mostly done through Rocket Pool Smart Node, and if you're not a console guy, well, it might also be a downside for you. You will for sure share protocol risk, and it's worth mentioning that options that involve a governance token or RPL staking are facing RPL price risk, but we all know about that. Luckily, it's no longer mandatory, so you can just avoid that and remove it from the slide. The next option, Lido CSM. Probably the most recent home staking protocol, at least in my overview. I am not aware about any others popping up. So here you can start with as low as 2.4 ETH or even 1.5. If you get identified as an independent community staker, you can get APR multiplier of up to 2.38, which is absolutely insane. You get fully socialized rewards, no options here, though the rewards are socialized not just over CSM, but over the whole Lido protocol, so kind of good. The protocol is also battle tested. You have this concept of a performance threshold where if you're kind of dropping like a little bit in performance, no effect on your rewards. If you're dropping below the threshold, well, you will skip the reward distribution period. Might be good for someone. For me personally, it's very cool, and like Spanish blackout that we saw at a couple of months ago, right? I still got rewards. And ICS system, probably the best thing and the most unique thing about CSM is the system where you as a home staker can apply without disclosing your identity, without doing KYC, just by on-chain data and a bunch of like stakers lists or data available off-chain proof that you have enough experience in Ethereum validation and you are indeed an independent person, and get special conditions. On the downsides, protocol risks and a notable competition for stake, because stake allocation queue in CSM has been pretty long for a while. Now it's just 500 keys, but again, who knows how long would it take for it to go bigger and when it will be allocated. Next up, Stater permissionless. Here would be kind of faster because Stater is, let's say, Rocket Pool inspired or a Rocket Pool fork-like protocol, which means that Stater shares most of the stuff with Rocket Pool, at least early stuff, with the difference being that here you can already start with 4 ETH and you were able to do it with 4 ETH for a long time, but you need to use mandatory governance token stake, but at the same time you have SD utility pool that allows you to mitigate this risk and so on. The main thing worth mentioning about Stater and what worries me the most on the downsides is that there has been no updates on the permissionless roadmap and on the protocol development in general. So maybe I missed that, but for me it looks like that there's not much activity there, though the protocol is still live and you can still register a node, and apparently they are depositing validators, so why not? Cool option. Next thing, and this is the thing that is not that frequently considered as an option for home staking, is home staking with decentralized validators. So instead of getting in touch with protocols or doing all on your own, well, you can have a decentralized cluster or squad with your friends. The benefits here is that you can, first of all, reduce ETH requirement, and secondly, get better slashing protection and offline protection, which is important, which makes a lot of people anxious about what they're going to do if my validator will go offline. Well, with DVs, you are less likely both to go offline and to get slashed. On the downsides, you are now sharing DVT technology risks, and you get default staking APR, and in some cases mandatory, in some cases optional, you have to pay DVT provider fees. What are the options here? Mostly 3 of them: Obol, SSV, and SafeStake. I haven't heard of any other technologies available on the, currently on mainnet, so let's cover these 3. Let's start with Obol. Here you can start with something like 8 ETH, assuming that you have a cluster of 4, 32 divided by 4, you start with 8 ETH, cool. You get improved slashing and offline protection. You are definitely using a battle-tested protocol, and the thing that I like the most is that Obol is a DKG native protocol. So by default, you will be asked to generate validator keys for your decentralized validators, not in a way that you had a key and then you've split it, but in a way that the key is originally generated as key shares so that the original key never existed. That's really cool. On the downsides, again, technology risk, no capital multiplier if you're just using decentralized validators. Probably the main downside is that with Obol you really need to have friends to run cluster. I mean, you cannot just find them anywhere. You need to have some friends unless you want to run cluster on your own. And you will have to pay Obol collective fee in case you want to get incentives. And if you don't want, you can emit this thing. Next, SV. Here, the main difference would be that you can form a cluster without friends. You can even form a cluster without even being a home staker, just selecting operators at their explorer. Though you will have to pay SSV fee no matter what. It's not an option, it's just a mandatory thing. And the cool thing here, and that the thing that Alon is going to tell just in a few minutes, I believe, is more about based applications that can be a kind of additional vehicle for getting additional APR just by running SSV. The last notable mention, SafeStake, and here somewhat similar to Stater. SafeStake is kind of early SSV fork, so it shares most of the early features with SSV. The downside here is that there's very few mainnet validators with SafeStake. But the cool thing here is that literally all of SafeStake validators are currently in Lido CSM, which makes me personally proud. This whopping 8 validators. Anyway, the final option. And I specifically did this picture rather weird so that you will understand that this is a complicated option. Though, maybe the most appealing is when you use DVs with liquid staking protocol. And what are the benefits? Basically, the benefits here are all the cool things, so you get the best of all worlds. So from working with a bonded staking with protocol and DVs, you combine it together, boom, you have a cool thing. On the downsides, you basically do the same, but you're now combining downsides. Why? Because you're now sharing 2 risks, both DVT technology and the protocol, and you should account for that there's now a lot in between you and Ethereum. In most cases, you will have to pay DVT provider fees, and I'm not gonna lie, and I'm not gonna ignore this thing, but support and maintenance of such a setup might be tricky for those who are not super experienced, so keep it in mind. Speaking of options here, well, you can basically combine any bonded staking protocol with any DVT technology. So I will not cover all of them. I'll highlight one, because to my knowledge, this is the most popular option, or one of the most popular option among home stakers, those really running nodes from home, which is Lido CSM plus Obol. And here, the things are getting insane. You can start with 0.6 ETH or even 0.4 ETH per validator, which is basically nothing to start your validation journey. You can still get this crazy high APR multiplier, socialized rewards, use 2 battle-tested protocols, performance threshold, slashing protection. I can speak about the benefits very, very, very long. But you should also consider downsides, because again, 2 protocols are now in between you and Ethereum, which is Obol DVT technology and Lido protocol. In most cases, you will have to pay Obol collective fee if you want to get incentives. And again, it might take a while for you to get deposit while waiting in CSM deposit queue. So that was pretty much it about home staking options. I hope it wasn't that boring, and some of you discovered something new or whatever. But the one thing you should remember after this talk is that no matter what you are using, no matter which approach you are taking, if you are home staking, you are making Ethereum better. And home staking landscape is waiting for you, even better, even more flourish. So if you haven't been home staking before, right after this conference, go back home and start your home staking journey. Thank you so much.
There. We have about 5 minutes for questions. Let me ask the audience here up here. Okay, I see a question. And I'll have you stand up and pass the mic down here.
Thank you for the talk. That was very comprehensive. But I think one major thing missing that I'm sure there's good reasons for this that you didn't mention is like tax implications. And I know you're not an accountant. I know every jurisdiction is different. But like that's a major consideration for people because it could be like 30% of your yield. So I was wondering if you could maybe just touch on anything you could mention about that, and like, specifically like if you're going to be like a Lido, CSM, like if you got appreciated ETH, like if you put it in there, it's a huge unknown of whether or not you get taxed. You have like brought up your capital, your cost basis, which could be a huge taxable event. Like I know like specifically, I know you like can't give definitive answers, but if you could like say, like if you kind of give us some kind of like plausible deniability that you're actually thinking about it, or you understand that like we have to deal with that.
Okay, so the question of taxes is also a question that is specifically tied to your specific jurisdiction, to your way how you approach that. So I intentionally never mentioned that in any option because any option might be tricky here. Some say, for example, that this withdrawal sweep mechanism that we have on Ethereum network for OXO1 validators is great for tax applications, while others saying that it's absolutely terrible and they have to file like each and every increase in balance. So the options are different. If we speak about CSM specifically, again, I'm not saying that it will work for a lot of jurisdictions, but the mental model that we had in mind while designing that is that technically speaking, when you put your ETH as a bond into both Lido CSM and I believe most of the bonded staking protocols, there are now two counterparties that are able to submit claims regarding this bond. It is you, so you can say, oh, I want to get my bond back. And it's the protocol and the rules of the protocol that might apply that will result in seizing the bond. And since the rewards in CSM will never land automatically at your wallet, we thought that the best we can do here is allow you to choose the moment where and in which amount you claim rewards, though, again, in any jurisdiction, people might have different opinions on if it works like that or not. And again, I would highly recommend you hiring a good tax consultant. And what I can do, I can help from the technical side to explain like why, for example, I personally think that if your ETH is provided as a bond into CSM smart contracts, you cannot be deemed as a unique owner of this ETH because, again, this ETH is clearly a subject to a penalty should there be a violation or outage or whatever else from your side according to the protocol rules. So that's probably the best answer I can give regarding taxes. Any other questions, folks?
All right, I don't think I see any other questions there, but Dima, thank you very much.
Thank you.
So excellent. For the folks that are viewing on the live stream as well, too, we are keeping track of the chat, so feel free to add questions in there. And we have our next speaker ready to go, I think, over here. With SSV is Alon here. And Alon is going to give us a talk today. And what's the title of your talk here as I pull it up here?
We're presenting Compose.
Excellent. I'm looking forward to this one.
Awesome. Hey, everyone. My name is Alon. I'm the CEO of SSV Labs. We are building Compose, which is an interop layer that brings synchronous composability to Ethereum. We've been also the team behind SSV Network, which I'm sure a lot of you know. SSV Network is the largest distributed validators protocol on Ethereum today, with roughly 5 million ETH staked. The second largest protocol on Ethereum in staking, with 14% of the total ETH staked in Ethereum, and with amazing partners building on top of us. And of course, Compose is actually building on top of the SSV validator set. And we'll see in a second how that works. When we, as Ethereum, started to talk about scalability, actually the original plan was to do Ethereum sharding, which is basically kind of split up the state of Ethereum into different kind of independent chains, if you will, and each chain has its own way of building their blocks, and somehow magically Ethereum will combine all of those chains, including some kind of interop or composability between those chains, and that will be the way to scale Ethereum. That's been kind of the dream vision behind Ethereum for quite a long time. And a few years ago, Vitalik and others in the EF kind of realized that doing sharding is very, very difficult. And so we pivoted towards a roll-up centric roadmap, which has some of the characteristics of shards. For example, they do settle on Ethereum, they do derive their security from Ethereum itself, but without any interop, or at least built-in interop between them. And of course, that created what we know today is kind of the roll-up centric roadmap with many, many different roll-ups. I think today we have roughly 100 plus roll-ups running on Ethereum, and a bunch of them continuing to kind of join, and even some L1s are turning into roll-ups. But it also created fragmentation, right? Each roll-up, even though they settle together on Ethereum, still has its own state, and by many consider its own chain. And so dApps are not necessarily can call one another, contracts cannot call one another, liquidity is fragmented, and of course users are kind of coexisting on a bunch of different roll-ups at the same time. So it feels like Ethereum is not really one piece, right? It's kind of Ethereum in the middle and a bunch of economic islands around it, which I think kind of goes against what Ethereum is trying to achieve. But also we should look back in history with kind of looking at similar architectures like Cosmos, for example, and see that as a warning of what could happen if we don't really focus on the way that roll-ups in between themselves can actually interact. There are a few kind of quote-unquote bridges that were built along the way, but none of them are really doing the job of kind of composing together or making Ethereum this one big continent, if you will, together. One of those solutions is asynchronous message passing, which is essentially a nice way to say that you can pass messages between roll-ups through some kind of a trusted committee or oracle, but those messages, you don't have any guarantees on when they will be delivered, or if they will even be delivered. And if you want to compose a bunch of different things in one transaction or one go, you need to do it block by block, transaction after transaction. This is the kind of the asynchronous property of those messages. And also, most importantly, the latency between them is quite big. And so in terms of composability, it's not really a great tool to use. Another type of solution are intents. Intents actually takes a completely different approach, where the user describes what they want to get, and then off-chain intermediaries kind of try to figure out how to execute. So, for example, swaps and cross-chain bridging works similarly. So I'm, as a user on chain A, I want to get the same token or a different token on a chain B. I say how much of those tokens do I want to move, and what is the fee I'm willing to pay. The problem is that it's heavily based on intermediaries and liquidity, meaning that ultimately the types of use cases are limited, because if you make very complicated use cases, you'll need equally complicated solvers or off-chain intermediaries. And also it's very liquidity heavy, meaning that somebody needs to front liquidity in order for intents to work. The result of that is that, one, not all rollups can actually tap into that, and two, ultimately it's very limited use cases and very limited amount of tokens with high liquidity, again, because it's based on liquidity. Another point is that we're forgetting that actually when you want to bridge a token between rollups, the end goal is not to bridge the token. The end goal is to do something on the other chain. And to that end, there is no composability with intents, because intents in of themselves are asynchronous. meaning you request it once, and at some point in the future, somebody will complete that transaction. The UX is pretty good. Like it's very fast, but it's still asynchronous, meaning composability is always a 2, 3, or 4 step process, which again kind of goes against what we're trying to do with composability and interop in general in Ethereum. What we want to present is something called synchronous composability. Synchronous composability is this idea that there are 3 main properties we really want to have when you're talking about cross-chain transactions. The first one is encapsulation or composability. It's simply the idea that you can compose a bunch of interactions within one transaction. So imagine that you want to transfer your assets to another chain and then do something with a contract and then return and go to another chain. It seems obvious that on Ethereum you can do that, right? Of course, there are no chains on Ethereum, but if you want to compose a bunch of contract interactions on Ethereum, it's trivial. And so that's the composability or encapsulation part. The second part is atomicity, meaning that all of those interactions happen together or don't happen at all. It seems minor, but it's actually one of the most fundamental properties in financial transactions. So imagine that you want to transfer or swap a token. You want to guarantee that your token that you're selling is going out and something goes in, the token you're swapping to, but those are code-dependent, right? You cannot have a situation where you're just sending your tokens and not getting anything back, and obviously vice versa, which is kind of a double spend problem. The third property is synchronicity, meaning that everything I've talked about happens instantly in one transaction, not across multiple blocks, which can cause state changes and rollbacks and stuff like that. And so those 3 properties are something we're all used to on Ethereum, but when we port them to cross roll-up transactions, it's called synchronous composability. We're all used to having that on Ethereum, but now we want to bring that to cross roll-up interactions. And if I need to kind of chart how we compare all of those types of solutions, then you currently either have very generic but very slow approaches to interop, like asynchronous message passing, or you have pretty fast but very specific type of transactions which are intense. With synchronous composability, we try to do both. Super fast, but also super expressive and generic, so you can basically do any type of interaction you are used to do on Ethereum between rollups. And that's what Compose is. Compose aims to consolidate liquidity, dApps, and users. It aims to create a user experience which is just like Ethereum. It's not between rollups, it's just Ethereum, right? And it's instant, meaning that whenever the transaction hits the block, that's it, that's where it's executed. There's no multi-block type of waiting and latency and stuff like that. And there's ZK guarantees for atomicity, meaning everything you want to do happens or doesn't happen. And there's no kind of this locking and unlocking or waiting for your assets to unfreeze if something went bad. And so that's what kind of Compose is aiming to do. And the tech it's built on top of is called shared publishing. The shared publishing is actually built on top of SSV validators, meaning that validators are actually the ones running this piece of software. The idea there is to have it as a credibly neutral layer that many rollups can integrate to. It doesn't have to trust anyone, it's just Ethereum validators. And that shared publishing is the one that guarantees synchronicity and atomicity for those transactions. What happens is between rollups, the sequencers of those rollups can actually form the cross-chain transaction. Each rollup has its own independent sequencer, and they just produce blocks and ZK proofs for those blocks. Those blocks and ZK proofs are then aggregated using the shared publishing and then settled on Ethereum, obviously guaranteed by ZK proofs. It all starts with the concept of a mailbox. So each rollup has its own mailbox with in and out boxes. And when they want to move messages, or in other words, call other contracts on other chains, they simply move messages in between. Inbox is the messages you on rollup A receive, and the outbox is obviously the messages you want to send elsewhere. And the cool part about it is a very simple construct, but it's a very powerful one because it's kind of the basis on which we can guarantee the execution and atomicity and validity of that execution between rollups. The way it works is through simulations. When you want to do a cross-chain transaction, the sequencers simulate between them the actual transaction. It happens very, very fast. we're using a very lightweight consensus protocol, which is kind of a very simplified version of the BFT protocols we're all used to from staking, for example, on Ethereum and other protocols. By the way, we're using a BFT protocol in SSV. This is a much more lighter weight version of that, and it's super fast. And they simulate between one another the transactions, the cross-chain transaction, and they pre-populate messages in the inbox respectively. And they come to a decision if they want to proceed to execution or not. And if they do want to go to execution, each one of them executes. Now what happens in reality is, because we have the simulation part, each rollup, when it executes, it's executing as if it's a synchronous action, meaning it can do one after the other because we already did the simulation part. They do the execution, they produce a block, produce a ZK proof, and send it over to the shared publishing layer, which are the SSV validators. The validators are aggregating those ZK proofs together and also add into a super block validity conditions for the mailboxes, meaning that the inbox of one rollup, or the root of the inbox of one rollup, has to be equal to the root of the outbox of another. This is how we check for validity. And the ZK proofs are also guaranteeing the atomicity, because if anything goes wrong in it, they'll have to reorg and redo the transaction. And so there's no way that one side only executed versus another. I want to go back to this slide. What you'll notice is we have the opted-in rollups that are part of Compose, but we also have external rollups here, Base, Arbitrum, and other rollups as well. Because we have independent sequencers, we can actually create synchronous composable transactions between a Compose rollup and those rollups, meaning that Compose rollups can tap into the liquidity, users, and dApps of the bigger rollups, Base, Arbitrum, OP Stack, and OP Mainnet, and so on, in a seamless transaction. And that's a really, really powerful thing, because we can bootstrap from day one using the liquidity, dApps, and users of those bigger rollups, which is super important. And so this is kind of how the shared publishing works. But the cool part about it is synchronous composability opens up the door for much more use cases than we're used to in intense or asynchronous message passing. The first two ones, bridging and swaps, are done instantly, no latency, without any intermediaries. You can literally bridge a token or swap a token with no latency. The same way it feels and looks like on Ethereum, a single transaction, and it's done. And we actually just now made it so that we can swap a token on another chain and return the asset we swapped into the original chain in one transaction. That's it. It's literally as fast as it can be included in a block. And so that's a very powerful primitive. But synchronous composability goes far beyond swaps and bridging. It goes into things like cross-chain flash loans. Or you can have cross-chain transactions which involve more than 2 rollups, 3, 4, 5 different rollups. You can have multi-rollup DEX routing, which is incredible. Find the best price out of many rollups, not just one. You can even do NFT bridging. The implications on developers is immense, because it enables you to do arbitrary read and writes to any rollup in any contract. And also, it introduces a concept called a singleton dApp deployment, meaning that because you have synchronous composability, and because there is no friction between rollups anymore, as a developer, you can simply deploy your contract once. You don't need to deploy it on every rollup. And so you consolidate liquidity and users and remove a lot of the overhead of deploying on many, many different rollups. And that's a very powerful shift in the way we think about interop and the way we think about the rollup-centric roadmap. It also has the side effect of actually enabling the smaller rollups to bootstrap using the bigger ones. And so in terms of competitiveness, it really, really pushes the boundaries of what's possible. And so all of that is introduced with synchronous composability. I think this is the way Ethereum should be talking about interop and talking about its roadmap. Instead of trying to patch things with temporary solutions, we need to look at the problem and understand that the UX is the most important thing. What can we enable from a UX point of view that enables Ethereum to just feel like Ethereum? Not be on Ethereum and feel like Base or feel like Unichain and feel like any other thing. And I think that's critical for Ethereum and Ethereum's future. in terms of the roadmap, we've been working on this behind the scenes for a few months, and we're just ready to release the first testnet for Compose. Throughout and until the end of year, we'll actually be integrating for the first time Base into Compose. So you'll be able to do on testnet transactions with Base, the Base testnet. And then throughout 2026, we'll be starting to roll out Compose in various pieces and so on. And so if you want to learn more, we actually have a cool Compose lounge today. Scan the QR code if you want to join and talk more about interop and how Compose can really help Ethereum. Thank you.
Thank you very much, Alon. We do have about 5 minutes for questions before break. Are there any questions from the audience here? Oh, perfect. If I could have you stand up and walk this way.
Hi there, Alon. If that works, it's kind of the holy grail, right? Right now, SSV has 14% of staked ETH. What percentage of staked ETH needs to be supporting this shared publisher before critical mass is hit for the Compose network?
So it depends on what exactly in the life cycle of Compose you're talking about. I've just talked about L2 to L2 composability. But there's another big elephant in the room, which is L1 to L2 composability. That requires real-time ZK proofs. And to that end, you actually need much more validators, potentially almost all of the validators on Ethereum, because then you can have real-time proving and real-time execution between L1 and L2. That's a bit into the future. For currently, to do L2 to L2 composability, you don't need any more validators. I think it's decentralized enough as a layer for other rollups to trust and be credibly neutral with to have this amount of validators. We have enough validators with enough entities and enough different actors within it to, I think, build a really solid base for it. If we're looking into the future and want to have L1 to L2 real-time composability, then it's going to take a bit more, but it also depends on real-time ZK proofs.
How does Compose fit into the EF's coordination efforts around chain abstraction?
So chain abstraction, I think, is more on the wallet side, at least from what I know, and I think it goes very, very, very well. I haven't touched upon it yet here, but we're making a heavy use of account abstraction and user ops to achieve the best UX we can. We actually heard a conversation between the major L2s yesterday at the main event, where they talked about adopting, specifically Base, adopting account abstraction and 7702 natively in their wallets. And so all of those things are very much things that we need as well. And so we are making use of all of those bits and bytes that the EF and others are building. I think account abstraction can really work well in this. By the way, I don't know if you saw the announcement by the account abstraction team with the Ethereum interop layer. Today or tomorrow they have their event, but they're making the same type of use cases with account abstraction and user ops as we do, meaning that you sign once and you execute on multiple chains. And so in various ways we are using all of those kind of techniques and bits and bytes.
Excellent.
I have a follow-up question to the amount of validators. So if I understand this right, the idea is to start with the SSV network, but not stop there. So the way you would get L1 to L2 eventually is by opening this up to really any Ethereum validator.
Yeah, I think ultimately if Compose is going to be the kind of the gold standard for interop, yeah, it needs to be open up for everything. When and where, it kind of depends on where we get to. We'll start with the SSV validators, obviously, because it's easy, and of course we're working in tight collaboration. But yeah, ultimately I think down the road, yeah, potentially open it up to everyone.
Perfect. Thank you very much, Alon. And you'll be around a little bit during break. We have a break for the next 15 minutes, so we're back here at 15 minutes.
Thank you, everyone.
All right, well, welcome back, everybody. We've got a full agenda today, so we'll go ahead and try to stick to the timeline as much as possible. And our next speaker is ready to go. Dionysuz is here, and he's going to be talking about making Ethereum visible. So.
Okay, hello everyone. I'm Dionysuz, or David. Dionysuz is just what I go by online, and today I'm going to be talking about probably something a bit different than most staking conversations, and I hope you find it exciting and useful. It's about making Ethereum visible. Has anyone here heard of the Delian problem by any chance? Okay. So the Delian problem was back in ancient Greece in the town of like Delos. There was like a plague going on. And they went to, as they do in these ancient times, they went to the Oracle of Delos, and they were like, yo, how do we like not die from this plague? And the Oracle was like, you need to like double the size of the altar of Apollo. And they were like, okay, how the heck do we do that? Back in those times, they had straight edges and compasses. So basically, they could draw like lines and they could make circles and angles and stuff. This was like Euclidean geometry. And it turns out that it's really difficult to double the size of a cube. And they just couldn't do it with a straight edge and a ruler. So the intuition that I want to give you is that like the tools that we use make our reality visible. And in a kind of weird way, like math isn't even real in some sense. It's just a measurement of reality that help us achieve certain things. So there's this quote I like by this Spanish architect, Antoni Gaudí. There are no straight lines or sharp corners in nature. The Delian problem is basically that we're able to, if we have new tools, such as the Cartesian plane, you can actually map, you can actually see cube roots. So you can't see cube roots with just a straight edge and a ruler. So what I'm going to be talking about is like cognitive tools. This is another one just to kind of drive the point home. At least in quantum field theory, there is a notion of like there being these like underlying quantum fields that like basically influence how particles like work in our universe. And Feynman diagrams actually describe how some of these particles work. They describe something that's actually invisible, and I'll get to like how Ethereum is invisible in a sense too, and how we measure Ethereum. But they describe something that's invisible, and they make it visible through this diagram. And if you don't use a diagram like this, you end up having to see this whole thing as like what's called a path integral, and it's basically this really complicated math, and it's like, okay, what does it even mean? So these Feynman diagrams just make it easier to understand behavior about an invisible world. So TLDR, cognitive tools help us understand and change our world. If we want things in our world, like we want to double the size of a cube because we don't want to die from a plague, or we want to do something in Ethereum, we have to look at the tools that we have, right? Like our rulers, our measurements, our Cartesian planes, math, things like that. So we build and measure Ethereum with cognitive tools. On the engineering side, our cognitive tools are pretty good. We use a lot of math, we use a lot of mechanism design, but on the social side, they kind of suck. And I'll talk about more of the social layer of Ethereum and how home stakers really embody what I'll refer to as like the spirit of Ethereum. So one more example of a tool is a miscalibrated compass. So this is really kind of a tragic condition that I want to highlight. Imagine you want to go somewhere, right? Like in the same way that the people of Delos wanted to double the size of an altar because they literally just didn't want to die and they believe what this oracle said. So let's say you're a traveler and you want to reach the illuminated city and you have a compass. So you say, okay, you know that the illuminated city is north, so you follow the compass north, but it turns out that your compass is actually miscalibrated and what you thought is north is actually northeast. Well, in that case, it's tragic because you are trying to approach something noble, and your whole epistemic reality of what you want to do and how you measure your world tries to take you to this illuminated path, but because your compass is miscalibrated, you end up going the wrong way. And this can happen in the way that we measure and learn about Ethereum too. So cognitive tools make the invisible world visible, measurable, and importantly, actionable. Like with these cognitive tools, we're actually able to change and engineer our world. So one point I want to drive home is that Ethereum manufactures anti-fragile civilizational substrate. So basically, there's like two sides of what give Ethereum this hardness that we're able to build civilizational infrastructure. One of them is on the protocol side, where we do like a lot of mechanism design and we figure out, okay, what is like the right way to build incentives so that there is like, we have these hard properties like censorship resistance, security, and things like that. There's another side of hardness that I want to talk to, again, which is like on this social side, and to a large degree is controlled by stakers who ultimately control the fork choice. So here's this new thing that I guess the ETH Panda Ops team put out that people are talking about, this like new lab visualization where you can see all of the all the nodes decentralized around the globe, right? And this is awesome. And one thing you'll notice, which is interesting, that people in like cryptography or like mechanism designers always talk about, is they want to disintermediate control so that control goes down to the user, right? They want to say, oh, we want control to be with the user in a biometric sense, in the sense that, oh, I scan my face and that uses a private key to give my intent and you verify a signature and that's me. Or I give a fingerprint. Or I burn some calories and I touch a screen and say, okay, sign this transaction and do this thing, right? So we like to look at systems and we say, okay, when we try to distribute keys, distribute signing keys throughout the network, we want to give those keys to actual users and humans that are bounded by like this cognitive human layer. But what's interesting that I'll say about this diagram is that like even though you have distribution of the signing key of the participants in the validator set, which are signing attestations, proposing blocks, and things like that, there actually is a cognition layer that is arguably not decentralized, where, for example, let's just say, like, there is some huge campaign that goes around on Twitter that's like, oh, we need to 10x the gas limit, like, today. Like, for some reason, everyone thinks that we just have to do that, and they're, like, really strong arguments, right? Like, even though your signing key is, like, distributed, and theoretically everyone has their own reasoning, and it's relatively pluralistic and decentralized, it's easy to convince a large amount of the network to say, okay, let's actually do this change, and in a sense it has some centralization. So one thing that I want to hit home here is that the protocol kind of purchases human reasoning as a way to manufacture anti-fragility in terms of this like substrate we build for civilizational infrastructure. So yeah, let's just get right into it and look at some cognitive tools in Ethereum. The first ones are like social feeds. So we use like X, Farcaster, things like that in order to measure the world in the same way we use like the Greeks used rulers to like measure sides of cubes and things, right? We're like, okay, this is the state of the world, this is how things are, this is how we learn about the world. And we primarily use that through social feeds. And these have different types of algorithms that show you about the world and with different incentives. So the cognitive tools we have kind of suck, but there is promise of things getting better. Again, we have like ETH Magicians, ETH Research. This is like synchronous human deliberation with text. We have Farcaster. Again, it's a text-based feed for you to understand the world, and you can also propagate sentiment throughout the network. We use math, podcasts, and then there's this really cool tool that the protocol support team has, which is called Fortcast. Fortcast is this new tool which is like basically takes the all core devs process and has some new tooling built on top of it, new cognitive tools actually. So one cognitive tool is like you take the abstraction of like an all core devs call, right? And it might be a complicated thing because you don't understand all of the details of the protocol and all the mechanisms involved with it. But if you have like a TLDR summary from an LLM, especially an LLM that's tuned to your preferences in the way that you understand the world, you have a new cognitive tool for understanding how Ethereum works. Another cognitive tool is like over here on the right. This is basically a hierarchical segregation of priority between EIPs, right? So it uses color coding for you to understand which things are relatively more important, and like things like S, A, B, C, and D to like kind of weight things between each other. I'll give another example. There's a project called Deep Funding in the Ethereum ecosystem, where basically we're trying to like figure out what is the relative value of a bunch of different repos inside of the ecosystem. So for example, we kind of found out that like it's hard for a human being to figure out like how valuable a single thing is in isolation, but it's a lot easier for a human to take two things, compare them against each other, and measure them with a multiplier. So for example, it might be hard to say, okay, like, you want all of these percentages to add up to 100% or the number 1, right? In terms of like capital allocation on like what's a good idea. And you can easily think of these repos as like EIPs in some format, or things that you want to promote within the ecosystem and think are valuable. It's hard in isolation to say, oh yeah, like the ETH Panda Ops, like the Helm charts is like worth like 3% or something, right? It's like how do you come up with that, right? But it's a lot easier for someone to say, oh, comparing these two, like which one is more valuable and by how much? So this is a cognitive tool, right? It allows us to measure the world better, produce better data, and allows us to actually engineer better solutions for a world that we want to go towards. This is another thing called Polis. It's a policy selection mechanism that is similar to the rough consensus algorithm we use in all core devs. The basic idea is that you have a bunch of statements. People agree on them, disagree on them, or pass. You take data about all of these people, and you plot them in like multi-dimensional space, and you cluster them actually, right? So people have dimensions and features, and then people are all of these rows in a database. And if you can plot them in multi-dimensional space, you can kind of have clusters and you can have groups. So you could say, for example, that there's like, I don't know, 6 or 7 kind of clustered groups in Ethereum based off of certain properties, right? And what rough consensus does, and also this Polis policy selection mechanism does, is they say, we're gonna reject any policy that doesn't meet a certain threshold of each group within the ecosystem, right? And it turns out that policies that use this like bridged consensus algorithm overall have better like agreeability in the group than ones that use something like majority voting. Like majority voting usually ends up looking something like this, where just a huge group of actors in your ecosystem don't actually agree with the policy, and that causes all kinds of social issues. Open Agora is one other cognitive tool that I worked on with some people in the open source space. It's a tool that like kind of like utilizes Polis and tries to think about how we can, we were actually thinking about this when there was all this like EOF debacle going on, like a very sensitive issue, because people worked on it for a long time, and we wanted to see like, okay, how can we like measure how people feel about this and like whether or not it's a good or bad idea for Ethereum. So, this is one way that you can like actually try to have a view into making something that is, kind of invisible in some sense, like, okay, how do people feel about EOF, or how do people feel about fossil, and making that visible to a certain actor. So an actor always has a lens that they look at Ethereum and the world and the policies, and they try to measure it and figure out like what's the reality so you can act on it. So this basically uses like Polis. You can get an idea of like, okay, how much consensus are there for different issues, and I didn't show the part where there's like a voting mechanism like agree, disagree, pass, but it's like the same thing. And there's a little bit of a loaded slide, but because I just wanted to get information in there. But the basic idea is that, when we measure our world, like Ethereum, and we try to understand Ethereum, we all come from different backgrounds, and we all have different like technical understandings, different philosophies, and we can't just use one tool for like everyone, because that's just not everyone thinks the same. Some people like to read, some people like to watch videos, some people understand diagrams. I mean, everyone understands the world differently. So what's important is that you give the person who's trying to like measure the world their own tools for understanding like how things are working, right? So to give you an example, like one thing that you could do is just an example I thought of recently, is like, there's recently this like trustless manifesto thing that was going around on Twitter, right? That Vitalik and some other people made. And you could say, okay, I agree with this, right? You could say, I agree with the trustless manifesto. Like this is something that I'm aligned with, right? So you could, for example, take an LLM that knows your preferences, knows that you align with the trustless manifesto, and interprets some set of things to measure the world, and it can tell you, okay, these are the impacts of this proposal based off of the values that you have. Another way to think about this is like, I'm not sure if people have like are familiar with like the issuance debate. Like I think Anders like Ellison like wrote some stuff about like issuance, and like for me like a lot of the formulas are like I just don't like understand the math and all that very well, and I'm like I just don't really like get like how changing different like parameters into functions like actually change things that are important to me. But like the thing is like you don't actually, depending on the lens of what actor you are in the ecosystem, you don't need to know the details of that math. You just need to know how this impacts you. Like for example, if you are a staker, you could say, okay, you're just going to earn less money, right? I mean, there's going to be other there's more nuance to that, but you can see the outcomes of something without knowing all of the details, right? And LLMs are actually really good at that. Like you can say, okay, here's this like this hard engineering thing that I don't understand. Like what happens? Like what is the result of changing this like complicated thing that I can like actually understand? Yeah, so the TLDR here is that Ethereum cognitive tools like kind of suck in my opinion, but they're getting better with things like Forecast, experiments like Polis, and experiments like deep funding. I think that this talk in some sense is a little bit philosophical, but that is because Ethereum is a little bit philosophical. Like it's just new technology, right? And we have to accept that we're doing something new that hasn't really been done before. So we have to invent these new things actually. Like it's really a new precedent. So I think that we need to try to like invent algebra in some sense, right? In the same way that algebra and like Descartes coming up with like the Cartesian plane would have allowed the ancient Greek people to see cube roots, right? Like we need different tools to be able to see the reality better. And the reason for that is because it'll allow us to measure the world better and engineer better solutions faster. So I think that one thing maybe I didn't hit on enough is that really the most aligned actor in this ecosystem, in my opinion, is the home node operator, the home staker, because they have the most alignment with the hardness of the protocol because they earn ETH. And I think it's just really important anyone that stakes that it's really like a it's really like a role to be proud of, I think, and it's really impactful in the ecosystem. So I hope that we can get more stakers on Ethereum and more people that stake involved in the process of controlling the network, right? Because you run a certain binary that has the protocol rules, and I think that it's very important to keep Ethereum as this like anti-fragile civilizational infrastructure. So if you want to hack on this, I'll be at ETH Global over the weekend working on cognitive tools, and we can always chit chat. I'm dionysuz on all off-chain places and dionysuz.eth everywhere on-chain. And then I also, as a shameless plug, I make an open source tool called Kody node, where it's like easy to like run an Ethereum node with it. So yeah, I don't know if there's time for questions, but that's my TED Talk.
We do have about time for maybe one quick question. I see one here from the audience, but looks like I'm not seeing one. Will you be around a little bit?
I will be around, yeah.
Excellent.
Okay, thank you guys.
Thank you. All right, bear with us just 1/2 second as we set up the stage here for a short panel discussion. Great, thank you very much here for it. I have the pleasure of moderating a discussion here with two individuals that I've had the opportunity to know very well over the years here. Steve, let's start with you if you want to do a quick introduction.
Hi all, Steve Pack, CEO and co-founder of Rock Solid. We're a liquid vaults platform that let folks earn the best rewards in DeFi with a single click. Just launched 6 weeks ago with the Rocket Pool protocol. Happy to be here.
And I'm Darren Langley, otherwise known as Langers in the Rocket Pool community. I'm the general manager of the core team of Rocket Pool, and Rocket Pool is a decentralized liquid staking token protocol. We have a liquid staking token called rETH, and we also allow people to do node staking on the other side for as little as 8 ETH per validator.
Excellent. And so the topic here is talking about how vaults can integrate with LST protocols. And so Steve, maybe for you, you want to talk a little bit about the origin story of how this idea formed and the genesis of it?
Yeah, sure thing. So I'd been running Rocket Pool nodes for a couple of years. Had met the team at ETH Denver, and I was finishing up a role and just really liked the community, liked the protocol, liked it was, this intersection of finance and technology, and it actually helped Ethereum be decentralized. And so I really wanted to do something in the space. At the time, one of the issues was getting enough node operators. And so I'd talked to the team about, a product that might sort of help with that. And then things changed, and all of a sudden that wasn't the problem. What Rocket Pool needed was rETH demand. And so, I had a co-founder. We'd been talking to investors, and it kind of identified that rETH was amazing for its decentralization and its reliability, but it wasn't as well integrated into DeFi as some competitors were, especially Lido. So we looked at ways we could help with that, and kind of landed on vaults as this effective way to sort of be a focal point for rETH, so that we could then help negotiate more integrations for rETH into DeFi, and so kind of fill that maybe top layer that was different to the decentralized LST. Yeah.
And then Darren, from your point of view, why was Rocket Pool excited to partner with a vault provider?
Yeah, so as Steve said, Rocket Pool is kind of like a two-sided marketplace. So you have rETH demand on one side and node operator supply on the other side. And you're always in this situation where you're kind of like shifting between the two. And we launched Saturn 0, and it's meant that we kind of flipped over to we had plenty of node operators, but not enough rETH demand. And the big thing for rETH is utility of the token. We do have a number of DeFi kind of integrations, but a real kind of issue that we found is because we're a decentralized protocol, we don't allocate capital. So we can't go to a protocol or a new chain or something like that and say to them, we have all this money, we have all this kind of like TVL, and we're going to put it somewhere. And so a big thing for us is having a vault provider who can actually do that for us, and also the fact that rETH itself has quite good yield because it's the base layer from the beacon chain, but there are a lot of people who want to kind of get that extra yield, and so that's where a vault comes in as well. So so it kind of helps with the driving demand of rETH as well.
And then Steve, it's been what, 2 months? I always get the times a little here, but I think about 2 months since you launched. You want to talk about some of the early wins and successes that you've seen so far?
Yeah, happy to. So 2 months ago, we've seen 5,600 rETH, which is I think 6,500 ETH flow into the vault. So that's between 20 and 25 mil USD, depending on the price of ETH on the day. So great response from the community, and I think we've got northwards of 270, I think, holders now, and so that's a good spread of, we see 0.1 rETH deposits and we see 100 rETH deposits. So, it's been great to see both the community and whales deposit. I think one of the biggest things is we wanted to help with the rETH demand side of the equation, and of that 5,500 plus rETH, we did some analysis of deposits, and the majority of that, somewhere around 80%, they didn't own rETH right before they deposited in the vault. So they went and had something else, whether it was ETH or maybe staked ETH, sometimes that would be nice, swapped into rETH before depositing. So in terms of protocol alignment and being able to say, like, yes, we're helping with rETH demand, like that was a really nice sort of result to get from that analysis. Another thing that we sought to do was DeFi integrations, and so still getting started here, but I've seen a few. So we've deployed to 7 different strategies so far, and one example was Hemi. It's a small L2. It uses Bitcoin for finality to improve the bridging performance, and it didn't have RETH on the bridge, but they were offering incentives. So we said, hey, if you add RETH, we're interested. And then in a particular protocol that they were incentivizing at the time was SushiSwap, and there weren't RETH pools on this chain. We're like, well, create an RETH pool and we will come. And so, that's good for the vault. The vault earns incentives that way. But what's nice is that RETH holders, whether they're in the vault or not, if they wanted to go and LP to a pool there, like that opportunity is there now. And that was just the first. We got RETH added to the Inc chain as well, where we're currently deployed into an Aave clone. And yeah, we are, and our partners are constantly out there, like trying to negotiate for new opportunities for RETH. Selfishly for the vault, but the whole ecosystem benefits.
And then Lingers, let me ask a question then. I guess you mentioned early on that Rocket Pool, it's a liquid staking protocol, and so it has really 2 sides of the house, right? It has the node operator side, it has the liquid staking token holder side, the RE side. Yeah. What benefits are there for the node operator side of the house?
Yeah, that's a great question. So on the node operator side of things, it means that they can deploy more capital. We've got like a little bit of a queue at the moment for RE for node operators, but it means that that queue gets processed by these deposits. The more RE that can come in, the more capital a node operator can actually deploy.
Okay. And then what about the reverse of that question, just the RE side of the house and the larger ecosystem? How do you see this partnership advancing that? Yeah,
actually I did miss one for the node operator side. So the node operator side, with Rocket Pool, you earn the yield on your 8 ETH, but you also earn the commission from the ETH that you're staking on behalf of RETH holders. So they actually get like a commission on top of that, so they get more yield from that. So the more that they can deploy, the more of that yield they can get. On the RETH side of things, as Steve said, this is kind of like an expansion for RETH. It's opening up new doors, new opportunities for RETH and its utility. So things like a lot of LPs, a lot of new chains, potentially more lending markets. All of those things add to RETH's utility for RETH holders.
Actually, one thing I'll add on the RETH side, like one of the strategies we run is like leverage looping of the token. Only about 5% of the vault is deployed that way because we want to make sure we're in mostly liquid things. But when we first deployed that, we actually closed the discount of RETH to its underlying value because we were there constantly, like mint, borrow, and so we could see the gap closing. And it was a point in time thing, but it was just kind of a really visual representation that the more demand there is, the closer the RETH is to peg, and there are other protocol related things anyway to coming to help the peg. But that was just again nice to see, like, this really is operating in a protocol aligned way.
Yeah. Okay. Yeah. Maybe Steve, to you, let's change it over to a little bit about the risks and challenges that are out there, right? And so one of the recent things was Stream Finance had a collapse, right? You want to talk a little bit about that and kind of your perspective as a vault manager?
Yeah, sure. So first of all, DeFi has risks. There's a reason why the vault has a greater, return than staking does. Staking also has risks. You rely on client teams. You rely on, the protocol sort of operating the way we think it should. But it's priced lower. With the vault, we deploy to DeFi, so we do incur risks. Things like we use bridges. So we use bridges that we trust, but there have been issues with bridges. A lot of the protocols we're deployed to are also rock solid protocols like Aave, like Spark, like Morpho. Balancer just blew up, right? So we weren't affected by that, but there are risks. So that part should be clear. But we do a lot of things to reduce those. So, like I said, due diligencing the bridges. We typically do delta neutral things. So we don't like borrow stable coins against the RETH holdings and deploy that. You can earn good returns that way, but if ETH falls against the US dollar, which we're seeing right now, like you can get liquidated and lose money. So we really focus on delta neutral strategies. Stream, I think, is a particular example where you need to understand the asset, right? So a lot of DeFi is lending. It's like I will lend you ETH, and on the other side you have someone give you collateral to borrow the ETH and go do something with it. So what's the collateral you're accepting? And with Stream XUSD, turned out the collateral was like basically them also running strategies, but that weren't transparent. They'd taken money, they'd given it to some other asset manager to manage. It was off-chain, so you couldn't even see it. That asset manager lost the money, and all of a sudden it was gone. So, we had seen opportunities to participate in XUSD opportunities, and it was like, what is this collateral? And you couldn't figure it out, right? It was called on Twitter. It was like this "trust me, bro" approach to DeFi. So, yeah, just by nature of the fact that we're focused on delta neutral strategies and do look carefully at assets, we avoided with Stream. But that's also why the APR is 7% with at the moment with the incentives that we add, and not 10, 12, 15, 20 that you see on some of these like stablecoin focused vaults.
And so what resources are available for somebody who is considering investing in this and they want to do their research? What type of transparency do you provide somebody to make an evaluation of these risks and to understand where the funds are?
Yeah, great. Thanks for that one, Ken. So just go click on the vault. You'll see the strategies that we're deployed to at any given time. There's I think 7 at the moment that are active. There's a DBank link. So for folks who haven't used DBank, it does a really good job of looking at a wallet and finding all of the positions across all of the chains. So you can verify that what we're saying is what is there. And then for folks that really want to go deep, there's a very long and boring terms and conditions document where we really tried to lay out every possible risk we could think of that exists in DeFi, and they're all there. So plenty of risk material for those who want to dive in. Yeah.
But I think one of the best way that you said it was that your kind of vaults are like a risk adjusted return, which I think is a good way of putting it.
So excellent, and I think last when we were speaking a little bit, right? The launch was successful. You maybe had a chance to sleep one night, right, after the launch, right? But now the rest of the journey begins. You want to talk a little bit about what's next in the roadmap ahead and where you see Rock Solid going?
Yeah, there's lots happening. So there's always like feature type things going on. So one thing coming up is like instant withdrawals. So typically it's a 24-hour delay when you withdraw from the vault, but we can run a pool of RETH and vault receipt shares. So if someone wants to swap out instantly, there may be a slight haircut depending on the market, but being able to get out instantly is a nice feature that folks value. Really, we want to keep growing the vault, right? Like there are ETH holders out there that I think value the risk-adjusted returns and that value that our ETH is a force for good for Ethereum, and we want to convert them to deposit holders. So very much grow the existing vault is number one. Like vaults also are useful outside of the Rocket Pool ecosystem, right? There are other ecosystems or just holders of ETH that value out the way we approach vaults, and especially delta neutral strategies. So definitely looking at that as well. But yeah, that's really the focus at the moment. It's growing this one. It's been a great start, and I think it's 2.5 billion-ish RETH total TVL, and we're at 25. So we've converted 1%. I would like to see 10% of that, and I don't think that's actually outrageous. It just takes some time for us to like be in the market, keep delivering returns for holders, and yeah, I think we can get there.
Excellent. Well, before I let him go here, we do have about 5 minutes for questions from the audience. I don't know, does anyone have a question for the panelists that are up here? Okay, perfect. Hang on, give me 1 second.
Hey, I know liquidity is a big factor. Have you guys considered, I don't know, funding or building a secondary protocol that focuses specifically on highly liquid stake derivatives? Because apparently a lot of bigger investors, prime brokers that want to get into staking ETH, what they really care about is the liquidity so they can exit early. What are your thoughts on that? And does the vault, does it take away from that liquidity? Is it affected by it? Can you talk more to that end?
I'll deal with the base kind of like from the protocol liquidity. So, so there's a couple of things there. So we have within the DAO, we have a management committee called the Incentives Management Committee. Their job is to incentivize liquidity of RETH across different chains. They focus a lot on mainnet to make sure we have deep liquidity on mainnet, but they also incentivize liquidity on L2s as well. So that goes. That's incentivizing liquidity providers on different liquidity platforms. So that's kind of like one thing. The other thing is in terms of like withdrawal liquidity. So Saturn, which is our next release, which will be in January, that actually improves withdrawal liquidity quite a lot. So at the moment, the withdrawal liquidity is just fed from node operators exiting the protocol, but in Saturn 0, it'll also be any ETH that goes into the protocol will serve withdrawal liquidity first, so that we make sure we service that first and give that a priority, and then it'll go into growing or servicing the node operator queue. So, yeah, that'll help get that kind of like withdrawal liquidity from that perspective. Yeah, that's probably the base level.
Yeah, and I think that will be an awesome feature for just Rocket Pool's competitive positioning in the LST marketplace, so yeah, very much looking forward to that. Then the next level, I think, where you're getting at too is, well, just holding an LST, if you need to get liquid ETH, like, you know, how do you do that? And there it's, there's secondary markets, right, where, yes, you know, that's another one where...
Actually, I should say at the protocol level as well, talking about kind of like the big institutions, the DAO has kind of like prioritized redemptions, so essentially forced exits of node operators for our next release. So after Saturn, the next release after that will have forced exits redemptions, and so that's like a key thing for particularly the big institutions.
Yeah, yeah, and then for the sort of getting from an LST to actually liquid ETH, that I actually agree with you. There is a kind of an unmet need there, because that exists today. You can call a lending desk or if you're a large institution or a market maker and say, like, what's the cost to borrow ETH? And then the thing is, like, though, when things are orderly and the redemption, the validator exit queue is low, it's like not much. And then when Kiln blows up and you ask and it's 47 days, the answer is it's a lot. So yeah, it is an interesting, I think, place for experimentation. Yeah.
Excellent. Well, please give a round of applause both for Darren and for Steve.
Thanks again.
Thanks again.
All right, well, I'm very pleased to announce our next speaker here. Joining us from the Aztec protocol is Joe Andrews. Joe is going to be talking about decentralization or delegation, rethinking how we build the validator ecosystem.
We may need just a minute to get the slides working. Clicker? Okay, no laptop. Hey, welcome everyone. It's great to see so many stakers here. I love coming to events like this one. It's where kind of the real people behind Ethereum are, so thanks for having me. My name's Joe. I'm one of the co-founders of Aztec, and before we start, I'll just give a bit of context on what Aztec is, in case you guys aren't there. The talk today is going to be a bit about our lessons, kind of bootstrapping Aztec staking sets, and hopefully will be a good lesson for other people thinking about staking in different ecosystems or building their own decentralized validator sets. We're going to cover kind of what our view of decentralization actually means, why we think foundation delegation can be a trap, and how we think about building different ecosystems, and then we'll have some time at the end for questions. Before we start, what is Aztec, and I guess why can we speak about this? We've been building kind of a fully decentralized programmable world computer, or private world computer. The goal of Aztec is it's permissionless from day one. Anyone can stake, and it's kind of a stage 2 roll-up on Ethereum mainnet. It enables kind of optional privacy at every level of the stack. You can have user privacy, smart contract privacy, and even kind of like execution privacy as you go. In terms of our progress, we launched a decentralized testnet earlier this year in May, and we had about 10 to 20,000 nodes from all around the world, and we've kind of taken lots of learnings from that into our current state. The current Ignition network is bootstrapping on mainnet as we speak. I think we're 80 to 90% of the way there to it launching, and the execution environment will launch next year as a stage 2 rollup on Ethereum. All right, let's dive in. In terms of kind of decentralization, we've built Aztec to be decentralized from day one, and we've thought a lot about kind of this question, like what does true decentralization actually mean? I think about it in terms of 4 categories, and each of these is needed to actually effectively decentralize a network. The first one, which is kind of an obvious one, is around stake distribution. How is stake distributed across your validator set? Ethereum's seen this kind of firsthand with like large institutions like Lido or kind of Coinbase owning large amounts of the set. But you need to think about, what threshold does any one entity have in the set, and how many entities need to collude before you break some honesty assumption, which could bring down your network. If you're not kind of using Ethereum's consensus and you're using kind of a different form of consensus, it's usually going to be around a 33% threshold or a 66% threshold before something goes wrong, especially if you're using something like Common BFT. The next point is access. So who can participate in block production? Is it permissionless? Who can participate in staking? Is it permissionless? Who can participate in governance? Is it permissionless? A lot of kind of new networks keep this behind closed doors, and so access to the validator set is gated. You have to go and apply on some form. You have to apply to a program to get delegation to stake. And then the last kind of like, but maybe not so obvious one, is sometimes networks are permissionless, but it's $1 to $5 million to participate, and then people are basically priced out and can't afford the stake. Third point I want to talk about is diversity, and there's kind of 3 camps here. There's the location of your stakers. Where are they located in the world? What client are they running? Ethereum does a great job of this, but on kind of smaller networks, it's usually one client. And then lastly, kind of who are they? Are they institutions? Are they solo stakers, like a lot of people in this room? Or are they kind of like validators as a service? And you don't want any one group of those to outweigh. You need all of them because they all bring different views to the network. The last point is one that's usually forgotten. What we see with most validator ecosystems is, other than Ethereum, people don't own their stake. They just own the rewards that that stake entitles them to. And this is a big mistake because it means that validators are not economically aligned. They just do what is required to extract those rewards from the ecosystem. They don't actually think about what's needed to make the network successful because they're not invested in its long-term future. If the revenue stream dries up, they'll move to a different ecosystem. So this is what I call kind of the foundation delegation trap, and it kind of goes a little bit like this. I think foundation delegation came about as a result of like the Biden administration and as a way to kind of bootstrap decentralization when we had very kind of like strict laws around distributing tokens. Now we're in like a new era. I think they actually do the opposite. And if we're not careful, foundation delegation can entrench a small validator kind of monopoly or oligopoly, and they prevent the market finding new operators who can kind of come in and prove their competency. And in the worst case, they delay or permanently prevent decentralization. And so you end up with networks kind of stuck in this limbo of temporarily centralized, and their kind of ecosystem is clinging on to the foundation because they don't actually own their stake. I think about it a bit like scaffolding. Like you need to build a building, and then you can put scaffolding around it. Like you can't just like use the scaffolding to support the building. In terms of memes, it's not that all delegation is bad. For us, it's the ordering that's really important. So if you kind of try and use foundation delegation to bootstrap a decentralized network, it's probably going to be quite difficult. It's much better to try and decentralize the network from day one, decentralize ownership at the start of the network. That's when it's easiest to do, when the network's kind of in its genesis. And then you can use foundation delegation to maintain decentralization over time. You can kind of think about it a bit like a tool to combat different centralizing forces. So if you see on a staking dashboard that you're missing validators in South America, great, the foundation can start delegating there to, pull the validator count up in South America. If you launch a new client, you can make a program to kind of incentivize the usage of that client. But if you start with it, what you end up doing is kind of entrenching an existing group of people who maybe will keep the network centralized for a long time. So our approach, we've been seeking out kind of solo stakers, institutions, and node operators all around the world and kind of give them all equal access to the network. We don't have foundation delegation for the first year. We want to ensure the network bootstraps decentralized. It needs to kind of launch in a way without the foundation, and then over time the foundation can use delegation to make sure it stays that way. No insiders can stake for the first year, and only the community can stake and own rewards. So for us, this means that the community has pure kind of ownership and control of the network, which is really important. It means that they're kind of economically aligned with the protocol, and they're not just waiting for the next delegation program. Last point is, I think it means that validators can compete on performance and not just connections. So new validators can spring up, and we're seeing that a lot in the Aztec ecosystem, either first-time stakers or new businesses that want to kind of prove themselves in a new chain. So as I said earlier, we started with a fully decentralized testnet. We had between 10 and 20,000 nodes running fairly consistently from about May till now. On every continent that has people on it. I think no one managed to do it in Antarctica, but we're still waiting on that one. We have low hardware requirements, and as I said before, a good group of kind of first-time operators as well. In terms of where we are today, this is the network kind of bootstrapping on Ethereum. When it gets to 500, it will go live. So this is right now on Ethereum mainnet. It'll be fully decentralized on day one and controlled by this validator set, and no foundation delegation for the first year. But after that point, the foundation will look at the makeup of the network and start to kind of delegate where it sees fit. I'll leave you guys with kind of 2 points that I think the ethos of Aztec and kind of how we thought about this problem. I think we need to build these networks that are built to last. They need to be decentralized from day one, not just with a promise to do it later. And I think we need to avoid the trap of foundation delegation being kind of like a shortcut to decentralization. And the second point is, I think it's not a silver bullet to just use foundation delegation to say your network's decentralized. You actually need to decentralize ownership and economic rights to the network, and that's a lot easier to do at the start of the network than it is at the end of the network or when the network's successful, when the stake is much more valuable. So TLDR, use foundation delegation programs to maintain a decentralized network and combat centralizing forces. Don't use it to kind of take a shortcut. Maybe I finished a few minutes early, so we can take some questions, and thanks for having me.
Yeah, we most certainly have time for questions, and unlike last time, I'll keep an eye on the live stream folks to see if there's questions from there as well too. But does anybody have a question for Joe? I guess I did have one for playing around in the Aztec testnet here a little bit, and I guess it's approaching ignition here. Do you want to talk a little bit about what happens during that process and next steps, right? You mentioned in the presentation you're about 80% at your threshold, but do you want to just foreshadow a little bit about what happens once that threshold is met and how that's different from your mainnet launch?
Yeah, it's a great question. So we've built kind of all of Aztec. What's deployed on Ethereum right now is a fully working version of Aztec. The block gas limit is just set at 0. And so it's set like that so we can test decentralized block production works as intended on Ethereum mainnet. We're very confident it works on testnet. It's been running for a long time on testnet, but with real economics and kind of, actually competing for real blob space on Ethereum, we need to test this in the real now with deploying it to Ethereum mainnet. So the point of the ignition launch is to test that for 2 to 3 months on mainnet. It's a bit like the beacon chain. We'll run that until we're confident that it works, and then there'll be an upgrade by the decentralized staking set to basically enable transactions by increasing the gas limit. So that's happening in the background right now. Once we get to 500 nodes, the network will start producing blocks, and it's kind of, at that point, it's in the hands of the community. So it's pretty exciting.
Excellent, thank you very much. A question back here in the back.
This is from Tio on YouTube. He's asking, when's the mainnet launch date?
So the ignition, like the first kind of point, is happening right now. And we expect it will complete this week, I think. Depends when enough community members stake. We're targeting kind of early February, maybe March for turning on transactions. The only kind of missing pieces are completing audits for some of the execution environment code. All of the stuff on mainnet is currently audited, but the actual execution environment for transactions is a lot of complex cryptography, and so we're still auditing that ahead of mainnet in roughly February.
Thanks.
Hi, yeah, thank you for your talk. I had a question which is about like the node operators that are running part of the Aztec sequencer. Like, what is how do you balance like decentralization that the protocol obviously wants with like the performance, like the quality of service that you want to get for like users? Like, how do you generally think about that?
Yeah, it's a really good question. So we're a little bit fortunate in terms of being in L2. So Ethereum has a problem where like every validator has to execute every transaction. In our model, that's not quite the case because we rely on Ethereum to kind of verify the computation with a zero-knowledge proof. And so the performance requirements are a bit less as a result for validators, but there is still a tension. In the Aztec network, it's around bandwidth. And so we have to just pick a threshold that we think is suitable to attract home stakers and get that side of the network, but also not jeopardize the network's goals. At the moment, it's 8 cores roughly and 25 megabits up and down connection. And so it will scale, I think, with Moore's law after that, and we can achieve reasonable throughputs with that. So that's how we've got there.
Thank you.
I think there was one more at the front, maybe?
Yeah. Hello.
Hey.
I have to make a statement. I'm a lazy home staker. Lazy enough so that I never use things without like helper tools. That's why I had to develop CSM and Lido. Now, the question. I've been trying to get my hands dirty with Aztec testnet, and even though my friends send me like a shit ton of videos on how to set it alongside Ethereum node, again, I'm a lazy home staker. Do you guys have any plans on integrating to Eve Docker, dApp node software, or wherever else where a lazy home staker like me can easily run this Aztec stack nearby my Ethereum node?
Yes, I don't know if Cohen's in here, but Cohen's our validator lead. He's either out there or maybe somewhere at the back. We have a DAppNode package, and I believe the Obol team is also looking at integrating it into their stack. But yeah, there's a DAppNode package, which should be one click for you. So if you've got a DAppNode, you're good to go.
Yeah, I'm laughing at Dima's question there because I too am a lazy home staker and had the same experience. But we have one more question up here in the front.
Hi there, thanks. When you're talking about foundational delegation, that sort of thing, my understanding is, and maybe this is more for proof of stake L1s, like part of the challenge is that you want decentralization, but you also want enough stake there that a single whale can't just easily take over the network.
Yep.
How do you balance that, and is that a challenge?
Yeah, it definitely is. I think like this is kind of why you have to do it at the start, because if you wait for 2 years and your network's successful and it's now worth a lot of money, it's very hard for people to acquire stake at that point. But if you start this way, it's a lot fairer access. There's still an issue with kind of Sybils and people pretending they're more than one person. We use kind of ZkPassport, which is a kind of proof of passporthood to kind of verify that on the testnet and try and make sure that like one person is not 5 entities. So there are still problems, but it is easier if you do it at the start when the token has no price, effectively, or its lowest price.
Okay, so it's not entirely permissionless. Like there is a limit per person.
So there's like a sale happening at the moment. There's a limit per person. Beyond that, it's completely permissionless. But at the very start, there's you just have to prove you're not on a sanctions list.
Okay, great. and so if I understand right, then it's still like, say a whale could take over, but the network's not worth that much. So who cares? While it's still early days.
Yeah, there's a normal like exit delays and entry delays. So you would, once the network's bootstrapped, you'll be able to see that happening, and the community can respond. So yeah, it could happen the same way as Ethereum, but you can respond in the same ways.
You got one time for one last question on the far side of the room here.
On the ZkPassport question, how was it developed? Did you guys develop it? Was it developed independently? How's the documentation coming? Because last time I used it, I remember you couldn't like granularly share, like see what info that you're sharing. I heard that it's different now, but how's the documentation for that, and is it open source?
Yeah, it's open source. So it's an ecosystem team. So we gave a grant to fund it. It's powered by the language we wrote, Noir. So they wrote their circuits inside Noir, but it's an independent team that built it. I think they used it as well for Devconnect. So if you're from Latin America, you got a free ticket by proving you're from one of the Latin American countries. So it's pretty granular now. And inside the app, you can see what it's asking you to prove. So are you above 18? You want a sanctions list, those sorts of things. So yeah, it's really granular.
Excellent. Well, a round of applause for Joe, please.
Thanks, everyone.
And that concludes our morning's program. We now have time for lunch. For those joining on the live stream and in the room, we'll begin immediately at 13:10. So you have about an hour for lunch. right, well, welcome back. I guess first to the folks viewing us on live stream and those watching us on the re-recording here. Welcome back. We just concluded our lunch break here, and the folks from the audience are starting to kind of trickle back in for it. But I'm very excited. We've got quite an afternoon ahead of us here. And the part right after lunch is going to be very interesting because we're going to have 3 speakers, each with the EF. And so I'm very much looking forward to these talks here. And the first one here is Marius. Marius is going to be talking about sustainable scaling. So please welcome him to the stage.
Thank you, everyone. Hello, my name is Marius. I think I know probably half of the audience already. So it's great that you're here and you're supporting me. And today, I will be talking about sustainable scaling and how we at the Ethereum Foundation think about scaling and how we think we can scale Ethereum without making it impossible to run nodes. So we recently had a bit of a restructuring of the Ethereum Foundation, and we came up with these 3 tracks: scale DL1, scale the blobs, and improve user experience. I, together with Tim and Ansgar, we are leading the Scale DL1 track, and we have several projects on this track that we think are blockers for increasing the gas limit and scaling DL1. I want to talk today about 3 of them and introduce them to you. The first one is history expiry. We have already shipped history expiry. If you don't know, we usually speak of the state as the current state of the network, so all of the accounts, all of the balances, everything, and we speak of the history as all of the blocks that happened before, that led up to this state. And we recently shipped, in all of the clients, we shipped partially history expiry, which means that all of the pre-merge blocks and receipts can be forgotten by nodes. This will reduce your node requirement by 300 to 500 gigabytes, and it's already implemented by everyone. Probably most of you have heard of this before, and now you can still run a node on a 2 terabyte SSD thanks to this. It was a bit slow, so maybe you have already upgraded to the 4 terabytes, but this will make sure that you don't need to upgrade to the 8 terabytes anytime soon. And then the next step of history expiry is full history expiry, where we need a new ERA-E format. This is the format where we can store the history, and we can also retrieve it from either decentralized or centralized storages. And this would also, in full history expiry, we also plan to expire everything after the merge up until 1 year ago. So nodes would only need to keep the last 1 year of blocks on disk, and this would further reduce your node requirements by an additional 300 to 500 gigabytes. And that would also mean that the node requirements are not increasing as much as they used to. So the requirement for disk space for a node should be increasing much slower than in the past. And one thing that we are also working on regarding history expiry is history retrieval, because even though most validators don't need the history anymore, some people do, or some people still want to look into the history. And they need a way of getting that history. And we already have centralized history providers that have this history, that provide this history for you. But we also have some decentralized out-of-band protocols, like BitTorrent, like some other solutions where you can get your history from in a decentralized way, but they are not part of the nodes yet. And we are also thinking about a purpose-built decentralized protocol where your node can ask for certain a certain range of blocks if you're interested in them. Okay, so the main topic of this talk is not going to be about history expiry, but it's going to be about the 100 million mainnet gas limit and the future of pricing. Those are two topics, two projects. So we kind of, when we started the track, we kind of discussed which projects we would like to see being worked on and which things we would like to see happening in the future. And the future of pricing and 100 million, the 100 million mainnet gas limit was the first big project that we had in mind. And in order to solve that, in order to get there, we need significant changes. First of all, a little primer to why or how some explanation of some of the things that we will be talking about in the next couple of minutes. Within the node, we have the EVM. The EVM executes all of the smart contracts. We have certain operations in the EVM, like addition or multiplication. These operations cost gas, and they are priced roughly on how hard they are to be executed. The problem is this pricing is not very dynamic. It was set once 10 years ago, and for most of the operations it has stayed the same since then. Even though we have different hardware now, we have different improvements. And then we have three different categories of resources that we have in the nodes: data, compute, and state. And we usually, when we think about these EVM operations, we categorize them by one or two of these resources that they use. So, for example, for the data, we have operations that impact the bandwidth, like, for example, call data, like log, like the transaction itself. For compute, or the access list, for example, for compute we have operations that use processing time, like addition, multiplication, jump. And for state we have operations that either grow or read the state, so create, sload, store, create to, all of this. And then the gas limit limits how many of these operations can be done per block. And this limits, this is for DOS protection, because otherwise you could just send a transaction that would take 10 minutes on every node to execute, and that would be kind of unfair to everyone else. So we have to limit the size of the blocks. And the gas limit implicitly also limits the execution time and the size of the block. And if we increase that, as I already said, it might mean that some nodes are not able to execute the block in time anymore, because we are producing a block every 12 seconds, and there's like attestations after 4 seconds, and then aggregation after another 4 seconds. We have roughly 3.5 seconds to execute a block. And this chart, one of the good charts on Etherscan, this shows us the average Ethereum gas limit. And as you can see, for a really long time, since 2021, mid-2021, it kind of stayed the same. And we have recently started increasing the gas limit. So what you can see here in the far left corner is an increase from 30 million gas to 45 million gas. And what does that mean? Like, it basically means nothing, but this might actually mean something to you, because this is the same time frame, and in this same time frame, the average transaction fee over the last year has decreased to less than $1. And so we are at 45, but the question is, can we go higher? Can we do more? And how can we do more? And the problem is always we have a lot of operations. Like here we assigned them like in this star kind of format. And we always have to identify the worst case operation. Because if someone just sends a block with all of the worst case operations, that block will take very long to execute. And so we need to make sure to limit our gas limit to the worst case. And so what we do during the 100 million gas project and the repricing project is we try to identify the worst cases. And once we identify the worst cases, we try to optimize the worst cases. We try to go into the clients and see, okay, like, I don't know, addition takes too long, there's something wrong, addition on this one client takes too long, it takes like 3 times the time that it takes on other clients, so we are going to optimize addition in this one client. And what we can then do is we can raise the gas limit, and we will see the next slowest operation. The problem is we cannot always just go into the client and fix things. Some things are just the way they are. It is very hard to make an addition much faster. It's just not possible. There's only one way to do it. But what we can do is we can reprice some of the operations. As I mentioned before, every operation is denominated in gas. So if we change the amount of gas that an operation takes, we can kind of homogenize these operations. And with that, we can, again, increase the gas limit. What we also are thinking about is homogenizing the operations across the different resources. As I said, we have data, we have compute, and we have state. And right now, we are limiting them with the same gas limit. But that means if there's an edge case in compute, it means also that there might be an increase in data that we could do, that we, in theory, that we cannot do right now because we are limited by this one edge case. So hopefully in the future with repricing and multidimensional metering, we can get all of the resources to kind of match each other. And how are we doing this? We have built a comprehensive benchmarking suite, or we are building a comprehensive benchmarking suite. And the idea of it is it will be available for all Ethereum clients, and it will also be available for all L2s because they face similar problems. It's a bit easier for them because they can just scale up the nodes. They can just scale up the sequencer. But in theory, the same problem happens to them as well, that there are some operations that might be really, really hard that they cannot get rid of or that they cannot reprice. So if we reprice, we also reprice for all of the L2s. And this benchmarking suite is part of the EEST, the East testing efforts. And I thought there was supposed to be a picture here. Anyway. And yeah, we are proposing a bunch of repricing EIPs for Amsterdam for the next hard fork, which are trying to change different values where we think we can then increase the scale. For example, so 8007 is a meta EIP that contains all of the different EIPs that we think, and most likely we will not be able to ship all of them, but if we ship the most important ones, we have like kind of an internal ranking what we would focus on first. It would already greatly improve the scale of Ethereum. So how can you think about this? How can you think about what we're doing? So this is a screenshot from our benchmarking platform. Here you can see the test names, but we have so many test names that you cannot read them right now. But you can see the test names, and you can see how much megagas per second they can run at. And if we like draw a line, we can kind of draw the line here. So this is roughly what we can do per second. What we want to do is kind of reprice, and what this also shows, that there are a lot of operations that could theoretically run at 3 gigagas. But we cannot run them at 3 gigagas because we are always limited by these operations here. What we would like to do in the next half a year is we would like to take that line from, I think it's about 40 megagas per second that we can do right now. We would like to take that line to roughly here, where it's about 120 or 140 megagas per second. And that means all of the operations that are, where you can see that are like lower than the line, we would either need to optimize them quite heavily, or we would need to reprice them. And that is what we are trying to achieve in Glamsterdam. Okay, so where will the journey take us? As you've seen on the first on previous slide, I showed the gas limit, and we were at 45 million gas. We have already done a bunch of repricings in Fusaka, and we will be able to hit 60 million gas by Fusaka. So all of the clients have already introduced this gas limit increase in their releases for Fusaka. And we hope that in the next year, we will be able to hit somewhere around 140 or 150 megagas. Because of the repricings, gas might not mean the same thing anymore. We might change the way a lot of operations are priced, and so it could be that that this number might change, that it's not 150, but it's 300 or 500. But what I'm trying to convey here is this is roughly, in today's gas, with today's schedule, this is roughly what we expect happening over the next year. All right, if you're interested in this and you would like to contribute and you think this is really cool, join us. We are always looking for great people for the Ethereum Protocol Fellowship. There's a study group where you can permissionlessly join, and there's a program that runs, I think, once a year now, sorry, where you will be able to get some resources, and you will be able to get mentorship, and you will be able to work on some of these hard problems. And yeah, thank you very much. That was it.
Excellent. We do have about 2 minutes for maybe one question. I see right here with Thorsten.
Hey, Marius.
Yes.
This is Thorsten. I hope I didn't. I hope I paid attention. You didn't already answer this. Do you have a rough timeline for ERA E and more expiry?
The ERA E is currently being prototyped. It's going a bit slower as we would have liked because people just have been stuck with Fusaka work. But yeah, I hope within the next 2 or 3 months we will have at least 1 or 2 working implementations, and then we will push the other clients to also implement the new format and also implement this this like trailing window expiry.
Excellent. Well, thank you very much for it. I think we're at time here for questions, but Marius, you will be available just outside?
I will just stand outside. If you have more questions, we can discuss for the rest of the day. Thank you very much.
Perfect. Let me go ahead and introduce our next speaker. It's going to be Ladislaus, and he's going to be talking about validating with ZK execution clients. So, Ladislaus.
Perfect. Hi, everyone. My name is Ladislaus. I'm part of the protocol coordination team at the Ethereum Foundation. Quick shout out to Jonathan, Remy, the whole Eastaker crew for organizing this event. And yeah, for the next 15 minutes or so, I'll be talking about, or I'll be reporting back, I guess, a little bit and give you a high-level overview of what several teams at the Ethereum Foundation, in conjunction with client teams, have been working on for the past couple of months, and sort of migrating us in this ZK era of Ethereum. And we'll sort of, with a particular focus, we'll look at sort of what this means for stakers. Right, and so a bit of, as a continuation of what Marius has been talking about, like the big problem we are trying to tackle and solve here is obviously this trade-off between scaling Ethereum significantly while not giving up its its guarantees, which are preserved by decentralization, I guess. So permissionless verification, fast inclusion, etc. And so over the past, over the recent past, there has been this discussion going on about, okay, what do we actually want from our nodes in this context, and sort of how we may actually rethink the role of a full node, if you will, and sort of maybe this, which has sort of been much more imminent as part of the merge, and sort of separating building from attesting, potentially in the future separating attesting from proposing, potentially including as part of a fossil, for example, and maybe another role I will talk about later on. But what has been clear all along essentially has been that the technologies we have in order to not make nodes heavier, but sort of rely on this maximally uncorrelated validator set, have on the one hand been data availability sampling, which you may have heard of in the context of scaling blobs, and zero knowledge technology, which I will focus on going forward. So in the context of staking, like why is it interesting to apply this magic cryptographic technology, if you will, in our context? So I guess the main reason here is that as a full node today, or as a node runner today, when you receive a block, essentially what you do is, in order to verify its validity, you download the block and you re-execute all the transactions involved, included in the block. And so moving into this ZK world, essentially what we get from this succinct proof is that all it takes to verify the validity of all these transactions it's basically we only need to verify this proof which someone else has generated in order to be sure that the chain or that the block is indeed valid. And so basically as this tech has matured over the past I guess years, if you will, sort of the Ethereum Foundation earlier this year announced this quite massive initiative which involves multiple teams at the EF to ship this L1 ZK EVM. And basically what I want to take away for us here in the context of staking is that we will focus on snarkifying the execution side of things. And just to quickly recap, why would we want to do this? So this proofs of execution, this ZK EVM proofs, are extremely efficient. And so what we get from them is that we have basically very lightweight verification being done on very low-powered devices. Think on the order of smartphones, I would say. And the great thing also is like the verification happens consistently fast, independent of the statement we are proving. And so what we actually get is sort of a standardization of the cost of block processing. And the final great thing sort of for us as stakers, as testers, is that essentially as we receive a proof which guarantees the block's validity, we don't need to store the full state anymore. And so what this essentially means in terms of benefits for stakers is that we can massively reduce the cost of running a node. And as I alluded to earlier, verification of such a proof is super lightweight, so the CPU load we require is extremely low. As we don't hold the full state anymore, the RAM requirements, for example, for state caching, are also extremely minimized. And probably the biggest advantage is that as we don't have to hold the full state of the execution layer anymore, we can essentially get rid of this very intense sort of disk requirements we have today. And so all this is, well, there's a second big benefit, right? Faster sync times. So imagine instead of sort of downloading all of the state history, you can basically download this ZkEVM proof and somewhat mimic this this functionality we have on the consensus layer today, which we know as checkpoint sync. So similar to that, we downloaded proof of execution, and instead of having to download all of the state history, we can essentially sync a node instead of days, like on the order of seconds, if you will. And all this is to allow us, to on the one hand, like massively scale Ethereum L1 while allowing for anyone to run a verifying node. And so diving a little bit deeper into what this means for the node architecture for attesters. So on the left-hand side, you see like the current world where we have like two stateful nodes, like for the CL and for the EL, and we basically have this engine APIs, this interface communicating between both layers. And sort of, if we now look at what a ZkAttester client would actually look like, is that we mostly remove the engine API functionality. So we remove a massive amount of code, if you will, as we still need the consensus layer client, and as on the consensus layer client, basically instead of downloading a proof and asking you a full like stateful execution layer client, can you check its validity? All you do is sort of you download ZkEVM proofs over let's say gossip sub-channels, and you have this integrated execution verification function, which is the super lightweight function to only verify these proofs. It can be a single binary, right? It's not two binaries, it can be a single binary, and it runs statelessly. And so this is essentially a client architecture where we have prototypes in, I believe, Lighthouse and Teku already. So this is not a pipe dream, like there is work going on this already. But, and this is sort of why I put this handshake symbol there, if we zoom out, like from the attester role sort of into the bigger sort of node role picture, it's cool to have like super lightweight testing, can be at home, can be like maximally decentralized, but someone still needs to hold the full state, right? Someone needs to be able to build blocks off of the full state. So we still need this role of a stateful builder going forward, and moreover, we will introduce this role of what we call a prover. So somebody actually doing the work of proving the execution. And yeah, this is sort of where I wanted to zoom in here. It's sort of, if attesters become potentially super lightweight, like who does the heavy lifting? And yeah, what's very important to note here is that proving Ethereum blocks is a very resource intensive task. It takes like on the order of 20 GPUs currently to prove a block on the order of like on average 10 seconds. And that's the second part. There is a timeliness issue currently we have, as in the re-execution world it takes on the order of hundreds of milliseconds, I guess, to prove and verify the block, but provers need to do this heavy lifting. And so, yeah, I guess the interesting, or the good news that we have here is, and that's why I brought this example here, is that proving time distribution over a certain slot of mainnet blocks, it has made massive improvements over the past 12 months. We have hardware optimizations, we have software optimizations, and in this very instance, this ZkEVM provider, ZkEVM team, I show here, sort of, it takes them with 24 GPUs, fairly beefy CPUs, on the order of around 8 seconds for the average mainnet block to be proven. And just this very morning, I saw an announcement that this number has been, like there's another ZkEVM provider who's brought down this number to 16 GPUs. So this is sort of, I guess this is sort of to say that using ZkEVM proofs in the context of mainnet has become much, much more viable. And yeah, just to highlight another thing, is it actually a good idea to introduce a new actor in the block building pipeline? And I guess important to highlight is that it's not too bad, because we actually, for liveness reasons, for mainnet, we would only need one honest entity, let's say on the globe, to produce valid ZkEVM proofs, which seems doable, particularly as we set requirements for mainnet blocks such that that proving remains accessible, let's say. And just to contrast this, right, for the consensus to work, like for the chain to make progress, we need this at least 50%, right, and half over n, this honest majority, which is in this sense like much worse. So this is to say that introducing, or the worries for, I guess, proof of centralization potentially is not necessarily valid. Okay, rollout plans. I guess what you realized when I showed these 8 seconds average proving time is that 8 seconds is way too long, right? It's beyond the attestation deadline for the current protocol specs to have for testers to remain sort of to have timely attestations, right? And so actually, what we will see this upcoming Saturday is a live mainnet demo of a community member who will, regardless of the fact, shut down their execution layer client and download ZkEVM proofs and sort of run their mainnet validator based on this. But, which is great, it's sort of a great proof, right, that this actually works. But yeah, I guess the issue is like this individual will suffer timeliness penalties. And so what we actually need in order to this be like a more rational thing to happen on mainnet, we would need some form of block pipelining, right? So we need, and which is what we get with the Glamsterdam upcoming hard fork. So namely the EPBS update, or the EPS EIP, which will sort of bring us the separation of block execution from block validation. And so with this, what we would call delayed proving, provers will have much more time to generate this proof, and the testers will not sort of suffer from this timeliness penalties. So this is an optional phase. There's no hard fork necessary, at least, to opt in and run these clients. But again, it's economically irrational until at least some form of block pipelining. And there may be a second phase where we say, okay, now that that we want to make these proofs what we would call mandatory. So mandatory in this case means every block would have to be accompanied by ZkEVM proofs, and all validators need to verify that there are sufficiently many of these proofs indeed available before they attest. So this would actually be a change to the fork choice rule, and sort of yeah, some would use this term enshrinement, but essentially ZkEVM proofs would become mandatory for all validators. Right. So in the immediate near-term future, like before this is relevant for testers and stakers, we need to make sure, yeah, we need to make several more things much more robust. And the one thing is ZkEVM security, right? Proving or generating the ZK proofs relies on certain mathematical assumptions, conjectures, which in the context of the L1 we wouldn't consider, I guess, hardened enough. We also need to standardize a lot of these ZkVMs we have. We need to standardize changes to the execution layer clients we have. We need to do rigorous benchmarking on the combinations of ZkVMs and ELs. And obviously, ZkAttester clients still have to be built. Okay, cool. That was a quick rundown. There is a write-up on this, fairly high level, which goes a little bit more into also the details of what the changes to the engine API would look like. And I would suggest you to also take a look at the Ethereum Foundation's ZkEVM team, the team website. They have recently published a blog post on benchmarking ZkVMs. And so, yeah, that's basically it. And yeah, happy to take a few questions. Yeah.
Oh, this is tough. I want to hog the mic. First question. In this future, am I hearing right that local block building is out?
Yes, so you're right. If you run a ZkAttester client, you don't run you run a stateless client, and you won't be able to build locally. And maybe that's also a reason to double down on fossil. Like, this is a personal take, but yeah, we need to make sure that as we want to scale Ethereum, as we want to unbundle roads, that there are in-protocol guarantees for making sure that what we get from local building today, which is fast inclusion, right? Mainly fast inclusion, among other things. Yeah, this guarantee is preserved.
I agree with your personal take on fossil. Second question, have you had discussions yet what this means for the bond of attesters?
Right, yeah, so the 32 ETH requirement is sort of a different, it's an orthogonal question to this. Like, this will potentially change as part of the snarkification of the consensus layer, right? Some of you may have heard of this lean Ethereum lean consensus effort, which has started earlier this year, and this would potentially introduce like the snarkification of the consensus layer, and therefore potentially also allow for changing the bond. But ZkAttesting, so the snarkification of the execution layer, is a separate discussion.
Perfect. Okay, one question on the other side of the room.
Thank you very much for the overview. I have the following question. So right now, when you run a validator node, you have all of the toolkit at your hand. So you got the block, you execute the block, you validate, and you don't need any counterparties or third parties.
Right.
With ZK, the proof should come from somewhere.
Yes.
So you should either trust someone to provide a proof in a reasonable amount of time so that you can attest,
right,
or it should be somehow included at the network level so that alongside the block you will also get a proof so that you only need to verify that.
Yes.
How do you see that unraveling into future?
Yeah, it's interesting. Essentially, what I just mentioned, it's the second phase is this mandatory proof. So the protocol requires proofs to be available with blocks, and in the first phase we rely on provers, like a third-party actor, which, by the way, again, this one of n assumption comes into play here. So I wouldn't call it like a bad dependency. I'm fairly excited on distributed proving, for example. So call it squad proving. So it doesn't have to be this data center. Like, what we don't want is data center proving to be like a dependency for Ethereum liveness, right? So in this blog post, which from the ZkAVM team, which I highlighted earlier, like we want to set the requirements in order to generate these proofs to be sufficiently low that this n in the 1 out of n can be like maximally high.
Okay, I'm probably terrible at formulating questions. Generating proofs, even if you simplify it to the least possible extent, would still be a meaningful additional amount of work. It's like a energy preservation concept, right? You cannot just save one space without adding somewhere in the other space. So this would be an additional duty, and so that it should be somehow accounted for in the consensus mechanism, I believe, with the rewards or whatever else, because those who will be doing that, they will be doing way more work than those just using proofs.
Right, that's a good question. I haven't touched upon prover incentives. So this is still like a bit of an open research question. There are ideas around on-chain prover markets, for example, so that we indeed have potentially in-protocol incentives for these actors. I personally, right now, I'm a bit optimistic, but like a good analogy right now would be potentially a slasher. Like, who here runs the slasher on mainnet? Great, 2, 3, 4, great. This is a purely altruistic task. I guess it's not the same as proving, admittedly, but there's higher requirements than running a full node, and there's no reward for it. And some people, we need like the the network relies on one honest participant on mainnet to detect slashable offenses, and apparently we have some people in the room who would step up essentially as an altruistic task.
Yeah, okay, like I still think that, probably I'm not like fully aware of what separate slasher means, but the validator who reports slashing is definitely awarded for that, so there is an incentive. And
not the slasher, not the one who detects the slasher.
Okay, okay. But anyway, you mentioned it right, that generating proof is probably a way more complicated task.
Yes, that's true.
Okay, thanks for touching it.
Excellent. Well, I know we have more questions, but unfortunately we're out of time and want to get to our next speaker. But Ladislaus, thank you very much for the presentation. Sure. And he should be available right after he de-mics here in the lobby area. So if you have further questions, feel free to follow up. But I want to go ahead and introduce our next speaker here, who is Francesco, also with the Ethereum Foundation. And he's going to be talking about single slot finality and the future of staking.
Hi everyone. Yeah, I should actually say the title was changed. I think it was it's a talk I've given before. It's similar. It's a similar kind of topic, but yeah, it's actually called Fast Finality, Faster Blocks. But same idea. Basically, I'm here to tell you about first of all, like, why should we care about fast finality? How exactly are we thinking about this? Like concretely, like, you know, what do we want to do to actually get the protocol to finalize faster? How does it relate to shorter blocks? That's not immediately clear. And then, you know, why should you care about it? Like, why should stakers specifically care about it? Yeah, a quick why, I think, just to motivate, like, why is fast finality important? I think there's a few, like, clear reasons. Like, one is there's this, like, UX security trade-off that we get whenever you could either basically choose security or UX as a user. Like, in this case, I can choose to wait for finality. And user might mean like actual user, like anyone doing a transaction. It might mean rollup, or it might mean app. You can choose to use finality and just wait for the 12 minutes or whatever it takes, and you're gonna get great security but really bad UX. Or you could just say that you don't care about security and just use something that maybe like a weaker kind of method of confirmation, or like a third-party thing, like when you're bridging or these kinds of things. So essentially, you kind of put users in this in this situation where they have to choose, and they can't just get security by default. And this basically pushes them to potentially solutions that are not actually as good as the native one. And then another reasons that you should care about it, it's not so much about the fast part, but it's more about the consensus upgrade part. And of course, we probably would do this consensus upgrade if to actually make the protocol faster. But something that we'd also get out of it is that we can actually use it as a chance to clean up like a ton of technical debt that exists in the consensus protocol. So I think, like, I mean, technical debt and also just like high level really get like optimal provable security properties that the consensus protocol today just doesn't have. And a quick note is that when we say faster finality, or I mean even single slot finality, something that has been said a lot in the past, we don't actually mean that there's only finality. There's still this idea that we have today that the chain can progress even if we don't finalize. So there's this like available chain kind of blue thing, and there can be reorgs. Like here, these gray things are not canonical blocks, but they can still exist. And there's only like a prefix that is finalized. So none of that conceptually changes. Just the finalized part is supposed to like not lag behind nearly as much, basically. Just like follow much faster. And one protocol that we've discussed a lot over the last year for achieving this is 3SF, 3-slot finality. And it's what I'm gonna call today an integrated protocol. And here integrated kind of goes at this level of like finality and availability. So there's like these two things that are happening in the protocol, and an integrated protocol is one that basically kind of smashes them together. Like both of them are essentially happening like at the same time in the same kind of way. And here you see this basically it looks quite a lot like the protocol that we have today in a way, except that basically every slot you have all the validators voting. So here you have this like head votes, but it's not a committee, it's like the whole validator set. And this is what actually enables you to get like finality much faster. So you essentially have this like finalizing pipeline, that's 3 slot, hence the name, where first like you confirm a block. This is kind of a technical thing that I don't necessarily need to get into. But after confirming, it can enter this finalization pipeline that in a way looks the same as today. It's just you first justify and then you finalize. You have basically 2 voting rounds of like the full validator set. And at the same time, another block can enter the same kind of pipeline. So at any given time, there's kind of 3 blocks that are trying to do the same thing at different stages. But otherwise, like everything looks quite the same as Gasper. Basically, you have like head votes, target votes, like source votes. So it's like same component, just in a way like everything is happening at the same time. Everyone is voting at the same time, so that we can get finality much faster. But there is kind of a problem with this protocol, even though this is something that like we worked on for a while and have like a really good understanding of like the security of it, like which guarantees it provides. And the problem is basically that we have this couple thing, like these 2 things like finality, availability. They're basically like, as I said, happening kind of together. Essentially just the fact that validators have to vote every slot, like all validators have to vote every slot. And this has some consequences, like it's basically like a bidirectional dependence between like finality and block production. So one thing is that finality essentially slows down block production. So in every slot, everyone is voting. So we kind of have to wait for this like full round of aggregation in order to produce like a new block. So in a way, it's like finality is kind of, the needs of finality are dictating how fast we can move, basically, in terms of block production. And this means also like we can't really have too large of a validator set, because you can't have millions and millions of validators voting every slot if you want to have blocks that have or slots that have a reasonable length. And on the other side, block production also slows down finality. So block production has its own needs. You have to propagate blocks, you have to execute them. There's some other things like a bit more technical that you may want to do to ensure that, for example, the next proposer is sure that they can produce a good block that's not going to get reorged. So there's some things that are happening in a slot that actually have nothing to do with finality. And they actually just end up kind of slowing down the finality pipeline and getting in the way. And to kind of visualize this, you can, I think there's a missing slide. Okay, it's okay. Yeah, basically, you can think about it as, yeah, I mean, we can take basically the case study of Gasper to think about this, so the current protocol, where we essentially have like a very similar structure. We still have slots, we still have like committee voting, or like some amount of voting every slot. And you might think that in Gasper timelines are not coupled because you have these like long epochs where finality happens, whereas slots are much shorter. But actually the timelines really are still coupled. And it kind of manifests in this way that if you were to basically have smaller committees, this would help you with shorter slots. So you could say, okay, why do we have 30,000 validators voting every slot? Let's just have 1,000 validators voting every slot. This probably is going to let us have shorter slots. But this would mean very, very slow finality. And on the other side, you could say, okay, why do we have this like, in a sense, still small committees? Why do we have like epochs that are 32 slots long? We could just have a bunch more people voting every slot. This would make finality faster. This would mean that block production slows down a lot. So the same exact trade-off essentially like exists in the current protocol, and the current protocol just finds like a compromise between the two. It just says, okay, one epoch being 32 slots is reasonable enough. You get like good enough finality, good enough slot time. In practice, in a sense, you get neither really good finality nor really good slot time. So it's kind of it's a compromise, but it's not a great one for either of the two sides. And yeah, 3SF doesn't really change fundamentally this trade-off. It just says, okay, let's hope that we can basically have really good consolidation, actually near perfect consolidation, having like almost down to the validator set being equal to the node count. So kind of fully getting rid of this like overhead factor. And yeah, if we assume that that's going to be the case, then we can say that, okay, instead of a committee, that can be the whole validator set. And all of a sudden, we can get much faster finality without actually creating too much of a problem for the slot time. But still, the underlying trade-off doesn't really change. Like both sides are kind of getting in the way of each other. And a decoupled protocol is kind of a way out of this, where you can actually say, let's just pull apart these two things. We have finality, we have availability or block production. Let's just separate them. So you could say, okay, there's maybe some small enough committee size that we're fine with from a security perspective. Let's go with that. from the perspective, let's ignore finality for now. Let's just say, this committee, Vitalik had a post where he said this could be 256 validators, could be 500, it could be 1,000. We can argue on the number, but this number would have nothing to do with finality. It would just be its own kind of independent assessment of what this number should be. And so you could have a much smaller slot, basically, because this part gets compressed. And finality could have basically its own separate timeline, where on this timeline, what you care about is just as fast as possible, aggregating votes from the whole validator set. It's not kind of interacting with what's happening in terms of block production. You're not trying to have a round of voting, then do some things that are related to block production, then another round of voting. You can just do rounds of voting as fast as they can be, basically. And then, what this looks like in terms of the, trying to compare with 3SF, you would still have this confirmation phase at the beginning. That's basically getting a minimum level of security on the available chain. And now you enter the finality pipeline again. But now the finality pipeline is just directly kind of just going ahead with the voting rounds. And it doesn't have to kind of slow down to accommodate the available chain. And something that's kind of a recent, I don't want to say discovery, but essentially something that we didn't know before. For quite a long time, we thought, it would be nice if you could do something like this, but there's problems once you try to use committees on the available chain. This was this key part that just didn't really seem to work. Whenever you tried to put committees on the available chain, security properties would just break, essentially. So we didn't really think that we could actually do this. But as of recently, we actually have a design that essentially achieves this, that gets the same kind of properties that 3SF does, or whatever properties you want to write down for the kind of protocol that we want, that has this available chain and finality component. You start with this and you define some security properties, and essentially we now have a design that actually achieves all the security properties that we would like, without actually needing this tight coupling, essentially, between the two layers. And basically, once we have, now that we have a design like this, this enables us to do a few things. One is that basically we can just have both. Essentially, we can have the best of both worlds. We can have fast finality. We can have faster blocks, faster than the finality timeline and faster than today, even. And basically, just both can be as fast as they by themselves can be. They don't have to kind of talk to each other and agree on, you can only be so fast as it allows, finality doesn't have to kind of worry about how much it slows down block production and vice versa. Basically, it's both can be optimized independently. And this also means that we don't really have this hard dependency on the full consolidation of the validator set if we want to do an upgrade such as this. So before we basically always had this idea of, okay, if we do want to do this 3SF upgrade or whatever other form of this that we've kind of discussed over the years, we first need to get down to 30,000 validators. For example, the amount of validators that today are voting in a single slot, maybe it could be a bit more, maybe a bit less. Then there's shorter slot times. This idea that this is something we want to do in the future. This will also kind of put extra pressure on this consolidation process, because all of a sudden, if we have 6 seconds instead of 12, we probably would want to be even more sure that we can squeeze a whole voting round for the full validator set in there. So we basically have this really hard dependency on getting the validator set down from 1 million to almost maybe 30x less or 100x less, more than an order of magnitude. And now in a way this goes away. Once we're working with this kind of decoupled protocol, this hard dependency is not there anymore. What happens if the validator set is, let's say, 200,000 instead of 30,000? It's just that we finalize slower, but it doesn't actually kind of break the protocol. It doesn't mean that now we cannot do voting rounds in the basically time of a slot. This kind of finality process is happening on a different separate timeline, and the slot time that we can support has nothing to do with it in principle. And and this also kind of means that we don't need to worry so much about putting really strict mechanisms in protocol to ensure that there's a maximum kind of validator set size. So before we had always this worry of we have to really ensure that you cannot go beyond 50,000 or whatever the magic number is once we've made this upgrade. You can just upgrade and then some staking pool decides to split up their validators or like enter a bunch of like 32 ETH validators, and all of a sudden we're back up to like 200,000, and I don't know, slots just are not long enough anymore for a full voting round. So now this dependency kind of goes away, this worry goes away. If something like that happens, the only thing that happens is that finality can degrade, so finality can become longer. And I mean, we can put still incentives in order to kind of really try to ensure that this is not the case, but it doesn't become, it's not quite as bad of a worry. We're not really worried that the protocol is going to break or something like that. And yeah, I mean, this is maybe a bit like surprising that I'm saying this, because maybe if you knew that I was going to talk about fast finality in this crowd, you'd expect that I would just be trying to convince you to consolidate, and now it seems like the story is changing and consolidation is not really that important anymore. And well, this is not really the case. Actually, I'm still here to tell you, like, fast finality does matter, fast finality does need consolidation, and you should like try to think about, in whatever, whether you're a solo staker or a staking pool or whatever, in what way you can try to help the network with that. And the reason is, like, sure, we don't have this hard dependency anymore. We could, in principle, do this upgrade even without getting down to like 10,000 validators or something like that. But still, we're only going to get the benefits if actually the validator set is consolidated from the perspective of finality. If we have 800,000 validators, we're still going to finalize in a similar time as today. It's not going to all of a sudden go down by 20x or something like that. So basically, yeah, we really only get the benefits if we actually put the work. And the other thing is that in terms of thinking about scheduling protocol upgrades, this is going to be a massive effort from really every point of view. Like, at like the speccing level, testing level, at the level of like consensus devs, like trying to figure out how this transition is going to work. So there's a ton of work involved. We're only going to do this work if it's actually worth it. So we're only going to do this work if it actually gives us like real benefits in terms of finality. So still super important for everyone to think about how they can basically contribute to us getting there. How can they contribute to consolidation? And yeah, I mean, I think this is kind of an exciting time in the realm of like fast finality and this like stream of work, because I think we really realized that this is one of the really weak points, I think, in Ethereum's story. There's a lot of concern that this is something that Ethereum really does not do well, and where it really should be doing better. There's much better kind of guarantees that we can provide much faster, and so there's a lot of interest in having this happen. And we also kind of now have a bit of a better idea of how we can go about this in a way that, as I said, doesn't run into these like hard kind of blockers of like, okay, we can only do this after like 100x consolidation or something like this. So it's really kind of exciting times there, but there's still a lot of work to do. So from the protocol side, I think what we want to do is really like ramp up on this work in 2026 and really try to kind of finalize a candidate protocol and ideally specs. And from your side, from the staking world side, I think what we would basically ask is just like think how what's your strategy around consolidation. If there's any blockers that you have, try to talk to us. Try to figure out what are timelines in which we can resolve them. Like what things, even like at a protocol level, could help you. Let's talk about any EIP that's on the table or will be on the table in the future, about any tooling improvements, probably even more important than EIPs. Let's basically talk to us, try to help us, help you, help the network. This is really important, and I think in maybe 2-3 years, we'll look back and see that, okay, we actually did the work and we can enjoy these great benefits. Thank you, that's all.
I see lots of hands for it. We have time for one question, so I'm going to grab this side of the room over here.
If you decouple the finalization and this whole concept basically from the epoch transition, then could you possibly get rid of all the epochs as well and just have slots coming in without any epoch transition?
Yeah, I mean, I think there might still be a reason to have some concept of epochs for example, something that shows up when you work on this, like on trying to fix problems in a consensus protocol, like said very broadly, is that you have to keep track of more things than you do today. Like now, in a way, like things are a bit streamlined in the way the Beacon chain does state transitions related to consensus, but this creates problems. And I think to solve these problems, it probably would still be make sense to have some kind of sense of epochs. It's a bit hard now to explain without getting into like too many details. But yeah, I think there's probably like some things that don't make sense, like some aspect of what we do today with epochs that will not make sense, and some that will. Maybe I can say that.
Thank you, and Francesco, you'll be around for questions afterwards. I think my lesson to myself is every time that we host one of these events and we have a core researcher from the EF come, we really need to provide more time for their talks and questions afterwards. But thank you for offering to stay here. But I'll keep us going because we do have quite a lineup of speakers still yet for the day. So our next speaker is Advaita with Nimbus, and he's going to be talking about shrinking your node. So please welcome Advaita.
Hey everyone. So I'm Advaita, and I'm been working for 1.5 years with Nimbus, primarily on the execution client, which this presentation or today we are talking about. And let's see what we have achieved and from where are we exactly coming from. Nimbus, it has always been at our ethos to create clients which we can run on any low-powered devices, or anyone doesn't need an extremely extensive hardware for it to run. And we have been quite a bit building on this, but it's not really easy. It's definitely an engineering challenge that we are trying to achieve here. So, yeah. This presentation is kind of going to be divided into 3 parts. From the past, from where we are coming from, and what we are currently offering, and in the future what we plan to. Definitely the future is much more interesting, but just bear with me for the past and the present. Yeah. So in 2019, we conceptualized like creating Nimbus and writing the execution on the consensus client. In 2020, it was the first release of the Nimbus consensus client. We were one of the first, been there from the Genesis, and it's been some time on the consensus execution client work. But in 2025 September, we launched our first alpha, and it features low storage requirement, lesser dependence on the B2B layer on Def P2P, and it also comes with Nimbus verified proxy, which we're going to discuss later. Then in October, we also did release the proof of concept single binary, which packs all 3 parts of a node, which is the execution client, the beacon node, the validator client, and it also packs something which is known as EL sync from CL. It doesn't need to rely on the P2P network completely. Later, I'm going to elaborate on that later. So what we are offering today, we have all the separate parts like Nimbus consensus client, Nimbus verified Web3 proxy. Like if you don't want to trust the RPC that you are using, just use this one in the between, and you are pretty safe. Now we have the Nimbus execution client and the Nimbus single binary. This presentation mostly would be on the later 2, Nimbus execution client and the single binary. So what, as the execution client, we are offering? We are offering a very minimal set of requirements so that anyone can run a node. And to emphasize on anyone, like anyone maybe with a Raspberry Pi and NVMe storage can just do it. We were just talking with PyBox, and it seems like we can get it going there. But yeah, bad internet at the Devconnect venue, we couldn't prepare the demo. We are also providing different storage modes so that you don't need to bloat up your storage. It comes with really low minimum storage requirement. How we are doing that, coming to that on the next slide. And it also comes with a single binary package. A lot of you need to run an EL, a CL, and the CL comes with a BN and a VC. We just don't want like solo stakers to be doing that. I'm a lazy person, and I would be just happy to running a single binary, and it takes care of everything. So with the Nimbus execution client, you can just run an execution node with 200 gigs of disk space, which is just crazy. How we're doing this, it is just aggressive history expiry. But since as a full-fledged EL client, we have to offer a lot more. We have the options of different types of storage that you want to select from. If you just want to keep the state and want to maybe use the RPC to fetch the balances of the accounts, then just use the states. It's way layer, but it's a custom setting. We don't ship with it. You just have to pass the flags to make it run like that. The default mode would be the 6 months of blocks and receipts, which gives us around 200 gigs, including the state. So this would be pretty good to go with everyone. Like, you can connect wallets to it, you can use it as a private RPC, you can connect it to the CL, and do pretty much everything. Then the next one, which is like more the status quo, post-merge blocks and receipts plus state. Right now it's optional for us to store blocks pre-merge. So yeah, and obviously you can run keep the full history, or something which you offer is selective blocks or receipts. Maybe if you are using Nimbus EL as the backend for wallet, maybe you want to just keep the receipts, not the blocks. So sure, we also have that option. Yeah. So why do we need a private RPC, or why this lower storage requirement? Anyone or any HNI with a meaningful wallet balance wouldn't like to trust Infura or any other publicly available RPC, because yeah, you can just get hacked, scammed, or maybe your transaction is altered on the way and you are shown something different. Yeah, I wouldn't want anyone to trust that. Just run the Nimbus EL, and it comes. You can run the Nimbus EL and the Nimbus Light Client. Light Client just takes no space at all, and you can just connect the wallet to the Nimbus EL. You should be good to go with 200 gigs of space. Anyone pretty much with a meaningful wallet balance would be happy to spend $300 for this. And you can just also do it on a Pi box, Raspberry Pi, and get it done. So yeah, that's kind of running Nimbus on low-powered devices. And then comes the single binary. So we always wanted running like Ethereum should be a very simple experience, shouldn't be too much complicated. We tried to work on this for quite some time, and now finally we have the single binary, and it actually opens up a lot of options for us to explore. We are going to come to that one by one, but let's first explore how it looks and how the interface is of the single binary. Yeah, so this is like a screenshot of the Nimbus single binary running on Kody, and you can see it starts up both the EL and the CL, and it is communicating properly, syncing. It doesn't need any kind of external setup. It's just as simple as you just pass network, data DIR, good to go. Like, live a happy life. So are we restricted to only running Nimbus, CL and EL together? Not really. If you want to run it as a single binary, you can do it, like pass the network, data DIR, it should run. If you want to only run the execution client, be happy. We also have that option. Nimbus beacon node comes with the CL and the VC together, so you can also select that. And this is the interface that we are trying to expand on, and also include later the light client in this interface, so that people don't need to check for different releases. It's just one thing. You just download, you have all the options available. If you want, as a node operator, want to run separately, feel free to do so. Yeah. So what does the single binary opens the doorway to? It's like as Nimbus we come under IFT, and one of the projects initially was like the status application, and we wanted a private RPC node behind our application, as we don't want to trust any external guys, or it needs to be independent for it to be truly decentralized. So yeah, you can spawn an Ethereum client to any other application which maybe needs it. Second, have a private RPC in your local machine. Don't depend on anyone. I don't like to trust anyone. And reduce dependency on the P2P sync. Like the def P2P layer, how are we doing that is like when it is a single binary, we have complete control over the database. The CL has also the history. So if we want to sync the EL from the CL database, it is quite possible inside the single binary. We just import blocks from the CL DB and process it. So what's the future? The future that we want to move forward to is like a more harmonious approach towards Ethereum clients. It's like a shared database between the EL and the CL. Right now, if the EL is storing 6 months of history and the CL is storing 6 months of history, it's just redundant. We don't want to waste storage space like that. So with the complete shared database, we want to keep a separate history database inside the single binary, which will be used both by the CL and the EL, and no redundancy at all. It can also use the ERA1 and ERA files to sync. So if this question comes up like, what we are not storing history for that long, it might be a problem, but no, you have the ERA1 and ERA files, and also the Nimbus execution client can sync from both ERA1 and ERA files, which is like a very nice feature. History network is also another solution that we have been aggressively exploring. It's not there yet, but yeah, we are fully exploring all the options of reducing storage and relying on a separate history network. So yeah, pretty much this is like how the shared block database would be communicating with the EL and the CL, and the goal would be to reduce a little bit dependency on the def P2P and make the whole overall package a lot more stable. Yeah, so are anyone of you guys running Nimbus? If not, just try it out. You don't have to spend a lot on the storage. The performance is good, and we are always there to help you. So yeah, is anyone running Nimbus CL should try out the single binary and the execution client. It's an alpha, the execution client, so that's a disclaimer, but yeah, planning for the beta release in the first quarter of 2026. Open to all of your suggestions and whatever your feedback are. Always there to fix any issues or include new features. Yeah, thank you, and please join the Nimbus community for any suggestions.
Excellent. We do have about 5 minutes for questions here. Are there any questions?
So forgive me if I'm not familiar with Nimbus. How does it handle MEV?
As in like
external? Is that external running the program?
Yeah, yeah. Like what exactly do you want to understand from the handling MEV point, like from the single binary package, or
the single? Is it so we have to run MEV on a separate?
No, the single binary as of now don't support that.
Doesn't support it. Okay.
Yeah. But if you're running the single binary as a separate one, like execution and CL, you obviously can integrate it.
Okay.
Well, let me just ask a follow-up question on that. So if we use the binary, we can't add a sidecar like mev boost or mev commit?
Yeah, not as of now.
Not as of now.
But yeah, in future for sure.
Okay, excellent. A couple of questions over here on this side. Let me get the gentleman in the front row first, and then off to you.
Will it run on Raspberry Pi?
What?
Will it run on a Raspberry Pi computer?
Yes, it should, yes.
Same line of question, curious about CPU benches comparing single binary between running the two execution layer, consensus layer.
Yes, so we don't have the metrics of like CPU performance for single binary because we just did it before Devconnect, but yeah, for EL and the CL is obviously it's available. Maybe come to the Nimbus booth, we'll be happy to share and discuss, yeah.
This is a question from YouTube from Tio. He's asking any plans to support Quick?
Yes, it's again, it's dependent on the whole Ethereum. It's not that we are supporting it, but yeah, we are very happy to integrate it, and we're looking forward.
Thank you.
Lots of questions still coming in here.
Thank you. So if I'm understanding correctly, with the 6-month expiry, because that's not part of the full node specification, it would be technically called like a light client. How does that compare to other light clients like Helios? Or I'm not very familiar with the space.
I'm not very much familiar with exactly like what under the hood Helios does, but I'm not sure if it's a full-fledged execution client which stores the complete state, and it can validate blocks and everything. But
oh yeah, that it maybe doesn't execute the full state transition.
Yeah, maybe.
Just quickly, someone asked whether you can run it on a Raspberry Pi. Have you guys run this on a Raspberry Pi on mainnet?
Not the single binary yet, but the execution client, yes.
Okay. Thanks.
Quick question. You mentioned the CL sync thing. So you can sync the EL using the CL. So
yes.
Doesn't that still require the EL state to sort of bootstrap adding the execution payloads, or how exactly are you doing it just with the blocks if you're checkpoint syncing it?
Oh yeah, if it's checkpoint synced, we can't, because the whole history is not.
So you have to sync from Genesis in order to be able to do that?
Yes, but for what we are planning to do is like we are not completely relying on the CL for that sync. It's like for the short distance syncs when the EL might be falling out of sync for maybe some other reasons, or it is trying to catch up with the CL because of maybe some non-finality happened in the network, it can just use the CL's database. You don't need to connect to peers and completely depend on that.
Okay, thanks.
Excellent. Let me know if we have any other questions in the room. I did have two, since I'm not seeing any hands up here, I guess. One of those is just maybe retrospectively, if you look back, right? I get the history of Ethereum between proof of stake and proof of work and the execution clients, and now there's what, 3 or 4 different types of clients, or depending 5, how you want to count, right? Execution, consensus, validator. You got some sidecars of the MEV boost or MEV commit. You've got your slasher if you want to run that. I mean, if you were to look back as a core dev here, would you have designed it that way, modularized, or would you have created a single binary, a single execution?
I mean, looking back, I would obviously do a single binary, but since Ethereum is eternally evolving, I think this was bound to happen. Like, we are changing specs, we are trying to improve, we are trying to adopt every new stuff that is making us future-proof. Doing that, this separation is was bound to happen, and it is kind of better in the development process, but that doesn't mean that we shouldn't have a single binary option, which makes the life of solo stakers easier.
Absolutely. And then let me ask you one second follow-up on that last statement, which is, you mentioned that you're in alpha, ready to go to beta. Are you just recommending that on the test nets or on mainnet, or just as a node but not a validating node? Like, what are you recommending?
Yeah, you can run it as a node but not as a validator because it's alpha. Okay. You can use it for its RPC, you can use it on testnets full-fledgedly, so yeah, feel free to do so.
Okay. Any last questions for it? All right, well, please give a big round of applause here for Advaita. All right, we have one last talk before our break here. Our next talk is going to be by Luca Winter, and he's going to be talking about improving Ethereum's resilience.
All right, hi everyone. My name is Luca. I'm the CTO at Serenita, where we specialize in staking Ethereum. And I'm here today to tell you more about how we, not just we, but we as a community can do better, and how we can improve Ethereum's resilience with multi-node validator setups. So this talk will be about the topic of client diversity. We've heard a lot about clients. We're not done yet. Then we'll review the Holešky incident, which was basically the worst case scenario that can happen when it comes to client bugs. And we'll finish off with talking about how we can do things better going into the future. So what's client diversity? Client diversity is the idea of having multiple clients so that in case one client has an issue, Ethereum doesn't stop, we just keep going. This has been helpful in the past, and we hope will be helpful into the future. This idea has resulted in multiple clients being developed. So we currently have, as you can see, like 7 different consensus layer clients, 7 different execution layer clients. If I missed any, sorry. They're not all production ready, of course, but you can basically use any of those if you want. And if the entire network spread out the usage of these clients all across the network, then we would see each client being used by about 15% of the network, which would be an amazing thing. But of course, we know by now that reality is different. So in reality, we see, well, first of all, the client usage data is kind of vague. We're not completely sure how many clients, how many validators are powered by which clients. So it's kind of tricky to tell what the situation is, but we know for sure that it's not 15% for each client, right? So there's a question to be answered. Do we actually need all of these clients? Do we need client diversity? Like I mentioned, we've seen client diversity help Ethereum in the past. So I made this overview of client bugs that have happened in the past. Not all of the client bugs, because there have been many. These are only the ones that affect consensus. So it's basically only the client bugs that had an opportunity to derail some of the clients from the correct chain. While doing this, I run into the issue that there were so many of these bugs. They didn't fit in one slide, so I divided it up into the proof of work era, and later on we'll see the proof of stake era. So as you can see, there have been a few. This is not my way of saying client devs suck, not at all. This is just reality. This is going to happen completely fine. It's a complex piece of software, and bugs are completely inevitable. Well, you could avoid them, but it would cost 100 times more, so this is probably better to just have multiple clients. So this is the proof of work era. Moving on to proof of stake. It's been a little more quiet for a few years, if you notice, between 2020 and 2024. Not that many bugs then. But then back in January of 2024, that was pretty interesting because as you see, like in the span of 2 weeks, we had 2 client bugs, execution layer client bugs hit mainnet. So that was a pretty interesting period, and that triggered some node operators to start using different clients, which was good. And then we had the big incident, Holešky incident, at the beginning of this year during the Bactra network upgrade on the Holešky testnet. We're going to talk a bit more about that. But I prepared this slide earlier this year, and since then we've had more client bugs pop up. So I had to update the slide. Yeah, just to give you an idea how many of these bugs occur, it's a reality. So let's look into and quickly review what happened on Holešky. The Holešky Bactra incident. So Bactra was the next network upgrade to hit Holešky. It was scheduled for February 24th at 9:55 p.m. And only 6 minutes later, something happened. So what happened? People started seeing these kinds of things in their logs. Invalid blog. Basically, they were seeing invalid blocks being proposed on the network. But the funny thing was, most of the chain kept going. And so initially, nobody was all that worried. Everybody thought this is going to be fine. Do we still have Marius in here? Yeah, there he is. So basically, Geth, Nethermind, and Besu agreed on one state of the chain. And as I said, the network kept going. It wasn't ideal. There were like blocks being missed and so on, but it kind of kept going. So people were not too worried initially. But then, as people were investigating what is the cause of these invalid blocks, the mystery unraveled. And by the timestamps, by the way, you can see this is about an hour after the bug appeared. So it takes a bit of time to figure out what exactly is going wrong in these kinds of scenarios. So at that point, people figured out that Reth and Aragon were actually in the right there. And yeah, then the worry started, okay, what if this invalid chain finalizes? As you can see, some more confirmations came in. This is an hour and 20 minutes after the consensus bug appeared. So yeah, it takes time to figure out what's going on. And the end result of all this happening was that validators started to vote for this invalid chain to finalize. It did not get finalized all the way, but they did vote for it. Then there were 5 forks, and it was a whole mess. And the complete end result was that the Holeshki testnet needed to be deprecated ahead of time before it was planned. So, as we've seen, it can happen. And how bad these things get kind of depends on what the whole network does. In this case, a lot of the network ran those 3 clients that were affected. That's why it was so bad. But just to quickly review the different cases, in terms of how many validators vote for the buggy chain, if it's only about 20%, then the impact is negligible. The chain keeps finalizing, and basically nothing bad happens if the bug is contained to only 20% of the validators. But as soon as you start hitting larger numbers, 40%, then it already starts getting messy in certain edge cases. And even though the 40% is unable to finalize their chain, it can still get quite messy, and the people that vote for this 40% buggy chain can still lose up to 22% of their staked ETH, which is quite a lot. And for this kind of scenario to happen on mainnet today, only 1 client bug is needed. A very specific kind of bug, but still. And then we reviewed a Holeshki kind of situation where more than 2/3 of the network is on the wrong chain, and that's where it gets very tricky, because you can't just go back to the correct chain, and you stand to lose up to 100% of your staked ETH. For this to happen on mainnet, right now, 2 client bugs need to share this kind of correlated bug. Going back to the Holeshki incident, in this case, we had more than 2/3 of the validators voting for this incorrect chain. When is this going to happen on mainnet, right? We hope it never does. So that's what I'm mainly here to talk about. How do we assure that we don't get that situation on mainnet? So there's a few approaches. We can just stay ignorant about the issue and just act that it doesn't exist. We can do this, and I feel like that's what part of the network is doing right now. We hope for the best. We hope that it doesn't happen. We just, yeah. But that's not what I'm satisfied with, so I'm going to show you how you can actually do things better and in practice. So one of the things you can do is split your validators across multiple client pairs. And that would mean, like, if this is an example where you're running 3,000 validators, you'd split them up between multiple client pairs. Ideally, minority client pairs, but basically split them up. And if the whole network did this, then we would have a very safe Ethereum in place. But the problem with this method is it relies on the rest of the network. So you basically need the whole network to buy into this, which is not happening. So what can you do about this if the network is not cooperating? You can protect at least your own validators. And one of the ways you can do that is by using Vouch. Vouch is a multi-node validator client. It allows your validators to connect to multiple client pairs at the same time, and basically only attest to a chain if those client pairs agree. So this is very useful, because if one of the clients ends up on an invalid chain, your validators are not going to vote for it. Another thing you can do is use DVT. It's a similar concept. You basically combine the inputs of multiple client pairs, and based on that you make a decision. The things that these two last approaches, Vouch and DVT, have in common is that they're pretty complex to set up. it's not that easy, especially for home stakers, to run multiple client pairs, set up Vouch with its own key manager, or DVT with all of the complexity that entails when it comes to splitting keys into partial keys. So it's not that easy to set up these two last approaches. So my question 2 years ago, when going through all of this, was can we protect validators without all of that complexity? And that's where the idea of Vero was born. It's a multi-node validator client. It's similar to Vouch, but it's very simple. It uses Web3 signer, so it's much easier to basically get started with. It's part of ETH Docker, so it's very approachable, much more approachable to home stakers as well. And just to show you, this is the concept of a multi-node validator client. It talks to multiple client pairs, and you can configure a threshold that you're comfortable with. Like, I want all 3 client pairs to agree on a state of the chain, or you can say I want 2 client pairs to agree on the state of the chain. And if one of those clients goes down, it's fine because the other 2 are going to keep things going. This is a similar overview of the pros and cons, not biased at all. It includes some nice Grafana dashboards that you might like. Has some advanced features like you can export traces as well. One thing that not many validator clients have is slashing detection feature, where Vero listens to all slashing events happening across the network, and as soon as it detects any slashing event that affects any of your validators, it stops performing duties. So if you, for some reason, misconfigure your setup, your first validator is still going to get slashed, but this automated mechanism prevents further slashings. So this is what it looks on the dashboard. Once any of the validators are slashed, it stops performing any duties. And if you're like feeling like this, the good news is it's very easy to switch to Vero as opposed to Vouch or DVT. And I'm going to show you just how easy it is. Say you're running this kind of setup. It's a very simple kind of setup where you have your execution layer client, consensus layer client, and your validator client. The first thing you need to do if you're considering to use Vero is move your validator keys into a separate remote signer. That's because Vero doesn't interact with validator keys directly. So Vero is built like secure from the ground up. It never wants to touch validator keys if it can avoid it. So once you have your validator keys in a remote signer, primarily probably Web3 signer, at that point you can switch out the validator client for Vero seamlessly within minutes, and at that point your setup is not much safer than it was before because you're still using one single client pair. But at this point you should spin up some more client pairs. Once you are happy with their stability, then you connect Vero to all 3 client pairs, set up your attestation threshold that you're comfortable with, and you're done. So that's it. You can do this thing while it's switching over in minutes, like I said. This is what the command looks like, so it's very simple. With Vero, if you set up this kind of 3-node setup, your validators are going to be immune to any single client bug, no matter how much of the network uses that single client. So that's very helpful. You don't need to worry about client usage data. You just spin up this kind of setup and you're golden. If you want to take things one step further, you can set up a 5-node setup. And again, based on the threshold you choose, you can make this kind of 5-node setup immune to even 4 client bugs. So if 4 clients share a bug, you can have your validators safe from that kind of scenario, which is even worse than what happened on Haleshki. So the goal, not just my goal, but I hope for Ethereum, is to get to a state where 40% of the proof of stake network runs some kind of client bug resistant setup. Whether it's Vouch, whether it's Vero, whether it's DVT, a combination of these 3. And if we get to this state where 40% of the network runs these resistant setups, we will never finalize a buggy chain. So we will avoid the most catastrophic of scenarios. It's one thing to lose finality for a while, but it's much worse, of course, to finalize something that's invalid. This is the setup we run. We run 5 different CL clients, 5 different execution clients, and If we can do it, anyone can. That's it from my side. I'm happy to take any questions now.
Thank you. So for example, Lighthouse already has this support, that the multiple beacon chain support built into their validator client. Like, why would anyone switch from that to Vero versus just using Lighthouse? And Lighthouse validator client also supports all the different CL interactions. So like,
the difference between the Lighthouse validator client and Vero is that the Lighthouse and every other traditional CL client validator, it only uses one beacon node at a time. It's a fallback kind of setup. So if one of them goes offline, it switches to the next one. If that one goes offline, it switches to the next one. But it always uses one client pair at a time, whereas Vero uses multiple client pairs at a time.
Use the mic? Okay, because I've worked extensively on this stuff. Implementing, not writing, implementing it in production. Lighthouse and all of the others cannot do a attestation threshold. So this idea that you say 5 of 6 need to agree on source and target during slot 0, or we're not attesting to this because we got a major bug, that does not exist there yet.
Yeah, and that's the critical piece that avoids your validator from ending up on the invalid chain.
How much of the network do you think is already running Vero or like some of the others?
Well, I'm aware that many professional node operators run Vouch. That doesn't mean that they're running a client bug resistant setup necessarily, because Vouch has multiple different strategies you can use. One of them is just a simple fallback kind of mechanism, but they also have a strategy that's called the majority strategy, and that's the one you should use if you want to be immune to this kind of bugs. I can't tell you exact percentage of the network. I know Vero isn't used that much yet because it's kind of new. We know that DVT is starting to ramp up. I think SSV claims about 10% of the network, if I'm not mistaken. But they only, well, I don't want to get too technical, but their setups weren't resistant to these kinds of client bugs so far. It's only included in the latest release. So, but I don't think we're at 40% yet, and if I had to give an estimate, I'd say probably like maybe 5%.
Not really a question, but Nimbus validator client can also support that for like 2 years. But the delay traces looked very cool.
Thank you. Nimbus only supports multiple execution layer clients. So this is like CL and EL. And if you use the Nimbus CL, it can connect to multiple different execution layer clients, but it's only half of the story, so it's a bit different.
No, the validator client connects to multiple CLs.
But in this kind of way, where it confirms the attestations? I'm not aware of that, but yeah, let's discuss it after.
Just to clarify on if you're running 4 different CLs and ELs, and 2 of them pick one chain and 2 pick another, you just go with the majority.
It depends on the threshold you configure.
Yeah.
By default, it goes with the majority. So if it's 2 and 2, it will just stop attesting because neither has the majority. Yeah.
Yeah. Second question: if you're running 4 pairs, do you get performance improvements? So, like for example, if a block comes late on one of the nodes, right, but it doesn't on one of the others.
Yeah, you can get performance improvements, and it definitely doesn't hurt performance. If you look at the rated leaderboard, you'll find us on the top.
Yeah, so if you're proposing, you ask all 4 at once, and then choose the best one?
Yep.
Yeah, cool.
Thanks. You had a little secure green chick. Kind of triggered me a bit. So I'm looking at your repo. It's in Python?
It is.
Awesome. Have you got any external security reviews?
No, not yet.
Okay, cool. Thanks.
Yeah. Though keep in mind, the whole slashing protection is like one of the important features that's handled by Web3 Signer, which has audits.
Excellent. I see a couple questions in the back here.
Could you speak about the resource requirements associated with running Vero a little bit today? What's it look like in production?
Yeah. A validator client is very light in terms of processing needs. So even with this kind of multi-node validator client, it's still very light. That's why even Python works. All it does in terms of processing is make a bunch of API requests to the beacon node, make a bunch of API requests to the signer. That's most of what it does. So resource requirements are very low. You can run thousands of validators on a single node.
Awesome. Thank you for the contribution.
Yeah.
What's the right attestation threshold to be absolutely bulletproof? 4 of 4, 4 of 5, 5 of 6, 7 of 7?
That's the thing. You can't ever be 100% safe. What if all the clients contain the same bug?
Well, then it's BSC, Binance Smart Chain, right?
No, so that's definitely a possibility. What I would recommend, what we are doing is run a 3 out of 5 threshold on mainnet. And around hard forks, we increase this threshold temporarily. So we go to 5 out of 5. And if we notice, okay, this is a bug, but it's fine, we don't want to follow that chain, then we can go back to 4 out of 5. But yeah, in general, I'd say a correlated bug that appears the same way across multiple clients, coming out of nowhere on mainnet across like 3 clients is very, very unlikely. So I'm comfortable with the threshold of 3 out of 5. And a temporary increase around hard forks.
Excellent. We are out of time here, but please give a round of applause here for Luca.
Thank you.
I know there are still more hands up. He will be around during break, but we are headed to break. So 15-minute break. Please be back at 15:05. 15:05. All right, well, welcome back there. I know it's a very fast-paced day today, but I'm actually excited. I think they've saved some of the best speakers for last year, and I'm very excited for the next two speakers. It'll be a little bit of a fireside chat between two of my heroes. Thorson's going to come out and interview Danny Ryan. So please welcome to the stage.
Either one. All right.
Hello.
Hi guys. So we have Danny Ryan, and I have notes because I need to know what I'm asking him. From Etherealized, previously a researcher. I think you're really deeply involved in getting Ethereum to institutions and what that means for, well, the centralizing pressures that institutions exert on Ethereum. And the title of this talk is It's Complicated. As in, we did proof of stake and we thought, that's awesome, we're done. And we're really not even a little bit done.
Right. And I gave a talk about some other stuff recently, and I was talking about how at the beginning of 2018 I talked to Aya Miyaguchi, and she said, so when do you think like proof of stake is going to launch? I was like, I don't know, like 6 months. And it took quite a bit longer, and I think optimism and naivety, but like not only did it take longer, but the dynamics of the system, the dynamics of the mechanism design, the dynamics of the financialization of ETH, and all sorts of implications on this thing that we've been working on. We still have a lot of work to do.
Yeah. So let me ask you a probing question about institutions that you're talking to and centralization. So what I see when I talk to some TradFi clients is they have a risk team. The risk team needs to underwrite the node operators that run the stake. And the risk team is like, we can do 4, maybe max 5 of these, you know, and we need to know that they're ISO compliant and what their financials look like, etc. And so they're like, we can't do 39 or hundreds or thousands. What are you seeing?
I certainly see that, and I see, there's some gems. There's some that do want and plan on doing self-custody, which is pretty cool. But by and large, I have, kind of like sad conversations where I talk to someone, the head of digital assets somewhere, and they say, yeah, we get it. And we get that, like, by making these decisions, we might lose more money. But also, I can't remember the example they use, but they're pretty much, no one gets fired for choosing Microsoft. Mm-hmm. So it's like, actually, if we all go down together, we're fine.
Oh boy.
Which is terrifying, right? And when instead, it's like, what he's saying is, if we make an irresponsible decision and we lose all of our customers' funds, we're good as long as everyone else loses their customers' funds and we're all in this boat together. When it's like, you can just make a different decision. But they're worried about when they choose an operator that other people aren't choosing. And they go down and they look, they lose probably forego some rewards for a few hours. They're worried they're going to lose their job for that. But they won't lose their job catastrophic, because as long as everyone else is in a catastrophic scenario.
I think that answers the next question, which is, are they thinking about network health? And I think what I just heard, not necessarily.
It's a bit of both, right? Like, some of these people, especially in the digital assets teams, they get it. Mm-hmm. They understand the risk. They understand the network health, but they're also, the way that institutions think, it's like this weird herd mentality, and quite frankly, like pretty broken incentives to the people that are making these decisions. We shall see. We shall see. I do believe that, they say some of these things, not entirely in jest, but they're like, we do see these real problems. We do see, the risks associated. And there's an attempt, at least in the forward-thinking institutions, to try to navigate these in a principled way. But it's a tough space.
Have you found ways to educate, bridge the gap? Maybe, do you have ideas on how Ethereum can incentivize institutions to stake responsibly? As in, think about the network health when you're staking, not just if we all go down together, it's fine.
What is orchestrated catastrophe?
Yeah.
I mean, honestly, if somebody gets burned, they're all going to figure it out.
Yeah.
Right?
I'd like to avoid that. I have bags too.
But education is important.
Yeah.
You know, we tend to be in the room. The EF kind of enterprise team is attempting to be in the room. I've had some dialogues with the SEC about like, if these are going to be regulated financial products, isn't like the whole point of the SEC to like communicate risk?
Mm-hmm.
So if there's a big rubber stamp, and then rubber stamp's the wrong word, but you know, if you use this ETF, you can lose 50% of your money. You use this ETF, you can lose 5% of your money. I think it would go a long way, right? Like if these things were elevated as part of like the risk profile of investing in these products.
So part of the prospectus almost.
Yeah,
right?
yeah, I think that'd be great. I think it'd be great. And there's, you know, there's some people in the SEC that are like, oh, that makes a lot of sense. There's some that are like, no, that's overstepping the bounds of like how we structure products and how we talk about things, you know. But I think if we beat the drum, I mean, at a certain point it's about education. It's about actually understanding the risks. And again, when you're talking to somebody who got served by the SEC a year and a half ago, now I was talking to them, but like, they do have a purpose. Help educate consumers about risks.
Yes.
Flashing's a risk.
Yes,
Losing
it
your
is.
money is a risk. Let's, you know, do your job.
It absolutely is, absolutely. And you know, I'm very happy that there is now an organization like Ethereum who's trying to bridge that gap, which I think was truly lacking before. Do you see that institutions are worried about capture of governance of Ethereum at all? Are they thinking about this?
Capturing governance, or worried somebody else will capture it?
Either one.
They're not thinking about it.
They don't.
There is, for better or worse, the people at institutions that understand Ethereum, they're like, it's decentralized, it's great. It's neutral infrastructure, that's great. And there's not a lot of nuance to like what could go wrong with how those statements could become untrue.
Right.
Right. And there's certainly, you know, I want them to be confident and to use and begin to adopt this technology, while we at the same time kind of harden that layer. What I've been worried about for the past decade is capture. You know, of the institutions actually being like, wait, I know how to get a seat at the table. Let's build a client, or let's buy Sigma Prime.
Yes.
They have a client, right? And I think that, you know, part of the title of this discussion is turns out it's complicated. And one of the reasons it's complicated is we're not done. If by and large we were done architecting the system and it was sound and stable, and maybe that's a dream, maybe that doesn't actually exist. Maybe the world continues to evolve and continues to be complicated and the protocol must evolve to meet its needs. We shall see.
Well, maybe Justin gets his wish and Lean Ethereum solves everything, right? Yeah.
That's a different 30-minute conversation. But as long as the protocol is malleable, it is capturable, you know. And as long as Ethereum is valuable, people will want to capture it. So I think we need to be incredibly worried. You know, I think that I don't think JP Morgan's going to have a client tomorrow.
No.
It's not out of the question that they would, though.
Right.
If this is critical infrastructure and they're relying upon it, and they're not only like have staking ETFs or whatever, but they actually have, you know, they're powering some of their back office with this technology. Like, of course, it's going to make sense for them to potentially support the technology, even in a positive way. Like if you look at how Linux is built. The Linux Foundation only does so much, but like so many of these large corporations have people that just like help work on the kernel.
Yeah, like Intel and Microsoft and etc. Yeah.
And so we might see that in the financial institution world. It's like, oh, you want the expertise, you want to make sure the thing's running well. Let's allocate, and like that's like all good. That's great. I think it's a good thing that, you know, people hopefully help build and support this infrastructure. But the fact that the infrastructure is still the protocol is still being built, puts us in a precarious position once the vested interests, these massive vested interests, potentially enter the game. again, I don't think this is a tomorrow thing.
Yeah.
I think it's probably likely though.
Does the social layer need to evolve to deal with these changing realities? And if so, how?
I mean, the social layer needs a backbone.
Okay.
Like, for sure. Honestly, I joked about, like, once they get burned, they'll realize. But, we haven't actually had a good fire drill.
Mm-hmm.
There's been some. Y'all have done your job too well. Like, the network's like been more stable than anyone expected. But we haven't had to make these hard decisions of, like, what happens when there's a contentious fork? What happens when the network splits? What happens when people might lose a lot of money? And I think, after the DAO, we had a number of these instances for forking the execution layer, right? Like, I think Parity lost God knows how much money. There were a couple of these instances, and the social layer said, no, absolutely not. And it's practiced. And at this point, like, the answer is no. Like, we're not going to fork to, like, fix your smart contract.
Right.
And I kind of wish we would have had a fire drill on the consensus layer, so that the precedent was set. It wasn't just talk.
So a Holeshki style meltdown, but on mainnet.
Someone's going to quote me on this. Yes, let's have a Holeshki style. Perry, you ready?
Oh God.
Yeah, I don't know. I mean, but definitely, I think the social layer needs a backbone. I think the social layer needs to be global.
Okay, yeah, that's
when we're talking about institutional finance, for better or worse, at least from what I'm working on and where a lot of the movement is, it's in the U.S.
Yeah, it's
very
City,
centralizing.
right?
It's very concerning.
Chicago. Yeah.
I think that the rest of the globe should step up, and institutions, people should beat the drums and get. We want, like, disparate, not totally overlapping financial interests in the network at every single layer. And I think that not just the social layer of, like, the enthusiasts and the home stakers and the more crypto native, but, like, we want good stable coins across the globe. We want good staking products like ETFs across the globe. We want disparate interests to be at odds with each other, so that, like, actually the system just has to work like it is, and it's much more hard to capture. We need clients in Australia. Yep. We need client. Do we have a client in South America? Is Fede building a client?
Ethrix is in Argentina.
Yeah.
Yeah. Name checking Ethrix. Most of you have not heard of Ethrix. It's an execution layer client right out of here, Argentina.
I hear good things. I hear he has a wine bar too.
Yeah. How are we for time?
You're good. About 10 minutes.
10 minutes, great.
We're 10 minutes in. We have 10 minutes left. Damn, I can
Okay,
talk
wonderful.
forever.
If you could redesign the staking model right now with everything you know, what would you touch? This is more of a researcher thing, right? Like what you used to be.
Yeah, I've been a researcher. I don't know what the hell I was doing. That is hard. That is very hard. I think that there are some very excellent components of the system. I think that the fact that there's, like, this dynamic availability thing is a strange design decision, but I stand by it. I think we wouldn't have done the everyone 32 ETH kind of thing, like contiguous validators, patch that up. Hopefully that'll kind of fix in the network as people adopt it. I think, and this is more forward-looking, but with foresight, maybe it would have been a better decision. But, like, the separation of roles, like the specialization of potential validator roles, I think is actually probably very important. Because
so
I do think
testers, proposers, builders, provers.
Yeah. Like, if we would have had a crystal ball and seen, the centralizing impacts of MEV, the specialization of MEV, block proposing, building, other things
LSTs
like that.
coming in from outside.
Yeah, then I think that the specialization of the roles at the outset might have been a very valuable component. And that's because, you know, the long tail, even if there are centralizing pieces of the system, having many disparate actors that actually attest to and validate the consensus and do that relatively lightweight component compared to the rest of the system, that's what gives us kind of the long tail protection. And that's why I think, you know, solo staking or home staking or like at least small company staking like is valuable, is because of this like long tail of that particular activity of validating the network and attesting to the network and testing the validity of it. And even in the sense of like, you know, if there is massive centralization, a component of the network, and they go rogue or they go down or they go whatever, like that allows the kind of the long tail to fill the gaps. And so I do think, again, the specialization of roles at the outset might have protected us from certain centralizing things that are happening now, but I don't know.
Are we getting there with the changes that are coming?
It's funny. I was looking at like the fork list to make sure I refresh it. I don't go to the consensus layer call anymore. Although Stokes lives like 2 blocks away from me, so we do talk. But yeah, I think the EPBS stuff that's coming in is beginning kind of thinking in the right direction in terms of the separation of the roles and different things. I do think that there's still work to do. It's hard, you know, the priority list is tough, the priority list is long.
Yes, it is. So we talked about all the challenges with institutions and what they do and do not think. What gives you optimism that Ethereum can remain decentralized and credibly neutral under this centralizing pressure, and we don't really care about the protocol pressure from institutions?
Right. I mean, ultimately, even with centralizing pressures, we need to design protocols that are resilient in the event of disaster, right? Like protocols that slash the capital that was too centralizing and doing something evil. Protocols that can recover in the event of major downtime or forks and things like that. And like, if you look at even Vitalik's, he has like on like github.com/Ethereum/research, there's like a folder in there called papers. And this is him like writing stuff in 2016, 2017. If you go look at his papers, it's all about handling tail and edge case scenarios and being able to recover from disaster. And a lot of the core of the mechanism, even the components, you know, there are many components that could be better, but I do believe with a resilient social layer that, you know, the protocol will be fine. That said, some of these scenarios might not be pretty.
Very
so
true.
Let's try not to get there.
Yeah. Thank you, Danny. Really, really appreciate it. We have time for questions.
Oh, and I meant to give a disclaimer. I'm an observer of proof of stake at this point. You know, I have a deep relationship with it, but I also, there are people in this room that are carrying this thing on their back, so they probably know better than I some of these answers.
You're talking with all of these institutions who've been doing risk managements for years, decades, and centuries, and then when you tell them that we have decentralization and credible neutrality, they just take it as a given. Doesn't that mean that we are ahead of the curve in terms of like risk management and seeing all these potential issues in the futures?
Yeah, it's a different paradigm, right? Like there's financial risk management is far less like mechanism design. It's far less like how do I orchestrate and architect the incentive of actors to do particular things. Certainly, the financial markets push and promote and do different types of behaviors, but like they're not mechanism design risk experts. Whereas I think the people in this room are, and I think that's the problem. And I think that's the paradigm shift that financial institutions need to have to adequately understand these systems.
Thanks.
Hey, Danny. welcome back, first of all. As we go forward, in which the Ethereum Foundation has a limited treasury, and as we go through with time, it becomes harder and harder for us to fund things that are credibly neutral and stuff like that, whether it's critical parts of the ecosystem like client teams. Does it worry you at all that at some point in the future that would be capturable by, say, institutions with a lot of money who would end up actually, buying out a team like Lodestar or something like that? And how would you mitigate or continue to keep the ethos of Ethereum if, say, JP Morgan bought us?
Yeah. People that run client teams are individuals. It's funny, this is like child's play, but I remember when Prism was bought by Arbitrum, there was concern. It was like, oh, Arbitrum's buying a seat at the table. Oh no. And I remember talking to some of the guys over there, and they're just like, you think I'm gonna get on this call and like shill some like random shit that they're pushing behind the scenes? Like, we're a bunch of individuals and we're just gonna walk. Like, this is an open source project. And so I think individuals can stand for what they want to, and stand for what they believe. But also, I think the other mitigating factor is, man, I feel like I'm the only ossificationist left in the world. I like, this system's not done, and I know it's not done, but like portions of it, like when it gets to good enough, we should kind of signal like we're done. We don't mess with that anymore, and it should be harder and harder to mess with the thing. And I think that the protocol should be sufficient. It should be sufficient for the task. It doesn't need to be the best at every possible thing. We don't need to tune it and tweak it forever. And if there's a critical security problem, like, anything's on the table. But like, portions of the system, as they become sufficient, should be harder and harder to change. And I think they have to be if JP Morgan's gonna be buying a client, which is not out of the question. I'm not picking, someone go.
I think we're all aware of like the advantages of crypto and everything, and like the slow settlement, it seems like a bug, but it's a lot of advantages in terms of like mistake correction and like legal things. So like, I assume like a major thing that you deal with is the fact that the irreversibility of like like ETH is like should be a major problem for the institutions. Like, how often does that come up? I assume it comes up a lot. And like, is there any answer you have for that, or?
No, I mean that should be solved in the application layer, right? Like, you can program whatever you want to do Ethereum. If I'm moving a land deed to you and we have a problem, like, let's deal with. Oh, on ETH? Yeah, I mean, they need to handle that in their security and risk profiles. It's not recoverable. I don't have a great answer, and they're super, super paranoid. I think that institutional ETH will not move a lot, and they will have incredibly high kind of security practices around moving around. But it's a foreign concept. It's not like sending a wire, and well, that's the closest thing it is to. Sometimes you send wires into the void, but.
So we have hundreds, if not thousands, of EIPs proposed every year, and you're saying that we should just ossify. Which part of the protocol do you think we should ossify and should not touch?
It'd be nice to never touch issuance again. But it also would be nice to not have 100% of ETH staked. So right. Again, I'm practical. If we need to mess with that thing, let's do it fast and let's never do it again. I think that we should make sure the pricing on the EVM is right, but we probably shouldn't make tons of breaking changes to opcodes. Adding opcodes is a bit less potential for nefariousness than adjusting opcodes, but even then, like, get the EVM to sufficient. Like, and sorry, I do believe layer 2s can and should diverge from EVM mainnet, and EVM mainnet should be sufficient. I was just looking at all those EIPs. There's a lot of work to do, so I'm a bit at odds.
Hi. I'm not super aware of what Etherealize is actually doing, but as far as I got from a few talks from you that I heard, that you're talking to institutions, which is good. At the same time, there was a big concern that institutional capital flowing into staking might ruin all this shit. So how do you find the balance here? And when institutions will ask you, okay, we want to go staking, how should we do that? What would you answer them?
Yeah, so Etherealize is a champion for Ethereum in this environment. We also spend a lot of our time not focused on ETH and not focused on staking, and focused far more on how do we take institutional markets and assets and capital flows and actually re-architect them on top of Ethereum and bring the world's capital markets onto Ethereum. When we do talk about the ETH stuff, as we talked about earlier in staking, I beat the drum heavy that their risk models are wrong and they will lose a bunch of money. And like I said, people understand, but they don't have the proper worldview to incorporate it. I do think that if Ethereum is going to win, as people like to talk about this year, we do need to onboard the world. Institutions manage anywhere from like 45 to 66% of the world's investable capital, depending on how you estimate that. That's something like $100 trillion under their management. If we're actually going to make an impact on the world, that capital needs to begin to flow on chain. I think that if we are going to make an impact on the world, we have to do it now and not in many years. And so I think we're going to be at odds with the very real time consideration of onboarding the world and attempting to protect these systems. I don't have all the answers, and it's going to be hard.
Well, thank you, Danny and Thorsten, for this excellent conversation.
Thank you.
Thank you, Danny. Thank you. Danny Ryan, ladies and gentlemen.
I know there was more questions than we could possibly get to in that period of time, but actually we've got another interesting conversation coming right up. Perhaps Danny had a little bit of foresight to this. Please welcome to the stage here Jérôme de Tychey, who is going to be actually talking about the most controversial topic in our system, which is issuance.
Wow. I'm impressed you're actually uploading. So if you're looking for a rack of tomatoes, just look at the seat underneath in front of you. Help yourself. I'll be standing right here because I've been kind of losing my voice. So it's also going to help for your aim. If you want to throw something, I'll be sitting right there. So I'm really honored to be here. Thank you for Issaker for having me. It's a pleasure to be there. A couple of disclaimers. Many of the examples that you're going to see in this presentation are from the incredible works of Ansgar, Casper, Paxi, Justin, and so on and so on. Many incredible talented researchers that are constantly pushing this topic and not getting any good response from the community. So yeah, let's get into it. So a year ago, I saw this talk from Ansgar and Casper, ETH is money. It was framing the staking yield as the poison fruit. The presentation was a wake-up call for me, and I was hoping that it would be a wake-up call for the rest of the community as well. Did it? Well, not really. We were still in the same situation that we were a year ago. So let me take you for a ride. Let's buckle up. We're going to see the situation we are in at the moment, talk about the dynamics, how ugly it can become, and hopefully convince you that a change is urgent and necessary. As a sweetener for this controversial topic, and also to fit the vibe of this beautiful venue, I will spoil you with a couple of paintings of one of the artists I really like, Giorgione, which, funnily enough, did a kind of a follow-up to the painting they used in their original presentation. This one, the Tempest here. It can be seen as the aftermath after they eaten the forbidden fruit and God kicked them out of Eden. You have Adam, the ETH holder here, we now need to work extra hard to provide for his family needs. You have Eve, the core devs and researchers that are painfully delivering EIPs and laboring the new Issuance curves research papers. And of course, like back in the back, the paradise where newly minted ETH didn't create any negative externalities and so on. Really super fast, let's chat about the Ethereum monetary policy. You are all very sophisticated ETH stakers, so you know about that. The change of ETH supply is the validator reward minus the burn fees. Two critical components. The number of ETH that we mint per year is roughly equal to 166 times the square root of the number of ETH at stake. That's specification, assuming that most of the network participate, nothing goes wrong, and so on. This is the reward curve. And of course, there are burn fees, 1559 fees. The more block space is demanded, the more ETH we burn. And of course, the more blob space, 4844, is demanded, the more ETH we burn. And to set the tone, three fundamental theories about monetary policy. Information is an economic good. More information, better decisions. Regulatory agencies, not saying that the EF or the core devs are regulatory agencies, but they tend to be captured by the industry they regulate. Inflation is always a monetary phenomenon. We should pay attention on how much we mint for this case. Rule-based monetary policy, rule-based monetary growth is great for anticipation. This is how most of the modern models are built on. And Hayek, money prices are essentially formations. This is how people make their decision and forecast their decision of investment and so on and so forth. So consider yourself warned. What's the issue with issuance in practice? So right now we have 35.5 million ETH at stake, last time I checked, so roughly 30%. The APR, it's moving, sometimes a little bit more tips, sometimes a little bit more MEV and so on, but that's the rough number. So pre-burn, that means that we have an issuance of 0.82 and post-burn 0.8. As more ETH come at stake, due to the curve that we are using right now, as more ETH come at stake, we are issuing more. The consequence of the supply is the blue curve you see on this famously known website. I guess you all have been to ultrasound.money. Raise your hand if you have not. Yeah, everybody knows about this website. We can clearly see three different phases for the ETH supply. We were in extreme growth until we reached September 2022 when we did the merge. So it was a time when we had proof of work plus proof of stake at the same time. And then we had the pre-blob era where Ethereum was milking fees out of L2s, burning them out, both the L2s and the fees, and the post 4844 where we got out of the ultrasound era and started to get more adoption, get more scaling, and so on. So what's wrong with this? The amount of ETH at stake is trending upward. So you guys at ETH stakers have done a great job. Yep. Congrats. But it's an existential problem for Ethereum. This has been well documented by research for over the past 3 years, and now is the time to act on it. And if you ever pass by Vienna, you can watch and see this beautiful painting called The Three Philosophers. Do see it in person, it's really mesmerizing. It's a great Renaissance picture with fun interpretations. The writings of Plato and all the Greek philosophers were getting known more and more. So you have three intellectuals here that have recently learned about Plato's cavern and the importance, how it's crucial to not mistake the shadows and the reality of the objects. And also how crucial it is to get out of the cavern, of course. And what they are doing is staring at the darkness of the cave. Staking protects Ethereum. Too much stakings jeopardize Ethereum. So why is too much staking so bad? Two things that we should have the utmost care in this community. Security and marketability, or moneyness of Ether. First, let's talk about security. Staking is a centripetal force. It tends to create, and inevitably create, problematic market shares among the large stakers. The credibility of slashing events gets eroded and eventually disappears. There goes Ethereum neutrality. There goes also the perceived quality of the block space and the blob space that we are producing. There goes basically everything we are staking for, everything that we care about. If you think this is far-fetched, take in consideration that large institutional actors have custodian constraints. That means that they are going to use probably the same providers or start to do custody themselves or hedge their risk, meaning that they are just going to grow the shares of certain actors. If you think staked ETF are not around the corner, well, think again. I let Hildebert talk about that on his talk. So much so, consider this as well. The number of ETH at stake is snowballing. Take Alice, she has 2 or 3 ETH. She's not staking because she doesn't care, she doesn't know about it, and she has never heard about ETH staker. She's getting diluted 0.8% per year. Too bad for her, but flash forward to a few months later, and now we have half the supply of ETH at stake. That means that Alice is getting diluted by more than 1%. Maybe now she starts to realize that it's a pretty bad situation and she should stake as well. She should log in on Kraken or whichever centralized exchange she's been using and start to stake there or use an LST. After all, 85% of the holders have got their ETH at a centralized exchange and they have access to simple solution to stake. There you go. The phenomenon accelerates until most of the holders are actually stakers, and ETH has about 70 to 80% staking ratio. This is one of the worst case scenario and not a completely impossible scenario, quite the contrary. This is the worst case scenario because to defend proof of stake, to defend Ethereum, we need to have a coherent social layer and also a reserve of ETH that are not at stake, that can come at stake to defend the decentralization of the network against all kinds of attack. We are currently accepting a calibration of the rewards that, well, undermine the security, to say the least. But if you're saying, well, security is a spectrum, we need experts, it will fall into endless debates, scenarios and projection, edge cases, counter-arguments. Like, yeah, I understand the security aspect of it, but hey, we have more important fishes to fry, or as my business partner says, security doesn't sell. What about marketability? How easy it is to buy and sell the asset, how easy it is to pitch the asset as an investment or something you should hold, or the moneyness, how close the asset is to money in its functioning. ETH as an asset is much prettier in the eyes of its beholders, of its bag holders, of its potential investors, when it's ultrasound, at least when it's perceived that the growth of the supply is contained, the growth of the supply is predictable, and so on. Sure, ultrasoundness will eventually return as adoption grows, as it brings more fees, but go ask any people with crypto retail experience how hard it is to acquire a new customer when their asset is in the red. The least we could do, the very least we could do, is to take all the necessary action and decision to improve the adoption condition of Ethereum. Changing the reward curves is one of them. It's apparently an easy one to implement too. Nimbus and Sigma Prime can vouch for this. The reward curve in the code base is usually a few lines of code. So once we agree on the curve, it shouldn't be so hard to implement. But what's hard is to collectively agree on something and collectively agree that it's necessary. I was describing how ETH at stake can snowball and the consequences on security, but what are the consequences for Ethereum and its economy? What is the consequence for DeFi? Well, less ETH for DeFi, of course, and inevitably as well, ETH will start to be replaced by liquid staking tokens as the de facto pristine collateral on DeFi and the native currency eventually. We are lucky to have Lido. Thank you, Lido, for sponsoring this event and hearing me out here. We're lucky to have Lido that's currently in the lead and not an extremely predatory actor. Less LST dominance will shift our money model from trustless to governance-based with the LST's DAO and so on. Furthermore, destroying the marketability, the moneyness of ETH and so on. We have collectively everything to lose here. And one thing I've been hearing when discussing issuance around town is that, yeah, but more ETH at stake is good because less ETH will be available on centralized exchange or on the market. This is good for the price, less ETH ready to be sold and so on. Well, no, that's not how it works. In the end, you will get ups and downs, greater sparks. This is called extreme volatility, and this is not good for adoption. This is just a generalization of slippage, and it's really not good for bag holders at all. Another bonus, not a painting this time, but a more focal point on what's going on and where we're going, there is a vicious cycle between security and moneyness. As the price of ease goes down, the cost of an attack goes down as well. Right now, the economic cost of an attack is what we use to say Ethereum is the best, and also why probably some other chains like Bitcoin have switched their narrative towards energy, just to differentiate themselves with the leader that says, well, Ethereum is the most secure chain. So driving price erosion is really bad for us, and we should make sure that this doesn't ever happen, and every downward price pressure should be avoided at all costs. So at this stage, I'm kind of amazed that you are still standing and not throwing anything. As a fellow solo staker, I hear you well. My yield is fair. My yield is fair, of course. Stakers are the hero backing Ethereum. No one is arguing against that. We bear operational risk, the custody, the smart contract, the slashing risk, and so on. We bear liquidity risk. Staking ETH locks in the staking contract, which means it's less liquid. Of course, you have LSTs. But if there is an ICO you really want to participate, you cannot pull out easily. You bear operational risk. Also, it's a lot of risk, right? And is this risk fairly priced? The market weighs all those risks normally in a normally working market and expect a yield to compensate them. The growth of ETH at stake will stop eventually when we reach the reservation yield, the margin of the marginal staker. Like nobody wants to join staking because it's so low. And how low can we go? We can go to 160%. 160%. Is that low enough? It seems pretty clear that we are far from this reservation yield right now. But furthermore, let's talk about those risks. We need to acknowledge that we are not in 2020 anymore. We've been using the same curve for 5 years, and the landscape has massively changed. We benefited from major improvements. First, the Lindy effect. Is anyone from Balancer in this room? Yeah, so normally the probability of finding a new vulnerability in a smart contract decreases with the longevity, but still, account security is better, slashing protection is better. We just had a few talks about slashing protection and new innovation in this field. Liquidity is better, like you have LSTs and way to mitigate the situation regarding liquidity. I'm not even mentioning tricks to skip the exit queue. We have client diversity. We have delta neutral strategies that are available to more and more unsophisticated actors to prevent from the loss of value in ETH when they are at stake. But also we have regulatory clarity, tax guidance, regulatory development, stake TTF, institutional custody, and et cetera, et cetera. And more importantly, it's very unlikely that changing the reward curve will get us sued by the SEC. So the risk premium is likely going to be significantly reduced and continue to be significantly reduced. Yet we are using the same curve since 2020. So why now? Time is of the essence. Why now? Why do it now? It's even something that we can fit into Glamsterdam eventually. Huh? Anyone? Okay, maybe. The risk I mentioned will only trend to be lower. Stake TTF are just around the corner, so it's important to make those changes now before we have much more larger actors at the table. And countless top researchers, for countless top researchers, the situation that we are in right now is already very problematic. It's already worrisome. And also ask yourself the question, like, is it normal to get 3% ETH at stake and get 1.5% on Aave? Like, what is it? Is it double the risk? Or like, even if you stake 100%, what will you get on Aave? Here's a bonus. The Soldier, also available in Vienna. When you're in Vienna, go see the Giorgione. No interpretation, is just to give you a will to fight for new issuance. Some people may say, well, you know, changing the monetary policy, the market will hate this. The current curve is okay. Come on, we picked this curve 5 years ago. Yeah, but we have a history in Ethereum to not pay too much for security, not overpay for security, maximizing security and neutrality without overpaying for it. Look what we've done in the past, those beautiful EIPs that change how the Ethereum policy worked. This is also a bonus from private collection. Giovanni Borgherini in his tutor, an allegory for coming of age, transition to adulthood, the duality between youth versus prudence and wisdom. when we change the market, the monetary policy of Ethereum, the market listens, the market pays attention. Oftentimes, large changes in fees or large changes in the monetary policy led to huge price action. I'm not trying to draw a perfect correlation here, but we will see what 7918, which is going to change the blob market price, will do to the price. There are only two factors we should consider. Scarcer ETH, at least the perception of scarcity, is good for the marketability of the asset. There are tons of benefits of having pricier ETH. One of them is that the EF will have more budget to continue doing research, but of course there are dramatic pitfalls in looking for higher prices for only the sake of it. This is not what issuance policy is about. Issuance policy is about the protocol cohesion, the consistency, and to be honest, we just look bad if we are overpaying for our security. So you can run all the valuation model you want. They all boils down to two factors that are to take into consideration for Ethereum valuation. I mean the market cap. This is the fees that we generate and the adoption of the protocol. How much the output of the protocol are demanded, are used, and so on. Everything else is just long-term neutral, including the monetary policy. Ceteris paribus, if we don't do any adoption, if we don't burn more fees, but just mint more, we're going to have the same market cap and just lower price of ETH. Great. Not great, actually. So if you want the price to go up, just the price to go up, the recipe is pretty simple. Print less, burn more. Print less, burn more. Yeah, print less, burn more. I will bring a t-shirt with that next time. So talking about the research on the matter, we are blessed, and I choose my words carefully here. We are blessed with the world-class quality of researchers that are working on the topic at the Ethereum Foundation, but also with the countless top-ranked universities that produced a lot of analysis of this. You can have a look at everything that was produced on issuance.eth. It's a good extract, but here is a TLDR. There's an optimal ETH at stake range from 20 to 30%. We are getting past 30% right now. We are overpaying and diluting all the holders. So the holders should say like, hey guys, we should change this. It's painful to see this continue. There is clearly a detrimental thing for Ethereum with the uncertainties with the dilution. And yet, indeed, no alternative curves are perfect candidates, notably when it comes to the certain categories of the stakers that are impacted. So consensus on the curve will be very hard to reach. It's much easier to agree on an issuance rule, like max X% per year. This is what we can commit to. Let's say we'd say max 1% per year, max 0.5% per year, and then maybe we'll change the curve the year after, maybe we change the curve somewhere else. Just admit max X% per year. Here's what success looks like. We're not framing yield reduction, not saying like, hey, we're just going to do yield reduction. This is an improvement of Ethereum for everyone. The staking cap has outstanding benefits, notably ensuring that staking can deliver positive return for everyone. There is an inflation cap. It keeps ETH as a pristine collateral. It keeps LST for governance and specific liquidity stuff. And so it can keep the solo stakers viable for long term. Here's another bonus, the judgment of Solomon. You certainly know the story. Morning come, you have two mothers, two babies. One passed away and the other is still living. Both mothers claim the living baby, it's theirs. Solomon says, let's cut the living baby in half. What happens? Well, one of the mothers cries, the other mothers rejoice because justice was made, and Solomon gives the custody of the child alive to the crying mother. So no interpretation. Should we cut the issuance by half? Who's going to cry the most? Yet the good news is we can be way less harsh and cruel than that. We can collectively agree on a much more powerful signal on this simple rule, like max issuance X per year. I've only been given 25 to 30 minutes, so I will absolutely not have time to discuss all the different curves that were proposed. So here are a few shapes that have been thoroughly discussed on Ether research with all their pros and cons. Yeah, this one is cool. This is the famous croissant, issuance 2.5, issuance 0.25, Oh, I'm missing some? Am I going too fast? Hey, I think some of them were scrapped in the thing. So I have a personal preference for Frankenstein 0.5, but you can make your own mind. So here's my message to you. The stakes are high. Ethereum right now is a critical adoption. We need to realize that. Critical moment for Ethereum. It has a lot of potential for failure still. We see copycats of Ethereum popping out every morning. Large VC firms, large firms just funding something that's basically made to compete against Ethereum. In the meantime, we have to relentlessly continue shipping the different features that are missing on Ethereum regarding interoperability, regarding privacy. We are scaling the L1. That's a big effort to do. And we are catching up on different things also. And continue to sponsor the L2 cost with our own fees, just for the sake of adoption. So let's take a step back. Can we afford to have weak ETH in this phase? Absolutely not. And by not advocating for a change on this curve, by not acting, we are just sandbagging Ethereum. This change will make us stronger. It will be both defensive and offensive. We'll have better security, better marketability of ETH, but also we'll be able to defend ourselves because our monetary supply is sound, because we don't emit more than 0.5% when the new protocol that's going to launch are going to have like 10% increase of the supply each year, 20% increase of each year, and so on. So we have a chance. Oh, here it is. Sorry, look, I get mixed up. Yeah, I like this one. Issuance 0.5 Frankenstein. Ask me about it later. So this is a chance to signal and rally our preference. You can easily express yourself on the social media, only for research, say like, hey, 0.5 sounds very marketable, like it's like 50 cents, you know, or 1%. I like 1%. And alternatively, eventually, the situation will be so dire that Ethereum will passively bleed value, eventually go into fighting over controversies and competing EIPs. So this is what we want to avoid. We want to show that we are collectively agreeing that this is a problem and we need to act on it. Final bonus, this one is in Firenze. Another soldier, leaving you with the interpretation. Young guy staring at you with mysterious look, with a melancholic frown. Staking protects Ethereum, and too much staking jeopardizes Ethereum. Thank you. If you want to chat about the topic, my DMs are open. I'm also hosting a small discussion on Thursday morning with different stakeholders, different stakers. If you want to participate to this chat, like reach out. I'll be happy to invite you as well in the morning. Proof of Stake is turning 5 in a few weeks, and what it wants for its birthday is a new reward curve. So let's print less and burn more. Thank you.
Well, thank you very much. I know the room is full of questions. I've got a whole bunch myself, but unfortunately we are out of time. We've used all 25 minutes just to kind of get through that conversation. But we are coming up to a break after the next two talks. But let's continue on the agenda for it. And I think issuance is probably one of the most challenging topics facing us right now. And it's unfortunately one I don't think there is a consensus on with a clear path. And so I'm looking forward to that further discussion here.
Talk to you soon.
But let's go ahead and introduce our next speaker. Darren Langley is going to come in and talk to us. His topic is the stakes remain high, keeping Ethereum decentralized.
Cheers. Thanks for bearing with me. That'll do. Okay. So thank you very much, everybody. So I am Darren Langley. I'm the general manager of the core team for Rocket Pool. So just in case people don't know what Rocket Pool is, we're a decentralized liquid staking protocol. We are the third largest liquid staking protocol on Ethereum today. We're staking about 1.7% of Ethereum today, and we have about 2,000 node operators across the world, and a huge community of node operators. So we have a liquid staking token called rETH, and obviously, as I said before, we have these node operators. So with Rocket Pool, unlike a lot of staking protocols, you can actually stake on the node side as well. All right, so it has been a big year for Ethereum. There have been 3 core narratives that have garnered a lot of attention, driven a lot of demand, and obsessed crypto Twitter in general. So these are exchange-traded funds, digital asset treasuries, and regulation. So the ETH ETF market has kind of like hit 22.5 billion in terms of market cap. Most of the ETH ETFs launched about mid-2024, although we didn't really see any kind of like strong inflows until 2025. The ETFs currently track the kind of the value of holding ETH. Most of the ETFs don't include staking, and that's mainly because of regulatory uncertainty, kind of stopping the ETF providers from doing that. The few that have offered staking actually couldn't pass through all of the yield. They only did half of it because they have to meet redemption requirements and all that sort of stuff. So then you got ETH-focused digital asset treasuries. They kind of burst onto the scene pretty much overnight, and they started buying up ETH and packaging it up into kind of equity products. Their growth has been extraordinary. They, in a very short period of time, they've acquired over 4% of the ETH supply. BTCS is actually one of those treasuries, and they're actually using Rocket Pool to stake their ETH. So we come to regulation. So the SEC finally engaged with industry, and they provided some essential clarity on staking activities. So the guidance confirms that staking is not a securities offering, that staking providers don't need to be registered securities providers. Now that, to be honest, for most of the people in this room, that's pretty obvious. You know, unfortunately, this clarification took a very, very long time to produce. Other markets, such as the UK, have also got similar sort of things coming, and even in Australia as well. So basically, this is a win for common sense and kind of common sense regulation and innovation. Regulatory momentum keeps building. So the US Treasury has introduced some stuff recently around ETF providers sharing yield as well. So you know, everything looks pretty good in terms of that. So is this a good thing necessarily? Well, actually, there does seem to be a bit of a problem. So where is the new stake going? It's going to centralized exchanges, centralized staking providers, and pools only have like a handful of entities who actually run their nodes. If this trend continues, as we've kind of heard in the last one, particularly as ETH ETF providers come online and actually do stake their ETH, then it does pose a fundamental problem for Ethereum. So I'm going to switch to liquid staking for a little bit, but I'll come back to it in a minute. So okay, so let's talk about liquid staking, because it does actually have some advantages for institutions. It's easy to custody, there's transparent pricing, it's relatively easy in terms of accounting, it's liquid, whether that's via selected liquidity providers or kind of DeFi itself, and it's not non-technical. So why are they using centralized providers instead of, for example, a decentralized liquid staking protocol that distributes the stake across 2,000 independent node operators, many of which are home stakers? It turns out that the majority of the problem is actually regulation again. Back in August this year, the SEC finally clarified the position on liquid staking, so essentially extending the staking treatment to liquid staking as well, for most liquid staking activities. When we spoke to like one of the largest asset managers in the world, they said up until recently liquid staking tokens were impossible, but now they're on the table, and they're kind of like playing catch up in terms of whether they're going to use it, and but they're excited about some opportunities. So this is kind of confirmed by the VanEck Lido deal, which is essentially an STETH ETF. And at Rocket Pool, we're kind of seeing similar opportunities. So an interesting section in the VanEck Lido submission was that centralization was highlighted as a risk. That, in their words, that it could adversely affect the security and stability of Ethereum, as well as the value of the ETF shares. So this kind of shows that institutions know the risks, or at least they can enumerate the risks, but whether they truly understand the risk is another matter. This is an extremely kind of exciting time for Ethereum, bringing on the world's kind of capital, but it's also an extremely dangerous time for Ethereum as well. So for Ethereum to succeed, these new entrants need to embrace decentralized protocols or products. They need to contribute to Ethereum's value proposition rather than kind of undermining it. They shouldn't necessarily do this because of something subjective like alignment. This is kind of like basic risk management. Contributing to Ethereum's value proposition actually creates long-term sustainable wealth for their clients. So exchange-traded funds and digital asset treasuries give Ethereum some exciting momentum, but what we got to remember is onboarding out of Wall Street and TradFi and that sort of thing is kind of like a mid-game rather than an end game. The end game will go much further. It'll be much more impactful and much more profound in many ways. So there are many ways that this could play out. In the future, we could see a shift away from centralized intermediaries and more towards kind of self-custody enabled by algorithmic financial technology. Why is this important? A useful analogy is kind of like self-driving cars. Just as self-driving cars in theory, will reduce accident rates, self-custody algorithmic systems could actually help to stabilize economies and reduce this kind of like boom and bust cycles. Obviously, this is one possible vision, but it's pretty interesting how it plays out. So my talk's very short and sweet, but if you want to find out more about Rocket Pool, it's rocketpool.net. We have a fantastic Discord community full of staking fans, and whether you are a liquid staker or a node staker, come and see us. That's it. Thank you.
We do have an opportunity for a few questions if there's any in the audience here. Okay, I don't think I'm seeing any at this moment here, and nothing online from what I'm hearing about. I guess I did have one question, which is Darren, when you look at it and you see kind of the risk of centralization and perhaps the the perceived financial institutions that are coming in, is there some mixture or some Vitalik yesterday in his talk said, when asked the question, what did he think of institutions coming, he simply answered, I think, a very elegant and short response that they're a user of Ethereum.
Yeah.
Is there some perceived mixture or proration or share in which we think that there should be institutionalized staking versus home staking? Is there some mixture, or what degree of percentage of home stakers actually preserves the decentralization?
I don't necessarily have like a full figure. From a Rocket Pool perspective, our DAO has committed to not breaching, I think it's like 20% of all stake. So that's a commitment that we've made, and so that's where we will cap, because we feel that anything more than that is taking away from the value proposition of Ethereum. Even if the fact that we're a decentralized network, so we're spreading the stake across many node operators. Even then, just from the governance perspective, we're much better to keep it to 20%. So that's where we sit. Yeah, I mean, there is the power law exists in pretty much everything, but what's really important is the long tail. Rocket Pool has currently a median validator rate of 2, even though we've got 2,000 node operators and we're staking 1.7% of the network. We have this extremely long tail of node operators who are running kind of like 3, 4, 2, 1s of validators. So that they are really important to kind of like maintain the decentralization and inclusion.
Excellent. Another question here.
So you talked about how the regulatory issues are getting resolved. So when you do talk to institutions, why aren't they using Rocket Pool right now, since the regulations?
It's more that they're playing catch up. So liquid staking tokens were literally impossible for them, and they didn't expect it to change. And so they're kind of playing catch up on getting their compliance teams up and ready and analyzing protocols to make sure that what they're doing is correct. So that's the main thing. It's just kind of like timing. There's also a lot of infrastructure that kind of happens. There's like custodians and all that sort of stuff. So that's also something that we're kind of like sorting out. But yeah, it's mainly lots of steps to kind of like get to that point.
Thank you.
One more question in the back here.
Thank you. You talked previously, or you've talked about the difference of centralized exchange delegated staking versus like on-chain Rocket Pool staked ETH liquid staking tokens. The previous talk was also talking about the impact of LSTs or just delegated staking in general on the network. Are you aware, or can you talk on any difference between like centralized exchange staking versus on-chain staking?
Yeah, so...
sorry, from the perspective of the network's health rather than user risk.
Right, okay. So the one thing is, so with the centralized exchange thing, they're running the nodes, or generally very few entities are running the nodes, and there's a high influence. So they're also, the field of influence is very strong, and so they have usually contractual relationships with those people, and so the influence is very high. With Rocket Pool, they don't know their node operators. In fact, we don't know our node operators either. That's by design, and we keep that distance from our node operators. So that in that sense, there is no influence from that perspective. Really, we're a service provider, but there's no they have no influence on the actual. They there's no standover technique. Yeah, they couldn't actually threaten us in that way. So that's a big thing. On the liquid staking side, that's on the liquid staking side. As I said, we've committed to capping, and so our LST couldn't get to a point where it could overtake ETH. It just complements from that perspective.
All right, well, please give a round of applause for Langers here. So we have one more presentation here that I'm actually very interested in here. As many of you know, it's 10 years since the birth of Ethereum. And it's probably time that we do a little bit of a retrospective look back. And so I'm very pleased to announce to the stage here Hudson Jameson, who's going to be talking about Ethereum through the eyes of a solo staker since the testnets. So I'm very interested to hear of his perspective here. So Hudson, please join us here on the stage.
Hello, everyone. All right, so I have been in Ethereum for a long time. My name's Hudson Jameson. I've been doing a variety of stuff with like the Ethereum Foundation and Polygon and Flashbots. And one of the things that I really love doing is solo staking at home to support Ethereum's network. Yay! So this is kind of just a fun presentation where we're going to go down memory lane for those who were here in the early days, or maybe if you weren't, you can kind of see some artifacts, screenshots, tweets from way back when. First, where it all started for me was around May 2020 when I decided to participate in the early Ethereum testnets for solo staking. I wrote a blog, it's still on my website, hudsonjameson.com, where I talked about staking with Topaz, which was a Prism testnet, and using DAppNode for under $750. The Topaz testnet was one of the, I think, 4 testnets that Prism did. Is Prism here? Either way, it was one of the early testnets for Ethereum 2.0 when it was called that. Yeah, I actually still have the POAP from that. I'm really proud of. Back then, this was the system requirements way back when they were doing the test nets. This is what Prism said that we needed. If you look at this now and you're a solo staker, you can kind of see how things have changed. On the right is what I ended up buying for my setup. I wanted something that was really quiet, so I got a fanless mini PC. You'll see later that was a problem with heat, but we'll get to that in a little bit. And yeah, I also got 16 gigabytes of RAM and a 2 terabyte hard drive, because that's what you needed back then. Very different now. This was the DAppNode install screen at the time. Originally, I actually didn't use DAppNode. I set it up on an instance of like Ubuntu, and someone was talking to me about this. I think it was Colfax was talking to me in the lobby and said, "Oh, I remember you did a YouTube live stream where you were drinking beers and trying to set up your solo staking node." And I remember that stream, and that got me started. And I was like, really? Me drinking on a live stream got you started staking? That's pretty incredible. So yeah, I originally had an Ubuntu instance running where I just would run all the programs, but I'm not sysadmin-y enough to really do it any justice. So eventually I switched to DAppNode, which is, for those who don't know what DAppNode is, it's a all-in-one solution for Ethereum staking where you can install it on a new computer and pick which staking sources you want. There's going to be some screenshots later that'll better explain like the whole situation. This is what it looked like back in 2020. So if you were to boot up your DAppNode and you were to see what dApps were available and what applications were available, this would be some of them. Shout outs, wow, Storj, Trust Lines, Boink. Okay, Boink's actually still on there, but anyways, just we got some old stuff here. You could run the Prism Slasher way back when. And yeah, this is what I used to run my testnet node because Topaz was supported on DAppNode back at the time. Yeah, okay, this is actually, I skipped a little bit by saying that I switched from Ubuntu to DAppNode, but yes, I was running Nethermind and Lighthouse and Web3 Signer, so I can quickly swap between ELs and CLs. It turns out I didn't swap as much as I normally would. I kept with Nethermind and Lighthouse pretty much the entire time, even when it was kind of rough at the beginning. For those who were there in the early days, like, not everything was just click and it just works out of the box. Now I feel like it's so easy to run a node. It's so easy to get like into the staking environment. So yeah, back then, the ones that you picked really had a big effect on how well your node would do. Right before, I brought this up because I think this is going to get lost to history. There was something called ETHPOW, and it was a group of scammers, or I'm pretty sure they were scammers, who wanted to continue the proof of work chain after the merge. So they said they were going to fork Ethereum and they were going to keep the proof of work chain going, and they had all these people over like in Asia who were going to just keep the chain going, and it turned out it didn't happen. They literally just forked Geth and didn't even change any of the parameters. So we had a good laugh at that way back when. Right before the merge happened, we had some things set up, some live stream calls, and we had the merge bingo and merge drinking game, for those who remember. Leslie, the unicorn, everyone remember Leslie? It was like basically the mascot for the merge, and it was a rhino you could get if you were a specific like staker. You could get an NFT of Leslie, so that was a pretty cool thing. We had this. There's actually some people in the audience who are on the screen, but this was the merge call. ETH Staker, Daily Gwei, Ethereum Cat Herders, and like 2 or 3 other organizations came together to do this gigantic live stream where we were all monitoring the merge. There was get-togethers in Berlin. There was a group that was in a cabin in Wyoming. Was that right? In Canada. So there's the Canada team. There was Boulder, Colorado, had like a group of like 30 people in this little room. And yeah, it was like a 3-hour stream where we watched as Ethereum changed from proof of work to proof of stake. And it was like, honestly, I'm pretty sure I cried a little bit. It was like a huge day. Like, I'm pretty sure other people did too. It was like a huge thing. And I just remember feeling so proud of everyone and like us all getting there. So it was a really, really big deal. When the merge activated, you got this cool little panda on your screen, depending on what client you ran, that said POS activated. I just noticed this, but in the middle it has the LFG, let's fucking go, as the like middle bridge between the nose of the panda. I had not noticed that before. And yeah, this one's from Left Terrace, from his Twitter, because I could not find a screenshot of it anywhere else. So what am I staking on today? I skipped a lot of like stories from the middle of my staking career. The reason being, it's a little embarrassing. I kept my staking node offline for 4 months accidentally. In fact, Justin Drake like messaged me on Telegram and said, "Hey, I think your node's offline." I'm like, "I know, I've been really busy." And a lot of people thought that I would get slashed, but really there's not slashing when your node is offline for 4 months. You just get inactivity leaks that do not give you rewards. So I did not get rewarded for a series of 4 months. That was okay. I had some stuff going on. And the reason that I had some stuff going on is my node overheated. I had the fanless node, so there was no fan. And I kept it in my room in Texas where it gets to the hundreds degrees. And it just fried the thing. So would not recommend if you live in Texas having a fanless node set up. That is not something I would recommend at all. Now I have this with the Cold Wave 2.0. This is the Minis Form Venus mini PC, I guess. And it has a little fan on the bottom, but it doesn't make that much noise. I love it. It's working great. This is what my DApp node looks like as of last week. So if you're ever like, maybe you're here and you're thinking of staking and you're like, I don't know what, like, how much RAM to get, or I don't know how much like CPU it's going to take up and stuff like that. I went overkill on the CPU. You don't need 16 cores. I've never seen it go past like 12% on usage. Memory, it usually hovers around 16. The only things that I have on the DApp node is Lighthouse, Nethermind, and MEV Boost. So this is literally like if you want the bare minimum, this is probably a good idea of the specs you're going to be looking at. The disk space from syncing from scratch maybe 4 months ago is about 1 terabyte. I have 4 terabytes, so it can get as big as it wants, theoretically. And then the CPU temperature has been staying relatively pretty average, pretty good. And if you've also never seen DAppNode and like seeing how you can choose which clients to run, it's literally as easy as going to the screen and you click which execution client you want, you click which consensus client you want, and then you pick which MEV boost relays you want. And it's like stupid easy. Honestly, like anyone I feel like should be able to do this. I highly, highly recommend DAppNode if you all want to solo stake. I zoomed through this, but I'm allowing anyone to ask me questions about this or anything else.
Not a question, but another little piece of history during the merge
go ahead.
was the POAP art where like everybody logged in, you tried to paint on the screen. I don't know if anybody remembers that.
Yes.
But yeah, you should probably add that to your little
I'll add that to future ones. So there was a paint party where you could go and you could like mark like a color on a big canvas that everyone else was marking on. And so there were different factions of people trying to draw their own thing on this canvas. And it was a big, beautiful like canvas art piece by the time that the merge happened and it was done. Other questions?
Hudson, you had a unique trajectory going from Ethereum governance to working at Polygon.
Mm-hmm.
Now that you have worked at Polygon, how would you go back to governance and tell them like what needs to change in order to get users like Polygon more engaged in the governance process?
Oh man, that's a good question. I would say that, you know, L2s in general have their own edict and have their own like special thing they're trying to do. So it's really hard to merge those two communities, but it is possible. I would say making it exciting and fun and something that's relatable and connectable to like the L2 to the L1 to the L2 is definitely something. I haven't seen that happen that much. That's a really good question. Other questions?
Yeah, one more in the back here.
As a unique OG solo staker, how you convince new people, or how would you convince newbies to start solo or home staking?
Yeah, well, I just saw Jérôme de Tychey's talk, and apparently we really should not be putting any more stuff into staking. So, first of all, don't stake. No, please don't clip that. No, actually, I would say that I think it's a really fun exercise in learning how to use a computer in a different way. So people who maybe run their own Minecraft server, like those are the kind of people that would be like really interested in something like this, because it still has like a sysadmin type feel to it. It still has like doing a little bit more advanced stuff with your computer, and you're making a money printing machine for the most part. Like you're putting in money and then you're getting back, you know, interest over time. And so that's definitely something that's appealing to people who are able to put in that amount of money up front. So yeah, that's my answer, I guess.
Thanks, Hudson. From a networking perspective, have you ever been concerned about, assuming you're running at home, like exposing your home IP address?
Ooh, that's a good question. There are projects that are looking at that. I haven't really been that, yeah, like, what was it again? A VPN, yeah. There's ways to put your node behind a VPN or similar obfuscation. I haven't looked too deeply into it. I'm not that worried because I'm just a guy. I'm just a little dude, and I hope that no one wants to attack me. I think if I was doing like a big staking operation, then I would be a lot more worried. But yeah, to answer your question, no, I'm not worried. If I became worried, that'd be a really cool research problem for me to dig into and try to hide my IP address. If anyone actually has the answer or like is doing that currently, feel free to raise your hand and take the mic here. Who's next?
Hey, Hudson. I do remember that live stream. That's how I learned how to set up a node.
Yes.
Broad question, but what are you most excited about right now? Whether it's related to Ethereum or I guess not.
I like TEs. Those are really exciting. A lot of people are shitting on them right now because like they're misunderstanding what they can be used for in conjunction with other technologies. But I really like the idea of this physical hardware that you can store a secret in and then only selectively get people to see the secret. It's just really interesting to me.
I like TEs too. What specific use cases do you think that can be applied to?
There is some use cases around ETH2 and like staking and stuff that actually is really interesting. I'm probably going to butcher this, but I know that there's like you can do some stuff where you're building blocks inside a TEE, and that was something I looked at a little bit and thought that was really, really cool. Anybody else?
Hey, I just want to say thanks, and I'm wondering about centralization risk. So solo staking, it reduces centralization from the staking pool, but then if everyone's using DApp node, aren't we sort of like bringing that back?
That's a really good question. So there's different areas of centralization within the Ethereum staking ecosystem. There's everybody using the same execution layer clients, everyone using the same consensus layer clients. That's like not good. There's also the operators. If one operator has too many nodes, DApp node itself is just a means to run the node. So if you're using DApp node and then there's like a bug in DApp node and all the DApp nodes go down, yeah, that is somewhat of a centralization risk, but I think that there's enough people not using DApp node at the professional level that like unfortunately, solo staking and DApp node users are never going to get to a point where if they all went offline at the same time, that would cause a massive incident that I know of. Like statistically speaking, I don't believe that's the case.
One last question here.
What is your issuance curve of choice?
My what?
Your issuance curve of choice, like how much issuance would you like to see on Ethereum?
Oh gosh. Oh my God, I'm not. I don't do economy stuff. An issuance, gosh, enough that we're all happy. Thank you.
All right, we are now entering a break. It's a good 15-minute break, so please be back here at 16:50. We have some of the best talks still for the afternoon session. 16:50. All right, well, welcome back, everybody. Those breaks seem to go faster and faster each time, but we really do have just an amazing lineup this afternoon if you've taken a look at it. And to keep us on schedule here, let me introduce our next speaker. Very exciting for me because he's been one of my heroes that I've looked up to and the amazing work that he does. So please welcome to the stage Hildobby, who's going to be talking about a topic that we've actually been talking quite a bit about today, which is analyzing the impact of ETF staking. So please welcome Hildobby to the stage.
Hello, everyone. Hello, everyone. So I'm going to talk about the impact of ETF staking on the whole staking landscape in general. As a quick recap, first of all, I've been working in this space on Dune analytics for over 3 years now. In 2022, COVID happened, and I went full autistic on Dune and made a bunch of charts. And yeah, I don't know. That's how I started on here, pseudonymously with this little face that's a dying NFT, very, very dead now, and my pseudonym Hildobby. And I started at a time when I was quite surprised because the beacon chain had gone live, but there was no data to be found really on how it was performing. I thought it could be quite important for Ethereum, and I guess the interest really popped up after withdrawals went live. But the reason this event is also really important to me is because in 2022, when I launched this dashboard, there's 2 teams that reached out to me and wanted to give me grants. I was part of a quarter-check funding round from ETHtaker, and Lido also gave me a grant at the time. And I'm not sure I would be here without these early sources of revenue. I'm doing great. I'm at Dragonfly since 3 years ago. Don't worry about it. But yeah, that was a quick origin story on how I got here and why I do what I do. I've been trying to tag entities staking. Now, it's a bit of a gray area in terms of like doxing, what's okay to dox, what's not okay. I'm in the camp of it's okay to dox custodians who hold customers' money because it's also proof of funds and stuff like this. I'm also okay with doxing very, very large stakers, but I don't believe in doxing solo stakers. That's not really what I'm after at all. And so far I've staked about 75%. It fluctuates over time, and it's also harder and harder to keep on tagging entities and seeing who's actually controlling who's actually securing the Ethereum protocol. But what you do see here is that I have Coinbase tagged at 6.4%. It's actually much higher now because they're harder to track. I used to be able to track them quite well, but now they're all over the place. The reason I'm talking about Coinbase is because it's also the custodian for many of the ETFs, and therefore will come back being relevant here. Another thing, before talking about another thing, my tags have also been available on Beacon Chain, so if you see tags on there, feel free to give feedback if you think they're wrong, if things should be changed, whatever. Obviously, it's not a perfect data set. I'm trying to keep it as maintained as possible. But yeah, and if you want to remove tags as well, that's also completely fine. Please reach out. I have no problem with that. I've also been tracking ETFs. Now, you've seen many providers tracking reported flows, but I don't actually want to look at that. What I'm doing is looking on-chain and tracking the individual addresses and actually tracking what are the flows in and out of those addresses. Now, it's not easy because custodians aren't necessarily willing to give out those addresses, so there's quite a bit of sleuthing involved. But I consider that work kind of fun, I guess. And yeah, the reason I do it is, I guess, a little bit for fun, but also because I believe that when ETF launched, they would naturally eventually have staking and more involved, and on-chain tracking would make this, a clearer macro picture of what's going on rather than just looking at reported flows. So that's why I did all that. So yeah, I've got listed tags. I've got more than 10,000 addresses for all the ETFs that I'm tracking and keep on adding. You can query them. They're also useful for all kinds of on-chain analytics and other purposes. If you want to see, who's holding part of the supply of Bitcoin or Ethereum, those are large players and therefore worth looking into. But anyways, I digress. We're talking about ETF staking. Recently, Grayscale announced that they haven't been allowed to stake their ETFs, and that was on October 6th. And they went right ahead on the same day and started to stake. And they've been staking quite a bit of their ETH. That is across Grayscale, so that would be their product ETH-E, and Grayscale Mini, which is the ticker ETH. It's a little confusing because it's the same as ETH, I guess, but whatever. And then 21 Shares also has staked a bunch. Now you can actually see that when they staked on the validator queue, because it caused a 20-day increase in terms of queue time. So yeah, they're large ETH holders, so I guess to be expected. But this impact is going to be relevant going forward because they're not the only ETF issuer. They're not even the largest. We got BlackRock eventually coming at some point and probably going to have even a higher impact on the whole staking landscape. Now, ETFs have redemption requirements, so they need to keep some ETH on hand. You can't just take everything. Obviously, there's outflows into ETFs, and those are regulated products, and therefore some need to be kept. Looking at their current stats, they're basically staking about 70% of their assets. That's the initial amount they sent on October 6th till 8th, which is still actually, no, sorry, it's not in the queue anymore. It should be staked now. But anyways, it took a while. 70% is staked. And I actually looked at that percentage and wanted to extrapolate to all the other issuers and seeing what would be the impact were the others to do the same. I'm not actually, I've never really worked for the ACC or anything, so I don't know if 70% is the right percentage and will apply to others. I don't know if there'll be more degen issuers or less degen issuers. Not sure, but let's just take it as is and say that it applies to the rest as a ballpark measurement. So here you have the current ETF holdings for each of the issuers, only looking at the US for now, because that's usually what people focus on. It's the most relevant ETF issuers. Multiplying about 70% to get, if they followed in Grayscale's footsteps, what would they stake? Now you can see the impact on the deposit queue, so about 76 days. That would apply. I think obviously the largest is going to be BlackRock with the bulk of that weight, as well as the bulk of that percentage. But you can see as well it trickles down to the rest. What is important that I mentioned before is that a lot of these are under Coinbase's custody. And like I mentioned before, Coinbase is currently already quite a large owner of staked ETH. In fact, it is the largest single entity. And of course, like I said, they're really, really hard to track. I've been trying to keep tagging them, estimating, but yeah, they're not publishing it. They're not really showcasing that. There's an article that came out recently that said that they have about 11.4% of ETH staked, and there's a bunch more as well that is parked at partnering protocols. But if you look back on this, there's about 9.5% that would be staked with Coinbase, which I consider quite large. And back when we knew that they had like 50% and up, there was quite a bit of concern on in general about we don't ever want someone to control too high of a stake. They have seen reduced it, but adding that 9% on top would actually bring them back way over where they were when we were raid in the first place. So yeah, just something FYI I think is interesting to watch out for. I love Coinbase, by the way, no beef against them, just want to hold them accountable on this. I have a Coinbase account, great user experience. Now, there's other ETF issuers who have announced their staking. VanEck, which is much smaller, I believe it's 0.1% of would-be staked ETH, whether to stake, have gone for different routes. They've gone for Lido. Yeah, I think that's great. Lido is cool, and I understand when you're controlling a smaller portion, it's maybe easier to outsource it, keep it liquid, and I'm guessing they may face redemption. Given the smaller amount, they may face redemption limits that would require them to have a Lido liquid product rather than an ETF, much like Grayscale and BlackRock can have on their own side. But there's also, in the institutional side, you also have decentralized asset treasuries, which have grown quite a bit lately. And my assumption is that we'll probably see a similar-ish evolution to the ETFs. They can already do essentially whatever they want, but I do assume that quite a bit of this will probably end up being staked at some point. And it's over 4% of the supply, which is quite a bit. And that would equal to whether to stake 70% of all this, about 12 to 5% of all staked ETH. So in total, that would bring around 20% of institutional ETH being, sorry, lost my word, securing the network. And I'm sure it only goes up from here as well. Yeah, so that's, I guess, contextualizing, how much will be institutionalized in the staking landscape. I was really curious because, I don't know, we've been talking about this for so long. What, is ETH has always been at core about like the solo staker ethos and all this, but big players are coming to town, and yeah, I thought we might as well look into the numbers. And also, there's a follow-up discussion on ETFs in general with Anthony Chisano, Hong, who are going to discuss and talk about these potential, the impact of those things. With that, thank you very much. I work on a lot of data. This is the staking area, but you might have seen me in many other areas. I've done blobs, I've done ETFs, I've done central exchanges. Tomorrow I'm presenting my biggest project so far, which is Interop, made the biggest data set on Dune so far. So if you're at DuneCon, you're welcome to show up and see me talk about that. Thank you.
We do have plenty of time for questions. Are there any questions in the audience here?
Yeah, just with Coinbase disclosing the amount of stake they had, I thought this was going to be an ongoing basis. Was I incorrect to assume that?
They used to disclose it in their quarterly reportings, and I've been trying to sleuth through those and understand, because it's not clearly stated we stake this amount. I've been working with Stakehouse quite a bit on this, but it's somehow less clear on every reporting, and it's no longer in there as of 2 years ago now. Yeah, so I've been tweeting in the void.
Okay, we need to find Ben and tell him to get it sorted.
Yeah,
thank you.
That would be great. They have been disclosing CB BTC, and my assumption would be that eventually it would be the same for CB ETH, but that just never happened. And the answer I've gotten is essentially is just too scattered around many Coinbase teams, and they can't get it sorted themselves. But that's a weak answer.
Just a follow-up question to that: is there some standard or some type of published data that you would like to see institutions produce in their quarterly reports or disclosures that would help maybe form a standard for on-chain clarity and transparency?
So for ETF issuers, I originally wanted them to hopefully have to publish their addresses. Bitwise was the only one to do that at first. Unfortunately, their client saw this as a concern, and were actually, it was pushing them away from using the product. So Bitwise retracted from that and no longer publishes those. So I understand it from, like, it's not their fault, it's just the client's perspective. I'll keep tagging them and pushing their addresses. There's also the other concern for them, which is dusting attacks, because they have to report anything they hold, and that's just annoying regulatory work, because that's of course ETH on ETS, but also any other assets on the ETH blockchain. For Bitcoin, it's even ordinals that they had to report. It's just, yeah, it's a mess. So I understand it from the perspective. If there's something we can work out, I would love to. I'm just not sure they have enough interest for that for them to go through with this.
Okay, question right here.
Since, let's see here, Coinbase is securing all of this crypto for all of these companies,
yeah.
And let's say BlackRock wants to start staking, is BlackRock going to take their crypto back and then stake, or is Coinbase going to stake for them?
No, it's Coinbase custody that stakes it for them. That's what happened with Grayscale.
Okay.
And 21 shares.
So is that going to show up on Coinbase's portion as they're going to be quite a bit more, and BlackRock's not going to show up?
In theory, yes. You mean on my dashboard? Yes, it will. That's my goal, is to tag them eventually there. I haven't done it yet because there's a bunch of data work that I need to do in terms of code. But yeah, but they're scrambling their stake across many different things. So having the actual total is very, very hard now. Yeah, they keep on changing their custody models, like unstaking and restaking in different ways, and it's just, yeah, they're obviously pretty good at hiding on chain.
All right, one last question here in the back.
Thank you. Yeah, I have heard that actually Coinbase staked their funds with multiple node operators. I was wondering whether you have information or have you looked into that?
Oh wait, yeah. Well, on one of the slides, there's in their reporting from February, they said that they have like 500,000 ETH held in by other protocols, but they don't actually detail which. I don't know. I'm guessing Kiln and stuff like this is going to be those. I don't actually know. They're not very clear on that either.
All right. Well, once again, a round of applause for Hildabi here and his work.
Thank you.
Perfect. Give us just a second as we set up for our next panel discussion here. All right, well, I'm very pleased to welcome to the stage two panelists and a moderator here. The two panelists is going to be Hong Kim from Bitwise and Ben Hunter from BTCS. The topic, of course, is institutional staking panel, and it's going to be moderated by somebody who needs no introduction, Anthony Cezzano. So welcome to the stage.
All right. Hello, everyone, and welcome to another episode of the Daily Refuel. I'm glad that got a reaction. It makes me feel good. So yeah, we've got a great panel here for you guys today to talk about, I guess, the boogeyman in the room, which is institutional staking and what that means for the Ethereum network. Yeah, I mean, I guess personally I'm less bearish on it than others out there. I think that it's actually a healthy evolution of where we're kind of going as an ecosystem. But yeah, before I get into all of that, I just wanted to let these two introduce themselves and what they're kind of working on. So yeah, Ben and Hong, just introduce yourselves.
Yeah, hi, I'm Ben from BTCS. I'm the VP of Engineering there. BTCS is a publicly traded Ethereum NASDAQ company. We focus on Ethereum infrastructure, but we're also a digital asset treasury by second nature as well. So we accumulate Ethereum funds and deploy them into DeFi and staking.
Thanks. Great to be here. I'm the CTO and co-founder of Bitwise. Bitwise is an asset manager that specializes in this asset class. And we manage about $10 billion worth of client assets in ETF-like products, generally regulated financial products. And we also have a staking division that stakes about $5 billion worth of ETH in a self-custodial manner. So that's not inside the kind of traditional investment vehicles, but just clients that hold ETH directly. So I think those are the two kind of ways, yeah, that we engage with this question of like institutional staking within our financial products, and also institutional staking offering to institutions that custody ETH themselves, but stake through us.
Mm-hmm. Yeah, so maybe the first thing I wanted to talk about was something that I think a lot of people have a misunderstanding about, and that's kind of what providers or what staking kind of setups the ETFs are going to use and the DATs are going to use, because Hildobby had a slide just before talking about if all of these ETFs stake with Coinbase, then Coinbase's staking share goes up massively, and that's really bad for the network. But I think a lot of these entities, DATs or ETFs, they actually aren't going to stake with Coinbase. They're going to be doing their own operation for a number of different reasons. And I know Hong Bitwise recently acquired Attestant, which is a staking operator that has been around for a while. And that just, I guess, like for me, sends a further signal out there that you know, the ETF issuers and the DATs are interested in running their own setup. So maybe you can talk a little bit about how Bitwise is going to be approaching this and what that kind of looks like in the context of the broader Ethereum staking ecosystem.
Yeah, absolutely. So Bitwise acquired Attestant last year. Attestant was a small focused team around ETH staking and has been staking since the genesis, and also is well known for the open source contributions around Vouch and Dirk. And they were experts and very much aligned with the ecosystem and network that we really loved, and brought them into the Bitwise fold last year. And yes, I think something worth noting is like Coinbase custody doesn't mean that necessarily if you're staking through assets custodied on Coinbase, that's going to Coinbase's validators. Mm-hmm. They have a number of validators on their platform, 4 or 5, let's say. Attestant is one of them. So our ETFs on the US side is custodied with Coinbase, but would be staked with Attestant. Mm-hmm. That is the case for BlackRock, Fidelity, or like the other large issuers as well. So I think it's worth considering the difference between custodied and then staked can be a different operator, even though it's from that type of setup. And yeah, I think the way that we thought about it is that staking is a much more active relationship with the protocol and the network than custody. Custody just involves custodying the private key, and it's much more of a passive role. But staking and participating in consensus is much more active, and that we wanted to be have a product where we engaged in that way, and that is a way that we can be different from the BlackRocks or Fidelities of the world. Mm-hmm. In some ways, you can think of Bitwise in the US ETF world. We have about a $500 million fund, and the total kind of assets in US ETFs maybe 10, 15 billion or so. Mm-hmm. So we have, let's say, something like 5% market share. So we're kind of like the independent solo staker of institutions, let's say. And I think that role is very valuable because we can push for practices that we think are both institutional and better for the network, and implement them in these regulated products and demonstrate to the world that it's possible to do it that way. Mm-hmm. And Hildobby mentioned that, like, we did that, for example, with Bitcoin ETFs, where we published the addresses and demonstrated that that's possible. You can do proof of reserves in these US regulated ETFs, and we also donate 10% of the profits of the ETFs on the ETH side and to the Protocol Guild and the PBS Foundation. So, like, we're one of the main ways that we think about how we're different from just the traditional players is that we have traditional products, but we try to build them in a way that is that can be kind of further contribute to the network and the protocol, and that people that care about that buy our product. I mean, there can be a symbiotic kind of relationship there. So I think staking was one of the elements that we thought of as something that we can take on that could make our product better, and that we can also contribute back to the network as well.
Mm-hmm. Yeah. So I guess, Ben, shifting over to how the DATs view things, I think the DATs maybe have more flexibility than the ETFs do in order with, what they can do within staking, but also what they can do outside of that. I know BTCS has been doing Ethereum staking for a while now. One of the first, I think, big entities to kind of do it. So maybe you can talk a little bit about that and how maybe it differs from the ETF context.
Yeah, one thing that we say is that if you're a digital asset treasury on Ethereum and you're not doing active operations of your assets, you're worse than an ETF.
Yeah,
Why would you buy a DAT that's not doing operations on chain? You should buy BlackRock, or not BlackRock. Sorry, otherwise. Not BlackRock. My bad. For the little slip right there. But yeah, we look at it from the point of view that we're really fighting for BIPs over other DATs, right? And if you're selling or giving away BIPs to a staking operator or node provider, you're not going to be competing on the same level as a digital asset treasury that's staking in-house or doing operations in-house. We see that as a huge competitive edge over other DATs. Obviously, other DATs are doing the exact same thing. I mean, once these DATs come online, they see the opportunity with LSTs to get staking almost immediately with very little operations. But they're giving away a good portion of that to the middleman, right? But yeah, I think it's a huge competitive edge to have in-house operations, and obviously companies like SharpLink being so close with Consensus, and already Consensus having operations with that, it's very natural for them to get into there, where we see other companies like Bitminer taking a little slower and more conservative approach for that.
And I think that might be another thing that people kind of miss is that, like, as you said, it's about BIPs. It's about kind of generating the most amount of value that you can for what you're trying to do here. And Ethereum staking has become incredibly competitive, not just with the ETFs and the DATs, but also with all these other kind of protocols out there. And that's actually healthy for the network.
For sure.
So if we were to talk in the context of network health, which is what a lot of people tend to worry about, it's like these bigger stakers these bigger institutions coming on board and staking, people will obviously worry and say, oh, well, what if they get like such a huge chunk and then they've got a vested interest in, going after the core development process and influencing that. So that's always a big concern here. But for me personally, and I've spoken to a bunch of people about this, I just think that the fact that we have this broad competition between the DATs, between the ETFs, between the existing kind of providers, and obviously the solo stakers, it's actually a really healthy ecosystem, and it's very hard for any of these entities to actually acquire a large percentage share. Even the greatest boogeyman, Lido, that we've all been talking about for years, their market share has gone down considerably as well. And in the same kind of time, they've actually become more decentralized, or they've at least moved towards a model where they can onboard even more operators. So on that kind of topic there, how do kind of you guys think about that? Do you think that there's a certain point where you think that your percentage of the network stake should be kind of capped at? Like you think, oh, maybe if we get to like 5%, 10%, we shouldn't go beyond that? Because that was another discussion that also happened within the Ethereum ecosystem, is like self-capping, which doesn't really make sense from an economics perspective. It's like, or from a capitalism perspective. But like, do you often think about that? And kind of how would you approach that if you were to get to that level?
It'd be a great problem to have.
Yeah, exactly. Like 5-10%. That's the thing. I think because there's so many providers, it has become very difficult to get there.
Yeah, what they say is Tom Lee's coming for your ETH, right? So hold on.
Exactly. Yeah.
So I think that the risks of so much Ethereum being held by institutions in the U.S. is obviously censorship is the biggest one, right? Like I don't really think that there's a huge centralization risk of too much capital being held by a single entity, but all of that capital or all those validator operations like being run by institutions, you see OFAC compliance being a major concern, right? Which is a huge concern of ours as well. Like we've been working with teams like Shutter to help facilitate encrypted mempools into Ethereum so that we can get around that in the future, and hopefully that the protocol is able to get past that censorship resistance, or to get more censorship resistance to the institutions. But yeah, overall, in terms of self-capping, I don't think you can get any of these any public companies to self-cap.
I think for things like censorship resistance, I think that's why proposals like Fossil are very important, because ultimately the network can't be censorship resistant over time if the way in which it maintains that is to rely on stake weight, the largest stake weights to agree to censor or not censor. That's a very fragile system in some ways. And so if a minority home stakers, solo stakers, or smaller participants, I mean, like in the US ETF world, I said that we're 5% market share. So if our 5% market share of the validators that we run with kind of our own principles that might be different from BlackRock or Fidelity can contribute to censorship resistance in a meaningful way. And in the current world, it might not be, like our relay setting. Anyways, but I think that's why if we can solve it in a protocol and network way, like things like Fossil, where a small minority can contribute to a meaningful amount of censorship resistance, and that would be the kind of preferred protocol solution. Right. Another thing that I would just say on this note is that I think the way that Bitwise thinks about this question of institutional staking growth is, can we actually make the network better as an institutional staking provider and our stake weight growing? And so, like, an example of that is that we write our own multi-node validator client called Vouch. And what that allows you to do is that it allows you to run multiple consensus clients and have a stronger consensus rule internally within a validator about what blocks you would attest to and propose. And so, for example, the kind of super majority fork problem that we had on Plesky, if you want to avoid that type of problem yourself, and if a significant portion of the network had that type of policy, then that would make the chain itself much more improved in terms of addressing that type of supermajority fork risk. And so that is something that we write that software and maintain that, but also we run it in that way. And so we're increasing the stake weight that is considering the long tail of protocol risks that maybe a smaller player might not be thinking about, because you have to run all of the consensus beacon nodes rather than just one, and that is a kind of higher requirement. Another example is we write and maintain a threshold key signer called Dirk, which is essentially kind of sharding or kind of MPC, like multi-sig type thing for validator keys. And that requires you to run multiple machines, and we also make sure that they are in different server providers as well, so that you have much more resilience and security. And that increases the security and resilience of the network ultimately if more of the network is less resilient to kind of single validator key risk. And it's just a bigger operation. You need to maintain more server provider relationships. We run all of our machines in bare metal server providers, and so maintaining those providers and machines and like set up for failover and all those things requires more work. But if you're set up as a company to do that, and that's what you do, then you can get it done. Right. And so in that way, the larger amount of the stake weight of Ethereum can be more resilient to higher uptime and security. And so there's exciting aspects as well. I was talking about ETFs for a second before, and ETFs allowed us to do kind of profit donation to open source. ETFs allowed us to do kind of proof of reserves, because again, the pooled aspects of things allowed us to do something different. So I think that's how Bitwise thinks about it. Like institutions, or kind of an institutional approach to things, isn't necessarily de facto bad. There's actually opportunities for the institutional approach to actually improve the network, because we're a different type of participant in the network. And of course, there's the risk that the large kind of economic agent or actor doesn't care about the network or the product properties of the protocol. But that also kind of motivates me to grow Bitwise, because I want to make sure that a large economic player cares about the network and consensus and all these things.
Yeah, we see that a lot with DATs. They look for the lowest lift way possible to get yield exposure. And you're right, you have to be an active participant in the network, and there's a lot of these amazing tools out there, especially DVT. Obviously, we're going to be hearing from plenty of people about DVT. It's been around for a long time. Another team at Obel and SSV are making huge strides in the resiliency for these teams as well.
Yeah, that might be something that a lot of people may not know as well. Like you mentioned Vouch. I know of Vouch because I'm a nerd and I followed Attested for ages, but Vouch is probably something people haven't heard of in the audience before, at least some people haven't heard of before. But as you mentioned, there's DVT as well, and there's other technologies that make staking or running validators or being a node operator safer, more efficient, more secure for these entities. And actually, like, there are ways that you can have these setups that you actually take your own kind of power away, like in terms of your control over your setup, so that it has to go through multiple kind of layers in order for something to kind of happen here.
Yeah, and just on that note, like we talk about client diversity, Ethereum community puts in so much effort and to some extent takes a hit on coordination overhead and execution speed to maintain many clients, right? We have 6 consensus clients. So 6 teams writing and coordinating the same spec is much more, there's a hit on that. But there's a benefit to that. But in some ways, we're not maximizing that benefit, because we say client diversity, but like you have 1,000 validators and 20% is running Prism and 10% is running Lighthouse, et cetera. But from a fleet perspective, you might have diversity. From that validator perspective, if Lighthouse has a bug, that cohort of validators will go down, and that cohort of the network will go down. And unlike any other network that does not have client diversity, Ethereum actually has the ability to have none of the network go down when any one client has an issue and crashes, because you could actually have a multi-node validator client like Muroch, where you're actually just running everything in parallel. And if one is just not up, then you can attest and propose blocks with the other consensus clients and beacon nodes that are up. And that's actually client diversity in the maximal way, not the like you have 10 machines and you run different consensus clients on each, but you actually run everything on all of them. And that is like, so I think like these types of it's not just prudent for the assets and is kind of part of the fiduciary responsibilities like issuers like us have, but I think there's ways in which it can concretely benefit the network's resilience.
Yeah, and I do find it funny, like you mentioned other networks. They're so weak compared to Ethereum if you look at it from like a validator kind of staking perspective. Like we're talking about things here that are really tail risks a lot of the time. Like they're edge cases, they're things that are worst case scenarios that we don't really expect to happen. And we've seen some pockets of stuff like over time, like obviously in the context of client diversity, we have seen some clients be super majorities, but then because we have client diversity, we could fix that. Then you have other networks out there, like even Bitcoin, that do not have this, and that it's quite risky. So I do find it a little bit funny how we put so much emphasis on this in the Ethereum community when we're actually in an amazing position already, and we've also future-proofed it, because you mentioned Fossil before. Yep. We're kind of future-proofing everything and putting in these changes, but it is very different to everything else out there. Like I haven't seen this level of focus on this kind of stuff from any other ecosystem, which is really cool. So I think Ethereum is well positioned there. But you mentioned DBT. I would like to just quickly hit on that. I think we're out of time soon. But DBT is another technology, distributed validator technology, that allows us to have more kind of like resilience in the network. So maybe you could touch on that. And is BTCS using it yet, or do you plan to kind of use it?
Yeah, we haven't announced it officially yet.
Okay.
But, it's coming into a public company. It was a big shift for me from private to public, so I can't share too much information.
Yep.
But we are actually we are transitioning to DBT right now. Actually, internally, I can't say the team.
Yep.
But we do see that as a huge benefit. The geographic diversity, there's huge incentives on there as well. Like we said, we're fighting for BIPs, but it opens you up to a lot of new possibilities on there. And there's also the ability to be client diverse through that as well.
Yeah.
So, yeah, and likely we'll be moving to multiple DBT solutions, multiple client solutions. I know Vouch is a great tool. There's also another one. I forgot the name, but I see the guy. There we go. And so it's great to see that the market is actually focusing on the things that do matter. And those worst case scenarios do happen. We have seen issues where some clients are having adverse network effects through hard forks, and those teams are great at patching very quickly, but it's also a huge risk. But luckily, the network is so diverse.
Yeah, well, exactly. It is so resilient, so diverse, and it's kind of crazy. Like even if you think about, you mentioned the client teams themselves. Like we even think about funding those people like long term. Like what if the EF went away? Like how do we fund these people? So just all of that kind of I think is extremely valuable, and it's why I don't worry about institutional staking being like this big thing that's going to like take over the network and everything's going to be, you know, bad. I think we've put in enough kind of guardrails and enough different kind of ways of staking and making things resilient that we're actually really well positioned for the future there.
Completely agreed.
Yeah, yeah. Unless you guys have anything left to say, I think that's time there. If you wanted to add anything, Hong or Ben?
Yeah, I think the part two I fully worry about if institutions start meddling in the kind of like L1 protocol roadmap type of thing.
Yeah, yeah.
So I think it's good for players like Bitwise to have a good distance from the client development, especially on the L1. And so that's why, for example, in our ETH ETF, when we think we should still be funding the development because our business depends on it, and also we have some economic ability to do so. So that's why we donate to the Protocol Guild rather than individual teams or individual people, because that's a more credible way for us to have an arm's length distance between the decisions, but still support the development. And yeah, and I guess we think a bit differently on the staking operational layer, because that is more so taking the protocol and running it in a way that is resilient and secure. And we have views on that, and we think that there's ways in which we can do a better institutional job about it without having the kind of distortions around the protocol direction.
Yeah, on the tone of what scares me most about institutions is how institutional, I guess, trust in Ethereum could be lost quickly by an institution losing access to their keys, losing access to their crypto, and doing things the wrong way. And so we do actually recommend teams if they aren't comfortable doing it in-house. We've talked to a lot of these newer dads across Ethereum, BSC, and other networks as well. We push them in the direction of other custodians.
Yep.
Because we want that one goes down, it's bad for all of us.
Yep.
So that keeps me up at night.
Yeah. So. Fair enough. Okay. Well, yeah. I think questions.
We actually might have time for about 1 or 2 questions here. Yeah, okay, in the back row.
Sorry, not a question, but just for a piece of history, I think the client diversity really showed in the Shanghai DOS attacks.
Yes.
I think that was a big point of people remembering how hard that was to get through.
Yes.
Yep. And also, I think in the proof of stake world, on the consensus layer side, we've had some issues there as well with participation drop-offs. Don't think we've lost finality, but we got close. So yeah, another point there.
Yeah, and also in the PBS lifecycle as well, some clients weren't fully signing the blob payloads, and we saw a huge loss on that. I used to work at Blockstrat, and I was part of the team that kind of caused the issue. But
yeah, okay.
There were actually some client teams that were able to work around that properly.
Yeah,
so,
awesome.
Yeah.
Hi, I was wondering if you had any thoughts on like liquid staking tokens and using those, or even like restaking would be even more risky. But yeah,
I have a lot of thoughts on liquid staking tokens. I've talked about it at length so much already. Liquid staking tokens have been at the forefront of innovation in the space lately. A lot of people are looking for clarity from FASB and the SEC specifically for holding liquid staking tokens. Personally, at BTCS, we don't touch liquid staking tokens because we've seen 2 different companies, specifically SBET and ETHZilla, take opposing views that one of them will have to restate their financials because of it, and we don't want to be on the wrong side of that. It's a very, very bad thing for investor relations and trust in the market. Well, not liquid staking tokens. Liquid staking tokens are great, but the lack of guidance from the government right now has been a huge hindrance for us to get into that.
Let me ask maybe a follow-up to that question, which is, a couple of the liquid staking protocols like Lido, CSM, Rocket Pool, they use a distributed validator set, right?
Mm-hmm.
Maybe not DVT, but just home stakers, right, that participate in their network. Have either of you two considered using their node operator set to help diversify your operators?
We are a node operator on Rocket Pool. That was one of the first initiatives when I got to BTCS was to join one of the distributed networks as well as a node operator. But yeah.
I think it would depend on the product, but I think for ETFs, especially in the US side, there's more requirements around having direct relationships with service providers and understanding kind of their operations and liability and how to deal with those things that make it a little bit hard to interact with a kind of a pool of operators that we don't have those types of relationship with. So yeah, but that's not the gating factor of using LSTs inside US ETFs, for example. The gating factors are more so for the largest products that are kind of commodity ETFs. Those are single asset products. So it's hard to blend ETH and LSTs. And if you're creating a single LST ETF, then that has its own trickiness and issues. So there's some complexity there. But yeah.
Excellent. Well, please give our panelists and our panel members a round of applause.
Great. Thanks, everyone.
All right. Our next talk here, we're going to have dual presenters here. Perry with ETH Panda Ops and Barnabas with the EF. We're going to talk about Fusaka and testing the deep dive. So please welcome them to the stage.
Sorry? Yeah.
Can I need a
clicker?
Hey everyone. Just for the record, I'm also with the ETH Panda Ops team. But yeah, it's part of the EF. So today I'm going to be talking about Fusaka, what we have done in the past year and a half. Fusaka has actually been Pactra B, which basically means that we wanted to have PeerDAS in the same fork as Pactra, but then it started to grow so big that we just didn't see it as a viable option. We decided to take the headliner topic, which is PeerDAS, out into the next fork, and that is what we are going to talk about today. So Fusaka brings a bunch of other EIP improvements also, scaling the L1 and the DA at the same time. This includes the topics that Marius talked about earlier today, raising the gas limit to 60 million, basically limiting the maximum block size to 10 megabytes, ensuring that we can scale the L1 as efficiently as possible. We introduced the name of BPOs, so this is basically a light fork. We're going to be able to increase or decrease the target and max block count without needing to we can do a hard fork without much organization from the client teams. Like, we are not changing anything other than the block counts. Then we have a bunch of repricing EIPs. We don't have enough time to go into each of these independently. And we have a new opcodes that improve the UX. And the pre-confirmations are going to be enabled by deterministic proposal Luca had. So how could we actually manage to ship 2 forks in 1 year? This was just because we started to work on PeerDAS very early on. And we were pipelining shipping of PeerDAS from Kenya last year, which was around May, if I recall correctly. We had parallel work on Pactra and Fusaka. In the meantime, we had one CL dev from each team working on PeerDAS pretty much for like the past 12 to 15 months continuously. The first PeerDAS implementation appeared in June of 2024, and without having a dedicated person from each client team, we would have not been able to ship 2 forks in the same year. From this, maybe we can talk about PeerDAS and what is PeerDAS. So currently today, every single validator downloads every single blob, and this blob is then going to be served to the whole network. Going forward, if we want to scale up the number of blobs, what we have to do is, while keeping the network decentralized, we have to make sure that each blob can be split up into a smaller section so that small validators can actually still validate the chain, propose blocks, while bigger validators will actually take over the load of the heavy lifting. So if you have a small stake of like 32 ETH, for example, you're only going to need to custody a few sections of all the blobs, a few columns. This column is a new concept, and this enables us to split up the load in the whole network. While the larger operators will actually have to have an increase in resource usage. This means a bit more compute, a bit more memory usage, and significantly more bandwidth usage. This will enable us to have a larger blob capacity while keeping the network decentralized, and more blob capacity will enable L2 scaling and cheaper transactions for everyone. What is actually under the hood of Spectra? So, as I mentioned in the previous slide, blobs will be split up into columns. The nodes will have to advertise how many columns they have available. So this is introduced under a new field called the CGC, the custody group count. The columns will be then propagated to the relevant nodes. So a specific column will only go there if that specific node needs it. And the columns then also can be reconstructed to save some bandwidth. So if you have 64 columns, for example, you can just reconstruct any columns in the network. Nodes with over 2048 ETH will become the super nodes only. So if you don't hold 6.4 million on your home machine, then you probably don't have to worry about this. But some node operators, such as the Lido CSM operators, will actually have an issue where they don't actually hold the funds, but they stake on behalf of someone else. So their resource requirements will be actually increased. But yeah, we assume that significant part of the supernodes are expected to be sophisticated entities that will have the resources to run these heavier nodes. So what actually helped us achieve testing? We have a bunch of tools. You probably heard about Dora. We had a PeerDAS column custody overview, which enabled us to oversee which node custodies which column, and this gave us a very quick overview on just debugging in the network. Like if we expect that a node is a super node, then we want to make sure that the super node will show up in all of these columns, and if we have a non-validating node, then it would show up only in 4 separate columns. This also helped us debug peering-related issues. We also added Desk Guardian. This was a collaboration with the
Probe Labs.
They helped us build this tool, and then we integrated it into Dora as a library function. Basically, the main fields are the new earliest available slot and the column custody here. So this helped us a bunch to debug early issues with different CL teams. What else? We also added ethconfig support into Dora, so we can have an expected config value on one side and the actual client, what the client is reporting. This doesn't seem like a big thing, but actually clients like to just configure their clients however they want instead of whatever the spec is saying. So this really gives us a very easy way to see if they messed up something. This is also working now for the EL. And Syncer. So Syncer was built by Rafael from our team. Synchro enables us to basically run a sync test, let it be a checkpoint sync or a Genesis sync for super nodes or non-super nodes, and it gives us statistics on how long the sync has taken. And we run this on many times. So for example, on our DevNet tree, we have run it over probably 100 times to see how the state grows and if we have any syncing issues altogether. And I will pass it to Marius.
So I'm going to talk about what else helped us test it. So another tool was Spammer. So Spammer was a tool we had that we can configure a lot of custom scenarios on. And these custom scenarios can be real life transactions. So similar to like Uniswap transactions or blobs that we expect L2s to submit. We also want to talk a bit about why it took so long. So what was the requirement? Why was the requirement changing that took 15 months to ship PeerDAS realistically? Even though it feels like a 6-month fork, it only is a 6-month fork because we pipelined it. Well, the core EIP was implemented relatively quickly. However, we went through multiple rounds of bottlenecks that we found. One of the bottlenecks is that it takes about 100 milliseconds to compute proofs for a blob. And this is fine if you have like 6 blobs, you can afford that. If you have 40 blobs or 72 blobs, which is the theoretical max of the design right now, that doesn't work anymore. You have a 4-second attestation deadline, and you need to take 7.2 seconds to even generate the proofs. That just doesn't work. So one of the bigger solutions was to move the cell-proof computation during the time the transaction is being sent. So your transaction, the blob sender will take slightly longer to submit the blobs, but in the critical path of the chain, we no longer see this problem. This took a bunch of time for tooling support, for client support, RPC support, a lot of discussions about how to maintain backward compatibility and so on. So this was a huge topic for us. There was also a lot of peering issues, which you can expect in a networking change. One of the larger ones was that if you're trying to request columns from an older node that's recently joined the network, you tend to ask for something they might not yet have. And you don't know necessarily if they have it or not, so you're unnecessarily penalizing them. The solution for this was to add some information such as earliest slot, so the client can actually say, hey, I'm your peer, these are the columns I'm custodying, this is the slot that I have data up until, so don't try to ask me for something outside of this, and don't penalize me if you do so. So this helps a little bit with especially non-finality scenarios, because when you have a non-finalizing network, there's a lot of nodes syncing at the same time, and it leads to these weird edge cases that are just very hard to recover from. Since we've deployed this, non-finality scenarios have been quite good, actually. And if you're interested, like Fusaka DevNet 3, even today is going through a non-finality test, but we're, I guess, so confident about it, we're here on stage instead of actually looking at if the test is successful or not. How much can we even scale, right? So the next big question is, we have PeerDAS. We know the theoretical max of the system. We've found a couple of bottlenecks, but what is the actual scaling that we're going to ship with? Were we going to go from 6 blobs to 72 blobs immediately at Fusaka? That was the original idea, but the longer we looked at the problem, the more unsafe that felt. That's why we introduced the concept of a blob parameter-only fork. This essentially says, don't change anything about the fork, just change the blob number. And so far, we've defined about 2 BPOs, and we have a plan to define another 3. And this allows us to do it stepwise. So we can do minor changes, deploy a networking change, probe the network, see how it reacts, and then do a bigger change. The reason this is also important is, as much as we can define devnets, we can do 1,000 node, 10,000 node devnets, the problem is mainnet is always deployed differently. However, a certain staker chooses to deploy their node will go into the peering logic. And there's no way of accurately simulating that, at least not today. And that's why we wanted to go with the safer approach. And the next question is, what is the right number, right? We chose chose that we want to go to a safer approach. We chose that we want to split it up into steps, but someone has to still find out the step and find out how to find out the step. And this is where the Zatu tool from our team comes very handy. There's a concept of a Zatu sentry, and this connects to the Beacon API. There's also a concept of client forks that we maintain, and this is allowing us to get very deep visualizations into the peer-to-peer layer. We also have Contributor, which if you're a home staker, you should be running. This will collect as little information as we want from you, and this will tell us how timing variances work in mainnet. And all of this will go into analyses that give us insights into what our blob scaling numbers could look like. We also want to give a shout out to Sunnyside Labs. We did really large networks, probably the largest we've done before. We did 2,000 node networks alongside with them. For a scale, there's about 10 to 20% the size of mainnet. So that's probably the largest we've done in a while. We had to do a ton of optimizations to even get there without everything just out of memorying. And this leads to this beautiful blog post done by Sam. If you ever have doubts about how we reach our scaling targets, please talk to him about how he's analyzing the data. You can see a clear trend where the blob count looks quite good at the lower we go, and the higher we go, it looks iffier. And that's why we aren't immediately announcing a jump from 6 to 72. Rather, the next 2 BPOs go all the way to 21, where even from the time where this graph was taken, we have a lot of optimizations already put through. So we don't imagine any issues immediately. And then there's another whole round of optimizations that will get shipped, like partial cell proofs. There's a lot of peer-to-peer optimizations that go in that make us feel more confident that we can then schedule the next tranche of BPOs shortly after. There's also the Syncor tool, and this was very important for us to actually figure out, hey, if we go to 72 blobs and we have a home staker with 50 Mbps internet, are we going to make them take 4 days to sync? So this sort of helped us try out full sync, supernode sync, as well as varied number of blob targets and non-finality, and then throw all of this into nice dashboards and figure out, okay, this looks like a reasonable target for now. And in general, the phase is you have a testing phase, you do these 2,000 node devnets, you have an estimation phase where you collect all of this information, you look at it, you then schedule a fork, you enjoy the scaling for a bit before people complain that scaling is saturated. Then you optimize and repeat. And this is the loop we want to introduce for BPOs in the future, and it's something that's going to keep happening over the next years. And that's our talk, and we're happy to answer any questions you have about Fusaka. Thank you.
For the supernodes?
Yes.
How do you actually calculate that there's 2048 ETH on a machine? Is it like keys in a certain validator client? So if you ran multiple clients, could you stay below that threshold?
So when the validator spins up, it registers itself with the beacon node. And then based on these registrations, you would know how much stake you're custodying. And then that goes into the beacon node's information of how many columns it needs to custody. So you could take your one validator client and then spread it across, let's say, 20 different machines, each of them just touching one beacon node, and then you would have lower resource use. But the argument is if you have 2048 ETH, it's probably better for you to have it pointed at one beacon node or a few for redundancy rather than kind of chunking it into smaller ones.
Yep, sounds good. Thanks.
Yeah.
And it's based on the effective balance, not the validator count. So
yeah, that's true.
It doesn't matter if you have one validator with 2000 ETH or, you know.
Yeah, from the perspective of the protocol, we just care about how much ETH is staked, not necessarily the validator keys themselves.
And this value only goes up. So we made this change later on, like around July this year, where the CGC value of a beacon node will only go up, so that even if you start removing validator keys, the beacon node will not decrease its CGC value. This was an optimization. We decided to go with it. In case you just want to reset your CGC value, all you will have to do is remove your database, start fresh, checkpoint sync, and then point one less validator to that beacon node.
Okay, I honestly have a shit ton of questions. I don't know which one to select. Let's keep at this topic of a supernode.
Yeah.
So we have two things. We have this peer DAS where we are saying that 2048 ETH is a supernode. At the same time, we have people saying, hey, you should consolidate.
Yes.
Which means that with the consolidations, 2048 is just one validator.
Yes.
And it's already a supernode.
Yes.
Exactly. But that's why from the perspective of the protocol, it doesn't matter if you had 200 validators or whatever the number works out to, split with 32 ETH each, or you had one validator with all of that stake.
Yeah, that's understandable.
Yeah.
Okay, now to BPO schedules. So you said that 2 are already scheduled.
Yep.
Does it mean that they are now inevitable?
No. So that's also why we have a bigger gap between the BPOs, so that we can actually look at the network, analyze if the performance is degraded, if it has, if we have to ship any optimizations, and we still have the option to cancel a BPO. We just reschedule it.
Yeah, so the question that scares me more is not network immediately degrading after a BPO, but BPO coming out, us not seeing a real increase in demand. So if you raise limits, but the actual consumption is never raised, and then you raise limits one more time, you've basically never tried the thirst limit.
Exactly. So the solution there is for us to pay a bunch of money to make sure we're hitting the limits, at least for shorter durations of time, so that we can probe the network at the limit.
Thank you very much for that.
Blobs are surprisingly cheap, so we can afford to saturate them when it's important.
Now as a CSM validator and my almost super node, your test's going to cost me a bit of a gigabytes on my drive.
Yep.
Okay, thank you.
Yeah.
Thank you. Just one last question here, because we are at time for it, but I don't think your talk specifically covered it, but let me ask you, which is, Fusaka is scheduled, I believe, for December 3rd. Is that correct?
Yes.
And a lot of the conversations, both yesterday and here, is it definitive? Is it going to happen? Is there anything that's going to stop it, or is it December 3rd?
So the client releases are already out. The blog post has been shipped. So unless we find a mainnet breaking incident in the next couple of weeks, it's scheduled for December 3rd.
Okay, perfect, perfect.
As well as the BPOs, like as we mentioned, 2 BPOs are already scheduled. So the first BPO will be happening on the 9th of December, and the second one is, I believe, around the 7th of January.
15th.
15th of January.
Yeah, but that's why please update your nodes. The moment you notice anything funky, let us know. We will be probing the network, making sure everything looks good, but the more the eyes, the better.
Barnabas and Perry, thank you very much for an excellent presentation.
Thanks.
We actually still have an amazing lineup of three speakers here and a very fun staking quiz game at the end to conclude us here. But let me introduce the next speaker, a good friend of mine. I've known him as Freeborn. It's Izzy with Lido. He's going to be talking about upgrading Ethereum and upgrading Lido. So please welcome Izzy to the stage.
Hey everyone. Okay, I think it's working. All right, upgrading Ethereum, upgrading Lido. When I wrote this title, it sounded a little bit better than it does right now. It sounds like a coming-of-age movie, but to a certain extent, it is. What happens when a protocol grows up and it has to face a lot of costs? The point of this talk is not really to shill anything. It's kind of to give you guys like an educational introspection into how, when the base layer evolves and upgrades, how like the large actors or participants on the network receive these changes, how they need to think about them, and what it means in terms of like how do you implement, how do you stay at pace together with the evolving base layer, and what it means for the users, for the app layer, and for the ecosystem in general. So yeah, how network upgrades inform the trajectory of Lido specifically. I'm Izzy, like Ken said, Freeborn in a bunch of like the Discords, and as of May of last year, I'm Chief of Staking at Lido Labs. So in general, we're going to cover like what are upgrades. It's pretty obvious, I think, from like an Ethereum perspective, but I'll try to distill a little bit what that means in terms of like upgrades from a protocol perspective, understanding how a protocol like Lido is affected by Ethereum upgrades, in which cases it is and which it isn't, and how we assess those upgrades and what we do about them. Example upgrade that we'll take a look at, like EIP 7251, which is actually quite topical, and then just some closing thoughts. So Ethereum is an ever-changing protocol, and Lido must keep pace. There is a tension, I guess in general, in governance circles around, are we aiming for ossification at some point in time? Like, how great is trustlessness and immutability in terms of like an end goal? And to what extent should this be an ultimate objective for everything from the base layer to the apps that are on it? I think in general, like those are like pretty good goals, but in a lot of cases, it's very, very likely that immutability isn't possible. Or at least it isn't possible until the base layer stops changing. And at what point does the base layer change? Like, we don't really know. In order to continue to be a force for increasing the accessibility, utility, and participation of everyday users in securing the network, like that's what Lido does in my opinion, on-chain staking protocols in general, whether they're Lido or not, have to maintain feature parity with the underlying network. But there's a couple of key implications that result as a result of like this premise. So one is it's practically infeasible to create a successful staking protocol that's immutable. And by practically infeasible, we mean that like maybe it's technically possible, but it doesn't make sense because nobody's really going to use it. From a technical perspective, since the consensus is constantly changing, there's way too many future unknowns to be able to say like we don't need to make any more upgrades, and now we can have an immutable protocol. If you're an LST, if you were to have immutable protocols, basically every version would need to be a new protocol. So this means that multiple versions would lead to fracturing liquidity and complex dynamics with regards to integrations in CeFi and DeFi. You would need to integrate new tokens every time. And then thirdly, you'd need to ask users to migrate from like the one version of the token to the new version of the token. And this is horrible UX. Like nobody's going to do that, and that's not a product that anybody wants to use. And there's a fourth point here, which I forgot to add, which is like security implications. So immutability is great if the underlying system is relatively simple, and you can be pretty sure the first time that you got it right. But as we can see in DeFi, there's a lot of bugs that or exploits that rear their heads much, much later. We saw with Balancer, like 4 years later, a tried and tested protocol was like surprised by like an exploit that maybe we would have caught if it was audited now, but we didn't catch back then. You see things like compiler bugs, like in Viper, you know, that end up again 2 years after something has been pushed to mainnet, exploiting protocols. So immutability is a great thing from like a values perspective, but it also introduces complexity and potentially even risk from a security perspective. And secondly, upgrades for on-chain and decentralized protocols are complex, are expensive, and they basically result in meaningful disadvantages via centralized alternatives and competitors. So when we think about what the market looks like 5 years from now from a staking perspective, we need to take into account what the costs are for each of the different actors in the space to adapt to the changes that are introduced by new changes in the protocol. So this is like a very, very high level and basic way of how we consider potential upgrades that are being rolled out in Ethereum. So the first thing that we consider is who is affected or what, and how. So for example, is it a consensus layer or an execution layer upgrade? Does it affect users, in our case stakers, node operators, or the protocol, or some mix of all three? And is the effect economic, technical, or operational, or again, some mix of all three? Is the upgrade itself important or urgent? So it might be urgent if it's security related, it might be urgent if it's breaking, it might be urgent if it adds like a feature that we desperately want, or something that's really, really important for the network. And so in some cases, you might have things that are important but not urgent, urgent but not important, and important and urgent at the same time, which is like most cases. And finally, what are the associated benefits and costs of both the changes itself, its consequences, and the work to effect, like basically to make the change come about. This is our upgrade process, like the steps that we follow. Again, actually a very simplified version. If I were to put the real thing on here, it'd be like 4 different slides. And I'm gonna go through it really quickly just to give you guys kind of like context of how we tie this together with those guiding questions. So first, we identify and we scope changes. We actually have a team, like our research team, that reviews EIPs, and their job is to figure out how might this affect Lido. Does it affect it at all? If we decide that it affects us and that's something that we should upgrade, then we design technical and operational specifications around how we're going to implement this upgrade. We do this via aligning product requirements and technical requirements. Then we do like an early vetting of what we propose to do here. We do this both with internal teams and we do it with external stakeholders like node operators or perhaps researchers at the Ethereum Foundation. Once we've done that, then we approve the technical and operational design, like a high level. It's not super high level, but it's more like an architecture design document. by the DAO. And once that's approved, then basically we think this is how much it's going to cost us, give us this money to go about making this upgrade happen. We start like designing the full technical details and preparing the implementation. So we do that in a manner that quite closely resembles what upgrades look like from a preparatory perspective for Ethereum. We have local devnets, then we have ephemeral, like short-lived devnets, then we have isolated testnets. Now, the canonical Lido testnet is on Kody. And so that's like the main testnet that we use for everything. It's almost like a QA environment for our mainnet instance, but we don't deploy most of the changes directly there. We might have first like a change in its own small isolated testnet where we fully control it, and then when it's time to finally mimic, like let's say mainnet, we would attach this to our canonical testnet, which is Lido on Kody, to enable full end-to-end testing with all of our different stakeholders. So that's users, that's node operators. Like we have hundreds of node operators running on Kody. We pay for Gnosis Safe to exist there, basically, because like it doesn't exist as an application apart from that. So we need to mimic like real mainnet infrastructure and make sure that everything works, from DAO votes to node operator onboarding and management, and of course like usage of the actual network. And then we prepare the release for mainnet. So this includes like deployment plans, testing scripts, a full test suite for upgrade functionality once it's actually landed on chain, and the actual vote on chain. So all of this comes together and basically results in protocol upgrades being multiple stages of an iterative nature of internal and external validation, testing, alignment, coordination, and execution. So shipping an upgrade to a protocol like Lido, which is decentralized and fully on-chain, resembles Ethereum governance like in a few ways, but obviously not in some others. And I want to establish those caveats first. So insofar as supporting new features is concerned, we are constrained by what the base layer actually ends up implementing. So what do we mean by that? A lot of times when we implement something from a technical perspective, we want to make it relatively simple. Simple things are harder to break, they're easier to reason about, and they're easier to do something or to fix if something breaks. From an app layer perspective, it actually constrains quite a bit what you can end up doing with this. An example on 7251 is we had this idea initially that we might have different caps for what the max effective balance of a validator might be, starting from 32 all the way to 2048, in multiples of 8 and different things like that. Eventually, this was done away with from a simplicity perspective. Like you will either have a thinny, I call them the 32th validators, or a fatty, the 2048 validators. I can say it because I'm overweight. And essentially, like, that's probably great from a protocol perspective. It means, from our perspective, that we're much more limited in the product decisions that we can make. So for example, if you're thinking about bonding requirements for a 2048 validator, it really constrains the design space. Secondly, we have less time to execute. So specs come together and get finalized for Ethereum, actually like pretty late in the process. Huge props though, like to the teams, especially in the last 2 or 3 hard forks. This has gotten a lot better, but I think like the 7251 spec like finalized like a couple of months before it was rolled out. So this means that for certain protocol upgrades, especially if they're urgent, it's very, very difficult for protocols to actually do this in step with a network, like launch the upgrade day 1 or day 0. And sometimes this actually ends up with you needing to do like a Band-Aid upgrade to make sure that things don't break in the interim period between when you can fully support it and when it goes live on the network. And third, obviously, like Lido is a DAO. There's an on-chain governance perspective here. Ethereum does not have on-chain governance for chain upgrades, but there are a bunch of networks that do. And the difference here is that the coordination that Ethereum does via kind of like soft governance and diplomacy and politics to a certain extent, we have to do via on-chain mechanisms. And while that may not be the best solution, it's probably the only practical solution on an app layer basis. So let's kind of examine, going back to EIP 7251, so the upgrade for MaxEB 2048 and consolidations, to kind of like distill this process through. What was the primary objective of 7251? To reduce the set of active validators in Ethereum consensus. So we're talking about number of validators, like technical units, not entities themselves, to make the network more efficient and to enable further scaling. So what are the pros? It improves the network footprint and efficiency. There's fewer validators to manage, and the ratio of like actual validators as technical units to entities running them goes down. Staking rewards can compound. Consolidations allow for things such as validator key rotation without needing to ride the full entry and exit queue. And validator top-ups may be more efficient operationally than multiple validator deposits. Now, there's like a bunch of other stuff, but for us, these were the main pros. From a cons perspective, it means the Ethereum protocol has to support yet another type of withdrawal credentials, so there's a serious amount of tech debt that you need to think about. And there's also intricacies in terms of how the different withdrawal credentials like work in the system and the different things that they can do. There's a really interesting thing that came up recently where basically you can use consolidations as a way to like quickly withdraw, and that is like kind of like weakening weak subjectivity, or I guess there's a debate about that or not, but anyway. And another one was, at least in the initial spec, was there's an increase in slashing risk, or rather slashing impact. So if a slashing were to happen due to what the minimum slashing value was when the spec was first written, it would actually be like really, really dire, but thankfully that was changed. And so huge props to like researchers and the EF and client teams for like hearing concerns around that. And of course, increased centralization pressures. So how do we take those pros and cons, like at a general level, and interpret them through the lens of like Lido? The primary objective for us is to basically help the network reach these goals of reducing network load, like being good citizens, increasing network efficiency, and adding new features to the protocol. For example, like key rotation, which is often asked for by node operators because maybe their key management practices change over time. Rewards compounding actually turns out not to be a big deal for Lido. And it's not a big deal because the protocol was already compounding. It was taking the skimmed rewards from the smaller validators and turning them into new validators. So there's only marginal increase here and only like a very, very large amount of validators. If you're a small to mid-sized operator, it actually turns out that it's better to run your validators in like 32 ETH type withdrawal credentials. And this has to do with like what I call like the tick rate of effective balance in Ethereum, which is basically how fast effective balance increases on a validator. Also props again to like research folks, they've acknowledged this, and there's already some ideas in the works about how to possibly improve this and make it more economically advantageous to consolidate. Most staking protocols, and this is really, really big one, were written with the assumption that a validator would have a maximum possible balance of 32 ETH. And there's a lot of work that has to happen from a core accounting changes perspective to change this, to allow protocols to either use both or to only use 2048. But when you think about what it takes to implement something like this, you eventually get to the realization that you have to allow for both, because there's no way to transfer all of the stake from 32 ETH-based validators to 2048-based validators overnight. In reality, both of these withdrawal credentials need to be supported. And OXO1 MaxiB is also much more manageable for small home stakers due to the bonding requirements that we were talking about earlier. So it's very likely that the Lido protocol, even in its future state, will need to have a mix of OXO2, which would be the majority of stake, and OXO1 for home stakers. Which means that we'd need to support modules. Like modules are kind of like proxies for specific sets of validators in Lido. So we have the curated module, which is permissioned, and CSM, which is permissionless, for example, to support probably either one or both of these withdrawal credentials. From a simplicity perspective, you want to support only one, and so that means having multiple versions of the modules if you want to be able to allow node operators to benefit from both. The reduced initial slashing penalty is actually great. It means that we can reduce the bonding requirements, which means that we can make staking more accessible to new node operators. From a consolidations perspective, blast radius management actually means that you end up running either the same or more amount of nodes. So what that means is that even though you can run more validators or like more ETH on a single validator client, because like the node ops requirements go down from a bandwidth perspective, you actually don't want to do that from a security perspective, because if something goes wrong with that specific validator client or that machine, then you have a higher risk of getting slashed. And so what you want to do is spread out the amount of ETH that you have per, like, let's say, instance or pod of stake, and maintain that amount of ETH. So if you were running, I don't know, let's say like 100 validators right now with 32 ETH on each of those validators, you want to run roughly the same amount of ETH again if you're keeping the same security practices, even though the validators will have a larger balance. Partial withdrawals and deposits may increase ops costs. This sounds a bit counterintuitive because it sounds like partial withdrawals are actually great, but what it turns out is if most of the network is consolidated, they will be used quite a lot, and they get very, very expensive the more that they're used. And then there's very high implementation complexity. So cost and overall low direct value return. What I mean by this is that because large protocols like Lido don't really affect from compounding, and because there's such large changes that are needed in like the base infrastructure of how the protocol works, there's not a lot of direct value to the protocol here. Most of the value actually comes from just supporting the network. So what does an upgrade like EIP 7251 cost? So there's over 6,000 man hours from a tech design and implementation perspective. Like this is just amount of people that are working, spending like, let's say, a couple of weeks on this to design the technical implementation, and including the amount of time taken. So this is like a bunch of months' work for 10 people, more or less. From $500,000 to $1 million in audit costs. Now, this is assuming you'd audit this thing in isolation, and we always have at least 2 audits for everything that goes onto mainnet. The audit cost can come down if you're bundling this with like other audit scope, but it's still like very, very important. Over 15 end-to-end test scenarios, and like each scenario basically has maybe like 30 tests inside it in terms of what we test with external stakeholders. So every curated node operator, when we go live with consolidations, will end up doing somewhere between like 20 to 30 end-to-end tests together with us. And 3 months of testing on an internal, external basis once we get to like devnets and testnets. So where does this leave us from like a closing thoughts perspective? Immutability is a really lofty goal, and it's something that we try to work with, but realistically, from a Lido perspective, there's only certain parts of the protocol that will probably become fully ossified. For the rest, we're trying to get those trust minimized as possible. So it means moving away from trusted oracles to like trust minimized oracles using ZkAttester technology, for example, or offloading some of the implicit trust to teams to more automated mechanisms. The industry generally underestimates the complexity and cost of keeping up with Ethereum. We get a lot of questions like, why has Lido not consolidated now? And the answer is it's pretty difficult. And it's very difficult if you want to do it right and make sure that like nothing gets messed up. This cost can and should be considered basically like a decentralization premium, and it applies to any fully on-chain and decentralized protocol. Like Lido isn't the only one. And the funny thing is like the cost is more or less static regardless of which protocol you are. So smaller protocols have a more difficult time in dealing with this. The alternative to this is basically like not having those costs and giving up kind of like competing in this industry. And this means that we end up with more centralized and tightly controlled service providers, like essentially running the safety of the network. The cost to maintain feature parity with a core protocol generally increase over time. It's because complexity and tech debt increases over time. And they're generally much more substantial for decentralized protocols than they are for centralized protocols. And lastly, there's quite a few similarities between the upgrade and governance processes of Ethereum and like large on-chain decentralized staking protocols. Thank you. And we're having an event on Friday, so if anybody wants to talk about this stuff or anything else, feel free to use the code here, SDK_GTHR, and we'd love to see you there. Thank you.
Perfect. Well, thank you very much, Izzy. We are kind of at time here, so I'm sure Izzy can take your questions afterwards here, but we have 2 more talks, and then, of course, the staking quiz. It was a lot of fun last time this was hosted for it. So, again, please, a round of applause for Izzy and the great presentation. Let me go ahead and introduce Øystein, who is with, of course, Obel. He's going to be talking about programmable staking, and I'm very interested in this topic here. So please welcome Øystein to the stage.
I need a clicky. Do you have the click? Hello. How are we doing, everybody? Nice. My name's Øystein. I'm CTO and co-founder at Obel, and I'm going to do you a slight mercy today and not spend all of my time talking about staking. I'm going to talk about the work we do underneath staking, and particularly our new product we're releasing called the Obel Stack. But before we get into it, I wanted to talk a little bit about what Ethereum is for. Most of you are in the space for quite a long time and remember when Ethereum was a world computer and it was here to disintermediate all of the men in the middle, and it was going to be something where it's not your keys, not your crypto. If you don't run your own node, it doesn't count. And that's what a lot of us kind of really believe in and why a lot of us run our own nodes. However, over the years that I've been in the space, things have kind of gone a bit away from that kind of goal. And the title of this talk is Self-Sovereignty and a World of Service Providers. And to give people a bit of an idea as to what that's like, I'm going to walk through an example of, one dApp transaction, pretty much the kind of hello world of using something in DeFi. So let's say you're using a decentralized application, and this is all an example. Don't take any one in particular for take too much heed of it. But first, you have your app. It loads from something like Cloudflare, Versal, GitHub, somewhere nice and centralized. Bad start. Then, if you want to pull any history, you are probably not running a full node, or a full node alone isn't enough. You need an archive node, but an archive node is not really enough. You also need this thing called an indexer, and most of the time it's very hard to run an indexer, so you end up using a centralized service who will run this indexer for you. And funnily enough, between making this slide and giving this presentation, Alchemy have decided to sunset their indexer, so my slide is already stale because of a centralized company. Bad start. Then you have your smart contracts. Smart contracts, decentralized, great, no editability, all good. However, they often need prices. Prices aren't usually available on chain, at least not if you want to run the risk of getting flash loan attacked. So you often need to use a third-party system, hopefully not a centralized one, that will put the price on chain for you. These are usually called oracles, and these are another person in the middle, give or take. Okay, so far, so not so great. Next, you want to connect your wallet. Your wallet also needs to talk to the blockchain. We are not where we really need to be in terms of light clients or running wallets in your browser. Most of them, or at least MetaMask, the most popular, relies on something like Infura. Infura is deciding, what the blockchain is and whether or not you can use it. So still not really going the direction you need. Second, last, Infura has prepared a transaction for you, click sign. It's not really safe to go and put it on chain through the mempool. You might get sandwich attacked, people might take your money off of you, so you need to go through another party to get safely on chain. You have things like Titan, you have things like Flashbots, some of them more decentralized than others, but still another intermediary. And last but not least, you've sent your transaction, you've used your DApp, all good, you go to Etherscan to figure out whether it actually happened or not. So this is not really what we like to see in terms of don't trust, verify. And this is what I mean when I'm talking about reclaiming self-sovereignty in a world of service providers. So I mentioned that this talk is about the OBOL stack, and I wanted to start with give an example of how the OBOL stack differs from what I just walked through before getting into the technical side. So I call the OBOL stack a self-sovereign interface for Ethereum. This is a way for you to use Ethereum as, our Lord and Savior Vitalik intended, where you run your own node and you run all your own infra. Firstly, it comes with a local interface. That interface shows you the health of your node, all of the usual, and it lets you change your wallet over to connect to your local RPC. Your local RPC is powered by the lovely team at ETHPandaOps, who build these things called Helm charts that allow you to install any Ethereum node of all of your different client types, and it can run in a light client, or it can run in a full node if you have the disk and the performance for it. One thing that is kind of unavoidable is the MEV aspect. You do not want to get sandwiched. So we work with the Blink Labs team as an order flow provider service, where any transaction you are sending goes through them, makes it on chain, and any MEV your transaction may give off can get reimbursed to you. And last but not least, you use your own local node for verification. You look at a local block explorer, see the transaction is there, and you don't leak your IP to Etherscan. An example of the UI is over here. This is still a bit work in progress, but this is kind of the idea of what I mean about the goal of a self-sovereign interface for Ethereum. Now, if that's the idea, what about the execution? Many of you have run your own nodes. Many of you have used launchers built by people in this room. And I wanted to give an analogy of my journey when it comes to setting up nodes through Raptor engines. These are the SpaceX rockets, version 1, version 2, version 3. So I've been running a validator for quite a long time. And when I first got set up, I did what kind of a lot of people did, which is set up some of these systemd services, maybe using a cron job, stuff like that. It works, but it can often be quite complex, particularly if you want to run lots of services and you want them to connect to each other. Maybe sometimes they break. Trying to figure out what's going wrong. You're running commands, trying to get into the logs and trying to search through them. You need to be relatively able to know what you're doing to manage it all. That has been quite painful. When the merge rolled around and I wanted to add Mev Boost because Mev was a thing, I was like, okay, I'm going to swap over and I'm going to use a thing called Docker Compose. Docker Compose is a way to run containers. Containers are like mini computers, so each of your different services can run on their own. They don't conflict with each other. They're not supposed to fight with ports. A little bit easier said than done, but that's kind of the idea, and it makes it a little easier. However, as the years went by, my Docker Compose got super messy, and I'd see new cool things I'd want to run, and I'd be a bit lazy, and I wouldn't really want to crack out this file and start to add in an extra container, figure out all the flags, figure out what I need to connect to, and all of the above. So things like AVSs, things like Layer 2s, I was like, I want to run these, but I don't really want to figure out how. So
The Obol stack is built on 2 new technologies, but my PowerPoint is not really working properly, but they're built on Kubernetes and Helm. Kubernetes, for those of you that don't know, is the software invented originally by Google, and it is what undergirds, it's what undergirds most of the internet around the world. So if you're running thousands of machines and you have hundreds of thousands of services on it, you need some orchestrator, as they call it, to run them all. This is particularly important if you have lots of different services. Maybe you have a database and an API and something to do with automation. You can kind of package all of these together, and you can wrap them up in a bow in a thing called Helm. Helm you can think of as like an app store framework for Kubernetes. You can just take one Helm chart and you can install it into your cluster. So the Obol stack is designed to be a foundation for everything. We want to grow the Ethereum economy. We first got started by securing the Ethereum economy with distributed validators, and now we're looking to grow it. We want all of you guys to be able to run extra Ethereum services on your own machines, not using some SaaS platform, and we've built the Obol stack to make that more doable. One of the key reasons that Kubernetes is really cool is it's very good at self-healing. When you set up an application that runs in Kubernetes, you set up what's called a health check. And this is how Kubernetes knows that your software is running and is happy. And it basically checks on you every few minutes and says, still good? And if your software says, yeah, all good, it keeps going. If you say, no, not good, or you stop answering, it kills you. And then maybe restarts you, and hopefully your machine gets going. One example of where this is useful, probably many of you have seen your beacon node or your consensus client lose peers. It drains to 0. You don't really find out. Your validator's offline. You fix it, and you have to resync for however long it took you to go fix it. With Kubernetes, it will start reporting is unhealthy, and after a few minutes of being unhealthy and not figuring out, it's like, okay, turn it off and back on again. Problem solved. So this self-healing capability is super important when it comes to making your life easy and running services without a lot of pain. Beyond that, the next step is to have a very nice base layer. And what I mean by that in this case is an L1. Everything we do and every software we run more or less all depends on an Ethereum L1 node. So when you set up the Obol stack, it'll either come with an Ethereum L1 Lite client or it'll come with an Ethereum L1 full node. As I mentioned, we use ETHPandaOps' Helm charts, so you can pretty much just pick any ELCL combi you want, and Paratosh and Barnabas has done the hard work of making that work for me. This is what you need to run L2s, sequencers, RPCs, indexers, dApps, pretty much you name it. So that's really what the Obol stack aims to do. We want to make it possible for you guys to be able to run your favorite L2, to run your favorite AVS, to add more stuff to your machine. And we want to make it such that it's pretty much a one-line install to do, set and forget. Kubernetes handles it. You have a little UI to check on it, maybe an Obol agent to keep an eye and help you debug anything that's going on. And if we can make that happen, and we can lower the friction of running apps, and we can lower the friction of releasing apps, meeting in the middle there is how we grow the Ethereum economy and how we get more people running stuff. The kind of prime example is today is hopefully the day that Aztec has undergone ignition, give or take. It was about 80 validators away from it earlier today. And we're partnering with Aztec to allow you to run a sequencer in the Obol stack. My goal is to turn it on beside my validator on the stack. I was kind of planning on having a demo now where I had a kind of laptop set up, but that didn't really work. So there's meant to be a video here, and I'm not sure whether it's going to play. Let's find out. No. Great. But what this video was going to show you is in the top left, you're installing the Obol stack in a one-liner. In the bottom left, it has a terminal interface called K9s, where you can watch it turn on all these applications. They go from red to blue, and they're all happy. And on the right-hand side, it was going to launch a user interface to show this all working. That's kind of the crux of the Obol stack and the kind of base framework we're looking to build. The kind of people we want for the Obol stack to serve is obviously the node operators. We want it to be useful for you guys, but also for anyone that's building infrastructure in the space, particularly dApp developers, layer 2s, people that are using rollups as a service. We want these people to be able to A, release apps to node operators, and B, get their own users running their own stuff. They shouldn't necessarily have to spend all of their money on Infura and on RPCs. They should be able to tweet out like, hey Dimitri, will you run my RPC? And Dima will be like, sure, I'm gonna install it, and we're off.
And that's kind of like the dream, and this is my talk. Thank you very much for listening to me about self-sovereignty and reclaiming it.
We do have time for questions for Wijden.
Nervous mumble.
No, nothing to worry about. What OBOL stack has to do with OBOL DVT?
So I might give you an example. I built kind of the OBOL stack for OBOL DVT. For those of you that ever used our software, we first shipped a Docker Compose. It comes with an execution layer, consensus layer, distributed validator, and a validator. And that kind of worked. And then all of a sudden, we wanted to be able to swap clients. Swapping clients is a bit of a mess. You're writing scripts that work with Docker Compose. They're kind of fighting with one another. And people also came along and said, I want to add more clusters. And to add more clusters to Docker Compose gets a bit funky. You have extra files. You try and hide those extra files with something called a makefile. And it was getting really mixed up between bash, make, Docker Compose. And I was like, oh, this is not what I want. I was like, how can I make this a one-line install to add more stuff? And my background is as a DevOps. I used to work with Kubernetes professionally when I was in Consensus. And I was like, well, if we had Kubernetes and Helm, this would be a one-line install. So I kind of built OBOL stack for myself, to be honest.
Okay, cool. Can anyone run like vanilla validator with OBOL stack?
Absolutely. Paratosh has also built validator client Helm charts. You could install it with a one line. That's the plan.
Okay.
Obviously, I think TVs are better, but you know.
Is it already there, or we need to add it manually?
The OBOL stack by default comes with the ETH-Panda Ops Helm chart repo and the OBOL Helm chart repo. So anything that Paratosh or we offer should be able to be installed, though this is alpha software and not everything may work as expected. And I would say I would be very welcome for some bug reports for certain things that don't behave straight out of the box.
Okay, and the final question, this beautiful UI that you've shown, is that a prototype or is that a thing that we already get?
The screenshot is a mock-up, but it is already there, and it actually looks prettier than the screenshot. You might have spotted that the Geth logo had a Nethermind icon, and there were some issues with that mock-up. But yeah, no, it's there, it's real. You install it. My video would have shown it for real, but yeah, it's there.
Cool, thank you.
I got this question from YouTube, from Tio. He's asking, what are the hardware requirements, I guess, besides like running the regular software?
Yeah, so this version of Kubernetes uses K3s, which is designed to run on like ARM chips. So this should probably run on a Raspberry Pi. The running of an Ethereum full node in Raspberry Pi gets a little interesting, but you can also run it with a light client, which depends on an upstream server to like serve you data. But a light client means that you can't get fooled. It checks the exact consensus layer to make sure you're served real data. So yeah, you can run this on, I don't want to say anything, but a very, very lightweight machine. Though it will be nicer if you have a bit of a bigger machine. You can run more L2s, more L1s, and do more things if you have common hardware. This is not really built for enterprise and professionals. This is kind of targeting home operator to SME type of people, basically the people in this room.
Awesome. So you had mentioned Aztec and a few other things. What about for teams that don't already have a Helm chart but want to get integrated? How difficult is that integration process?
Yeah. So that came to mind when we were talking to certain people. Not everyone comes from a DevOps background. Not everyone has Helm charts. So we released a Helm chart called the OBOL app. It is designed to just take any Docker image and run it for you. So you can just come along with the Docker container and say, hey, OBOL install, OBOL app, give it this URL, and it will just run your Docker image. We can go a little further and also run like Node.js apps and like kind of static front ends, but that's a bit of a work in progress. If you want that, come find me and ask nicely.
All right, excellent. Time for just one last question.
Hi there. You were saying it's intended for the home operator. So it's all for like on one node intention rather than clusters?
If you know what you're doing with Kubernetes, I would love to run them in multiple nodes, but I know that that's going to be a little buggy for people that don't use it, but yeah, one of our developers in-house runs a little Raspberry Pi Kubernetes cluster, and this thing is supposed to work straight out of the box on a local cluster, but your mileage may vary.
So is that, is that offering any isolation between the containers?
Just Kubernetes namespace-based isolation. You can control Kubernetes and really tie it down if you want, but yeah, by default it is your standard Kubernetes level of isolation.
Excellent. Okay, well that's time for it. So again, a big round of applause for Oishin. All right, our next speaker is Leo with Amiga Labs, and he's going to be talking about analyzing validators' performance in the present and in the future. So please, big round of applause here for Leo.
Thank you. So thank you for staying here. I know I'm the last obstacle between you and drinks and food, so I'm going to try to make this light. I'm Leo, founder and researcher at Amiga Labs. Basically what I want to talk today is a kind of a walk through the memory lane and talk about how staking has been evolving since Genesis until today. So the Genesis was on December 2020. At the moment, we had set penalties, the slashing penalties very low because we were just starting with the Beacon chain. One thing that we actually took into consideration from the very beginning was client diversity. From the very beginning of the work on the Beacon chain, we started developing multiple clients, and we care about that. So we at Amiga Labs developed this crawler to look at the client diversity on the peer-to-peer layer, but also at the geographical distribution of the nodes in the network. Then 1 year later, we had the first hard fork of the Beacon chain, Alter, and we had sync committees. So now we had another type of rewards, sync committee rewards. We increased the slashing penalties a little bit, and then we also started looking into the decentralization level across, all the validator entities in the Ethereum network. So a kind of similar figure to what was presented today by Hildobi, looking at, what is the amount of validators that each entity is running in the network. Then we had Bellatrix on 2022. And this was for the merge. So this is when we had finally consensus layer and execution layer coming together. And then for the very first time on the Beacon chain, you had execution layer rewards. At this moment, we also increased the slashing penalties to the level that we initially thought about. And so basically, when you had an effective balance of 32 Ether, you divide that by 32, and basically your initial slashing penalty will be about 1 Ether. Now, for the stakers, what changed was that, okay, you have, first of all, more data to transfer across the network, because now you have to transmit the execution payload in addition to the attestations that you had on the consensus layer before. And then with execution layer, you also had the arrival of MEV. MEV, changed significantly the game at the time. And then you had all these, proposer builder separation. Then you had, flashbots, and then you had the relays, which, by the way, the figures that you see here is we have been also tracking relays activity and the distribution of relays, and so on and so forth. We have been seeing that actually MEV has been decreasing in the sense that what validators get as MEV rewards has been decreasing over the last couple of years, since 2023 until 2025. But I'm not going to have the time to present this today. But maybe come to talk to me if you're interested on that later. Now, sometime later, we have in 2023 Capella, the Capella hard fork. And with this, we had the withdrawals. Now, this was very important for staking because it was the very first time where you could actually withdraw not only the rewards, but also your initial investment on staking on Ethereum, right? So this was finally closing the validator lifetime loop that it was open up until now. So then you had finally exits and withdrawals and so on and so forth. Now it's important to take into account that this was designed several years ago, And it was designed thinking about possible attacks in the peer-to-peer layer. What happens if there is a bunch of malicious validators trying to attack the network? And these were the scenarios that we were thinking about, but there are many things that have happened that we didn't think about. So to give you an example, what you see on the figure here is the number of days that you have to wait in order to get to finally exit your validators. For example, right now it's in the order of 35 days. So if you exit your validator right now, you will probably receive your funds by Christmas. Okay, so this is a huge, it's a huge wait, right? The red arrow that you see here, the small one, is because there was a centralized exchange that withdrew a significant amount of Ether from Aave, and then there was a liquidity shortage, and then there was a borrow spike, and then there was a lot of validators that exit at the same time, which is the first bump that you see in the figure. Several months later, there was hack in an API for Solana, right? In a Swissborg API. And because of that, the institution, the staking institution that was responsible for this API decided to, as a precautionary action, to withdraw all the validators from Ethereum network. And that's the huge red arrow that you see here, and that's the weight that we have to, that we see right now for exiting validators in Ethereum. Now, I remember the time we were envisioning, possible attacks for the exit queue. If I came up and say, well, you have to take into account the case of a hack in another chain that is completely separate from Ethereum and that impacting the exit queue of Ethereum, everybody will look at me like, you are crazy, this never happens, right? These are completely separate entities and there is no way they are correlated. Well, they are, right? And so it's interesting to see how the DeFi world and all these aspects actually correlate each other, and how mechanisms that we developed years ago are impacted today by things that we didn't envision. Now, in 2024, we had the NEP hard fork. With this came blobs. This was not a very impactful change for stakers, except for the fact that now you will consume more network bandwidth because you have to transmit blobs. So at the time, I think the average size of a block was about 100 kilobytes, more or less. And now you have to send multiple blobs, between 3 and 6 blobs, and each blob is about 128 kilobytes. So you multiply the bandwidth consumption by factor of 3 or 6, and then you have to add a little bit of peer-to-peer inefficiencies that duplicate data and so on and so forth. Now the figure that you see here is the number of blobs by different layer 2s and rollups. We also monitor that in our website. But again, there was not a significant change for the stakers, so I think this was a quite easy fork for most of the staking entities. Now we had Pectra at the beginning of this year, and with this we had consolidations. Now consolidations, as Easy just presented, are quite significant change for staking entities, right? So now you can increase the effective balance of the validators from 32 ETH to 2048 ETH by consolidating multiple validators into one. The figure that you see here is how much of consolidations we see per day over the last couple of months. And the color code is different entities that are consolidating. What we have seen so far is that the entities that are consolidating the most are whales. Not much large institutions or large liquidity pools, probably mostly because of the reasons that Easy just explained in his talk. It's not that easy to do. But we do expect to see more consolidations in the next few months and in the next year. And so it's important to keep monitoring this. Now, with Pectra, we also decrease the initial slashing penalty. Now we don't divide by 32, but by 4,096, which means that even if your consolidated validator with 2,000 ETH gets slashed, you don't get initial penalty of 1 ETH, but rather half ETH. Plus proportional slashing penalties and other stuff. So then we have Fusaka. This is the second hard fork of this year, which was already presented by Pari and the Panda Ops team. Now with PeerDAS, what we have is we usually, if you are running just a simple node, a full node, you reduce the amount of bandwidth that you need in order to custody the columns that you need to custody, because now you don't need to download the entire blobs, you only download part of it, right? So this should reduce the amount of network consumption, bandwidth consumption that you have for your validators. Now, through all these hard forks, not everything has been perfect. There has been significant issues and concerns. The image that I post here, there are some concerns that have been raised, and this is what you see here in the bottom of the slides. For example, on the way we access blobs for a rollup, we changed multiple things with Fusaka that is making the life easier for some of rollups. So this is something that we need to improve, and we expect that maybe with Glamsterdam on the future hard forks, we will be able to solve these issues. And this is just some of them. There is also fractional staking and so on. So there are some concerns, and this process is an evolving process, and we are trying to do better all the time. But it's important to keep in mind when these things happen so that we improve for the next time. Now, we also discussed this afternoon what happens when all these institutional funds come into Ethereum. Right now, we have about 35 million ETH at the stake, which is about 100 billion at today's price. And this comes with a staking APR of about 3%. So the question is, what happens if in 2026 we have another 50 billions coming into stake? Because we know that the APR curve goes down with the number of validators, or basically with the amount of ETH at the stake, right? So it's going to go down to 2.5. Is it going to go down to 2%? What is going to happen, right? And then the question is there a point where maybe putting my money on Aave or any other compound or a strategy, DeFi strategy, is going to make me more yield than staking, right? And if that happens, is that dangerous? So we look at that, and we look at one side of the coin is rewards. The other side of the coin is risks, right? So if you look at risks in the DeFi world, there are many. Just yesterday it was presented that there was about $15 billion in hacks since 2016. Just earlier this year in February, we had about 200 million in liquidations in just one single day. About a month ago, we had these 19 billion liquidations in just one weekend, which is, I think, the largest liquidation that has happened in crypto since the beginning. And then just a couple of weeks ago, we had the Balancer hack, which there was about 120 million that was lost in just one hack, right? And this was a smart contract that has been used for many years and has been audited, and so on and so forth. So these are quite important risks in the DeFi world. Now, what is the risk on the staking world? So for that, I want to play a game, because there is a quiz after this, so let's warm up. So how much has been lost in Ethereum slashing since Genesis? Option A, 156 million. Option B, 4.82 million. Option C, 37.1 million. Or option D, 0.75 million. So who says option A? One person. Who says option B? A few person. Option C. Okay. And option D? Okay, most of the room says option D. The answer is effectively option D. There is only 0.5 million has been lost in slashing. So let me break down that to you. There has been about 537 slash validators since Genesis. And you can see them in this figure organized by month and color-coded. So Genesis is in red, Alter is in orange, Bellatrix in yellow, and so on and so forth until today. Now, the big green bar that you see here was the largest correlated slashing that ever happened in Ethereum. There were over 100 validators that were slashed in a very short period of time. So then you not only have the initial slashing penalty, but you also have the correlation penalty to pay for it, right? And then the second, the blue bar that you see with the second red arrow is the first time and the only time where a consolidated validator has been slashed. There was a validator that had over 2,000 ETH at effective balance, and it was slashed. But because of the changes in slashing penalties, then he only lost about 0.5 ETH. Now, of course, during all this time, there has been very different prices, so it's very hard to calculate how much really was lost. And then there is also the fact that some of these losses were socialized across multiple operators, and then in many cases also the node operator actually covered the losses. So it's very tricky to say exactly how much was lost, but if you make the numbers, and we did, this is more or less the number that you will have as a result. So this, in comparison to the DeFi risks, this is nothing. This is orders of magnitude much more safe than anything else that you will find in DeFi. So I think kudos to all you node operators and stakers and researchers and client developers, because it's extremely safe to stake in Ethereum. Now, if we look at the future, and this is very dangerous to do, to try to predict the future, but I'm going to just talk a little bit about what is coming. We have EPBS coming, I don't know when, but let's suppose that it's going to happen next year. This is going to change how MEV works, and this is going to impact significantly stakers. We have also inclusion lists. So for example, right now there are some groups talking about pre-confirmations. Pre-confirmations are now possible thanks to the look ahead. But there are also people talking about reserving the entire block or multiple blocks in a row. But that's okay, but you have to take into account how that plays with inclusion lists, for example. If you are forced to include all the transactions that are in inclusion list, then you are not really reserving the entirety of the block, because you need to include these transactions, right? So there are certain things that we have to think about it. And then in the future, we also expect lean Ethereum. And today we had a presentation about how ZK technology might change attesting and proving in Ethereum. And so that also implies that maybe in the future, stakers will have a completely different hardware than what we use today. Maybe because attesting will be much, much faster and much easier, so maybe you can run 1,000 validators in a Raspberry Pi. But if you are a prover, then you probably need a cluster with 24 GPUs. And so it's unclear exactly how that will impact staking in Ethereum. So I guess what I'm trying to say here is that, from Genesis, we have been, evolving, and we expect this to continue. Basically, if you think about staking as a constant thing that doesn't change, it's actually the opposite. The only constant is the change. It has been changing from the beginning, and it will continue to change through the next years, up at some point where we think the protocol is where we want it to be. So this is the work that we do at Amiga Labs. If you are interested on getting more information about our work, we kind of sit in the middle between the core research and the staking institutions, and we try to bridge that gap between the two. So you have all the links here. And yeah, that's pretty much my talk. Thank you very much.
We do have time for 1 or 2 questions if there's anyone in the audience. I see here one in the back row.
Thanks. Just an observation regarding the risks of running validators. I would agree that on the surface, the slashing risk looks to be minuscule. But actually, I think the biggest risk of all is the supermajority bug risk, which is a very, very low probability in that it might happen. But if it does, the level of catastrophe is maximal. And I think that's actually often forgotten about in the discussion of the risk of running validators. So until we get to a point where maybe 40% of the network is running multi EL-CL combos, whether it's through the likes of Attestant, Vero, OBOL DVT or SSV DVT in some fashion, only then can we say that the risk of the supermajority bug will have been sufficiently mitigated. So that's a discussion I think that needs to come up, or a point that needs to be made in the discussion of the risk of running validators, which everybody here is aware of, and maybe sometimes we conveniently try to forget. Just a comment.
Yep, completely agree with that. And this is what is important to pay attention to client distribution and use vouch and all these kind of things. Absolutely agree with you.
Excellent. One more question.
Hey there. You mentioned you sit between the validator teams, Ethereum, and then the institutional stakers, right? Where do you see institutional staking going, and what are they looking for specifically? Is it like distributed validators, higher yield, more liquidity? If you could speak to that.
Okay. Yeah, so I think institutional stakers, at least in my opinion, what they are looking right now is, first of all, most of the institutional stakers that I talk with, they already have a very, very secure system in place where they are using multiple clients, they are focusing on geographical distribution, they are even focused on ISP distribution. So on that aspect, I think most of them, or at least with the one I talk with, they are very safe. Now, what they are looking right now is to explore different opportunities, like, for example, re-staking, looking into AVSs, what new services they can provide with the infrastructure that they are already running, right? And there are also options into mixing staking with DeFi, right? You can actually, because of the re-staking, you can actually now invest in new DeFi opportunities with the stake that you already have. So I think they are trying to mix this, and there are also some other way more risky strategies like looping and stuff like that, but that is just only for those that are, very risk tolerant.
Excellent. Well, Leo, thank you very much for just an excellent presentation.
Thank you.
All right, so there's one last activity. I think it's going to be a very fun activity. Two of the community leaders from ETH Staker, Nolan and Colfax, are going to present a ETH staking quiz. I believe they did something similar to this in Istanbul, I believe, that was done, and it was a lot of fun. So let's see what they have in store for us today. We'll probably take the one moment of pause here and just to say that afterwards there is going to be dinner and the tour of the museum, which I hear is excellent. But please make certain you take some time to thank the volunteers of ETH Staker that have put on the conference for it. You'll see them wearing the ETH Staker shirts throughout in the front desk there. So do make certain you give them some feedback on the day's events here for it. But with that, let me turn it over to the team here.
Okay, everybody. Thank you. My name's Nolan. I'm a member of the ETH Staker community, or team, I guess. Colfax, current member of ETH Staker. Who knows? Thank you very much for coming to our event and sticking it out to the end. Appreciate you. We are going to finish things off, hopefully, with a fun Kahoot quiz. So we call it a staking quiz, but there's also some Ethereum questions and just some silly questions. It's just for fun. Everyone can participate, so pull out your phone. You don't need to download an app. You don't need to make an account. You just go to kahoot.it. The people watching on the live stream, you can play along at home. There's going to be a little bit of a lag because of the streams. Nothing we can do, but we're having fun. And I guess we'll just sit around. I guess maybe a show of hands if people are in and happy. Lots of familiar names here.
Very exciting. What's the largest quiz we've ever run, Nolan? Do you know?
Like people-wise?
Yeah, participants.
I don't know. Probably like 60, 70 people. We're at 36, 37. I believe you will be able to join after we start as well, if you came in a bit late.
45.
All right. 46, 47. I don't know. Should we start? What do we think? Is anyone in the room still working on it? Good to go? All right, let's start. Oh, I should mention, the faster you answer, the more points you get. Where was the first Devconnect held?
Amsterdam, Bogota, Brussels, or Istanbul? I'll also mention, I think you do get penalized if you get the answer wrong, right?
I think you just don't get points.
Okay. Then you don't get the shout out for having a streak too. So.
Yeah. Okay.
Ooh.
Most people
Amsterdam's
knew.
the right answer, yeah.
Good start.
Show of hands, who was at that Devconnect in Amsterdam? Pretty good portion, like a third. All right.
Okay, LVD, K, Van, Buddha. You saw the questions. You're cheating, Buddha.
Buddha's disqualified.
Which VC firm did Vitalik used to work for?
Tiger Global, Fenbushi Capital, A16Z, or Lamboshi NGU Fund?
Also,
I was going to say Bitcoin Magazine.
Yeah, well, that's true too.
Fenbushi Capital.
Fenbushi Capital. Let's see, big shake up. Of course, Buddha got it correct. Of course, this makes perfect sense.
Buddha, I see you with the answer key on your other phone. You can't do that.
Where was Zuzulu City first?
Portugal, Slovenia, Morocco, or Montenegro?
Everyone, this was kind of a secret event at the time. We've only recently learned about it.
Yeah. Were you there, Nolan?
I can neither confirm nor deny.
Fair enough. Montenegro with 20, so at least 23 people in this room are there, I guess. LVD, keeping up the top.
Buddha's got the answers. He's still not winning. What tokens were earned during DeFi summer?
Food, arcade, bus, or car wash?
Okay, arcade tokens. Threw a few people off.
I would have said car wash.
Oh, Buddha dumped one there on purpose. Okay, Megan.eth. Hodled one.
Let's go. K is coming up.
How much ETH goes in a single validator now?
32, 1500, 32 to 2048, or 8. Negative something, yeah. Interpret it however you'd like. Yes.
Okay.
Fair amount of people knew that one. 32 to minus 2048.
All right, James Carnley showing up on the scoreboard.
Buddha's back. K is marching their way up. I like to see it.
Aggressively optimizing smart contract code is called what?
Gas bowling, gas golfing, gas shorting, or gas gassing? Nolan, do you know who coined this term?
I do not know. Okay. It would be nice if I did. It'd be a good factoid right now.
For next year's trivia.
To fill the time.
Yeah. Gas golfing. Do you know why they call it gas golfing, Nolan?
In golf, the lowest score wins. So same with gas. You want to use as little gas as possible.
Gas shorting's a good one, though. I see why a good amount of people thought that. Buddha must have voted for gas gassing.
Okay. How many high-severity vulnerabilities were found in the deposit CLI after eStaker had it audited in 2024?
0, 1, 2, or 3? 51 answers are in. The answer is 2.
Okay, not many people knew about this.
Yeah.
We
a lot of confidence in the deposit CLI, which there should be. But yeah, it's 2. Can you tell us anything about those, Nolan? Like, why? Should I be concerned as a home staker, I guess?
No, it's all sorted out now. There was a very specific issue where if you got the password to one encrypted key store, you could also guess the passwords of all the additional ones created in the same run. And then there was another even more esoteric issue. But they're both patched now. We're good. Everything's okay.
So I should not be worried as a home staker, nor do I need to do anything.
Yes.
Perfect.
Okay, Kate coming in to lead. And James. James is always a strong competitor. What was the name of the merged testnet?
Altana, Serenity, Kintsugi, or Altair? I see some confident looks in the crowd.
I heard I got it wrong too.
Kintsugi. Wow, a lot of people thought Altair. Does anybody know what Kintsugi actually means?
It's the
I don't think
it's
so.
the Japanese method of using gold to fix
like a broken
pottery.
piece of pottery. Yeah. It's pretty cool. We have a broken sponge holder pottery at home that I need to kintsugi when I get back.
Also, if you didn't know kintsugi, it's because everyone just called it the merge testnet. Nobody called it kintsugi. So, fair play for missing that one, guys. I mean,
I wonder if Buddha got it right. K drops from the throne.
Okay, here we go. Which DeFi protocol recently lost approximately $100 million to a hack?
Balancer, Curve, Uniswap, or Hyperliquid?
The last talk kind of covered this.
Yeah.
Okay, everyone
All right,
gets
everyone
that
knew
one.
that one.
Yeah. LVD. Who sponsored ETHStakers POAPs for 2025?
Gnosis, Optimism, Arbitrum, or Base?
If you open the POAP app really quickly, you can look at the little logo in the corner.
All right, pretty distributed answers there. But yeah, indeed, it was Arbitrum.
Yes, and thank you to Arbitrum. And for the year 2025, you'll notice all ETHStaker POAPs are hosted on Arbitrum. So shout out to Arbitrum.
Thanks, guys.
Oh, Megan.
Megan.
Okay.
But LVD is still at the top.
What color, according to him, was Patricio's favorite jacket?
Red, pink, terracotta, or salmon? These are some good questions, Nolan. Did you come up with them?
Actually, Sam Coffey came up with that one.
Nice.
Oh, okay.
Wow.
Yeah, it's a groaner.
It is terracotta, indeed. Salmon and red are fair guesses. So is pink. Wow.
Okay, we'll move on. That's a tough one. Oh, that really shakes up the order, too.
Wow. Wait, Nolan, is there a prize for this trivia show?
Bragging rights, obviously, the most important prize.
Perfect.
What is the Bitcoin 21 million cap?
Unchangeable, a meme, perfection, or the truth? Is this one multiple choice?
There we go. Good work, everybody.
A meme.
I think you guys all listened to Jérôme's talk on the issuance curve and security.
LVD knew that one. Buddha didn't, though.
If you had a RISC V or 5 CPU, which client would you use?
Teku, Grandine, Prism, or Nimbus?
This is a new development. We had to throw in a few tricky staking questions. Thank you to Torsten. This is a Torsten question.
The answer is Nimbus.
Okay, 2 more. Stacks on stacks coming in. Tony Macaroni, 5 in a row. Good work. What is fossil an abbreviation for?
Forced order flow, centralization, insurance layer, fork choice, inclusion list, fork organized crank, inclusion list, finality, overriding, cascade, and activity leak.
Good job, Colfax.
I was worried I wasn't going to get all those in the time. No one said I didn't actually have to read that one. Wow.
Wow,
Nice.
good,
People
good
are
work,
informed.
everybody.
Fork choice, inclusion list is the right answer.
I figured just the quantity of words would, people would read too quick.
James Carnley climbing up.
Okay, this is still the top 2. K could still win this. Final question. What is the maximum amount of blobs in BPO2?
10, 14, 15, or 21? Correct answer is 21, and that's the majority.
All right, let's see who won.
Coming in at third, James Carnley. Some amount of bragging rights. Then K. And our winner is LVD.
LVD, are you in the room? Hey, good work.
Yay, congratulations.
Oh, okay. All right, I guess that concludes the speaking portion of our event. Now it's open bar, food, and museum tour time. So thank you again, everyone, for coming out, and hope you all have a great night.
Yeah, thanks, everybody. And give it up to the eStaker team for putting this on.